Now, we have a total of 250 presentations throughout the entire week, not only here in the Thought Leaders Forum, but also in the MindSphere Lounge. Now, the MindSphere Lounge is a second area that we've built up, kind of hidden up in a cloud. We kind of built this spaceship-looking cloud structure right in the middle of the stand. You'll find 2 staircases that lead you up to the lounge, and there we'll also be presenting different topics, especially regarding MindSphere, in cooperation with some of our partners that already work with MindSphere. Now, besides this, I want everyone to check out the 3,500 square meters of space. This year, the stand is huge, covering everything from additive manufacturing over to pharmaceutical industries, food and beverage, but also energy for industry as some of the highlights. A total of 140 stations cover everything you need to know. So if anyone comes to the stand and says, hey, there was nothing interesting for me, then you weren't at the Siemens booth. Let's just put it that way. So looking at the clock, we're just about ready to get started with our first presentation. And this is all about electrification meets automation. And these are actually 2 separate areas that, thanks to digitalization, grow together to form one strong tool for more efficient production. That means on the one side, less energy use, and on the other side, faster processes. Let's talk about it a bit more in detail and welcome our experts. Here are Helmut Ketterer and Edwin Schizar. Welcome.
Thanks, Chris. And welcome, Edwin, my automation engineer.
Hi, Helmut, my electrician.
Welcome. Today we show you how you can benefit from a certified energy management system. So first, let's listen to our customer.
Hello? Yeah, Wolfgang Müller speaking. We have a problem. Yeah, we had an auditor in our production. He found out that last year our energy consumption was way too high. He said this was due to our old gift packaging machine. In addition to that, the machine failed quite often, so we would urgently need a new machine. Please find a solution. Yeah, thanks. Thanks, and talk to you soon.
Well, this customer is in a real tough spot, isn't he? And so are we. So, I mean, do you experience time pressure in your work? I think you are, right? So we have to update this machine in so few days before Mother's Day. The functionality of the machine is clear, it's defined. The physical layout, it's given. But Edwin, I think we can do something about the control cabinet, right?
So many of you may think now this is now the opportunity to grasp it, because we may now introduce some new innovations. What about more efficient drives, for example? Or since we also heard that energy management is a topic, what about software tools to help to look for example, energy waste?
Exactly, and there's one more thing. The customer was mentioning that the machine was failing quite frequently. So a common cause for that are issues with the power quality. We for sure should monitor power quality as well with the updated machine. On the other side, since the energetic footprint of the machine will be much lower, we have to reduce the fusing as well.
Now, everybody will ask, that sounds all great. However, do we really need now a completely new switching cabinet, control cabinet? Because that sounds difficult. Or maybe there are other alternatives.
Well, a prototype always is the basis of our work. But these days, we do that virtually. That means we are building a digital twin. So in the end, all we need for that, we have in our system. We have all the nice 3D data from Siemens, for example, so we can not only draw single line diagrams, as we are always used to do. No, we are building a virtual twin and doing the complete application in 3D, testing, simulating everything before we have to buy the real physical components and get the final machine ready to run. So, after I've done that, I let out the bill of material, and you, Edwin, could do something with that, right?
Since this bill of material is exactly that list which I need, because I can find there those new components, hardware and software, which I have to consider in my new automation program. And while you are redesigning the cabinet, I'm just reconfiguring the automation.
Yes, As an electrical engineer, I know that electrification is the basis of any automation. So that means we're using standard components, communication is ensured, data gets exchanged automatically.
So data exchange gives us great opportunities. Just have a look at TIA portal of Siemens, the totally integrated automation portal. Since there, we can, well, obtain perfect interplay of both worlds, electrification and automation components, just for example, because of the communication.
Absolutely. But the TIA portal is known, of course, in the automation world. But can I configure already all electrical components there as well?
Definitely. That all starts with a common communication network. With TIA portal, we can easily set up such a network, assign, for example, all IP addresses automatically. Later, we can set up a common visualization, SCADA system, again for both electrical and automation components.
Wow, that's big benefit. But isn't that too complicated for me as an electrical engineer?
Not any longer. In the past, you might have needed more tools to configure and run different products. But however, now it has all become obsolete thanks to TIA portal. One tool for everything.
Yeah, hello, this is Wolfgang Müller again. I forgot to mention that the new machine must be integrated in our energy management system. We need full energy transparency. Yeah, please consider that the new machine can't be more expensive. Yeah, thanks. Bye.
So, ladies and gentlemen, this is real life. While we are redesigning the cabinet, new requirements are coming up for our customer, which we have to consider in our planning phase. I, as an automation guy, am really happy that my electrician colleague has already selected the right components from the Siemens portfolio. For example, Simatic, TIA Portal, Centron, Dynamics, or Sirius. Since, thanks to digitalization, all these products can not only do their job, but they will provide all energy data for me. We heard it, energy consumption is a big topic. So I, as an electrician, as an automation guy, I'm really happy that I don't have to care about the energy data. They're all handled automatically by TIA Portal Energy Suite, for example. And in case, let's say, higher level energy management tools are in use, no problem of that. Again, thanks to digitalization, we can exchange the complete engineering very easily. And if our customer needs to add some new meters next year, in 2 years' time, some new energy meters, no problem. That all can be done without adjusting your cabinet design.
You saw it in our real-life example. The customer was coming really late in the process, giving us even a change order, which makes it more complicated. But with the tools of digitalization, were able to achieve the job. So now after updating the machine, I give out a new bill of material. It's the final one.
And I'm going to place this final bill of material in a Siemens mall to get all products, hardware, software, as well as electrical and automation products right in time. Because we want to give this machine, hand it over to our customer to start production and to stop wrapping the gifts. Don't forget it. Mother's Day is ahead of us. We need the presents there, which are more important than those for Christmas.
Yes, ladies and gentlemen, what you saw is a perfect interplay of electrification, automation, and digitalization. So that resulted in real great benefits of a safe, fast, very reliable process. We could achieve really in a short time an update of this machine. So I think our customers should be happy.
Yeah, hello, this is again Wolfgang Müller. Yeah, so I would like to thank you. The new machine is running very well. The energy consumption is much lower and we had no more failures. And thanks to the energy transparency, our employees were able to optimize the production process even further. So thanks again for realizing this so quickly and on a short notice. Bye-bye.
So, what did we do today? We managed to redesign, reconfigure a complete machine under time pressure, under time constraints. We also managed to implement the newest requirements on energy management at the same time. The operators of our customer are now able to run the machine right in time, to produce the gifts, to wrap them, and get the necessary information to run the machine even more efficiently. That all was possible because we could integrate all three core topics, digitalization, automation, and electrification, by means of TIA Portal in one environment.
Yes, and it goes even further than that. So what we showed you here on stage, you actually can see 126 meters from right here, over there on the Siemens stand, we have built this machine, so you can experience and see everything what you actually need in your applications on that Siemens stand. And even more advanced, we have integrated also here on the Siemens stand all this energy data already in MindSphere, our open IoT ecosystem. So we would like to invite you, please join us, and we show you how you can benefit in your applications. Thank you very much.
Thank you very much.
Mr. 1000 volts in machine building and automation guys. Thank you very much, Harald and Edwin. Any questions from your sides? No. Where can we find you guys at the booth? I mean, it's so big.
Absolutely.
You're at the energy cube, right over there.
126 meters this
Over there.
direction.
The big energy for industry cube.
Exactly. That's the first cube and you come from the other side. So please do not miss the chance to talk to those two experts and their colleagues. They are happy to tell you more about what they have been working on all year to present to you at the Hannover Fair and passionate about it. So thank you very much.
Thank you.
Well, ladies and gentlemen, I'm going to switch over into German language now because the next presentation will be held in German language. Und da geht es um Netzbewertung und Störungsprävention, aber wir warten noch ein bisschen, weil wir nämlich, und das ist eine wichtige Information für Sie alle, live streamen. Das heißt, wir sind hier wie im Fernsehen. Und der nächste Vortrag beginnt um 9:15 Uhr. Und bis dahin können Sie ein bisschen im Programm schmökern. Das sind die Heftchen, die ausliegen, was heute so alles auf dem Programm steht. Es geht natürlich um Energie, Energie für die Industrie, die wir heute stark in den Fokus stellen mit interessanten Gesprächsteilnehmern, Präsentationen. Wir haben unseren Vorstand Energie, Cedric Neike, den Vorstand von E.ON, Dr. Wildberger, als auch von Gestamp, Pablo de Moura Figuera, hier bei uns vor Ort. Und 3:15 geht's los. Ich würde sagen, wir spielen jetzt mal kurz den Energy-Trailer ein und gucken mal, was denn so wichtig ist, wenn es um Energiethemen geht.
The production line you see behind me produces an amazing amount of units per day. And it does this by using an incredible amount of energy, something we take for granted. But without power, nothing happens. Nothing can be produced. And that means the stores stay empty. And that means you would be missing your favorite product. So how can we assure a consistent power supply throughout, individually, but also as an industry? Find out how at the Siemens booth and in the Thought Leaders Forum at the Hannover Messe in Hall 9.
Thought Leaders Forum, Halle 9, alles richtig gemacht. Sie sind da, da freuen wir uns. Und ja, wir haben tolle Themen. Wir haben die MindSphere Lounge hier erstmalig auf unserem Messestand. Das ist im Zentrum unseres Messestands, im Herzstück. Geht es die Treppe hoch und da gehen Sie in den Datenhimmel. Da wird Ihnen gezeigt mit unseren Partnern, die auch hier vor Ort sind, wie Sie Daten sinnvoll nutzen können. Gestern gab es eine Information, 5,5, ich weiß gar nicht wie viel Millionen Geräte waren hier angeschlossen auf dem Messegelände und haben Daten transportiert. Was wird damit gemacht? Das und mehr können Sie in der MindSphere Lounge erfahren, damit Sie viel, viel mehr aus den Daten, die Ihre Maschinen und Geräte generieren, nutzen können. Zusätzlich haben wir hier ganz interessante Cubes auf dem Messestand, unsere Highlight Cubes. Energy for Industry, da gehen wir nachher noch mal ein bisschen mehr drauf ein. Pharma for Industry, also auch hier Lösungen aus der Pharmaindustrie. Additive Manufacturing, großes Thema. Sie haben es vielleicht der Presse entnommen. Die Kanzlerin war bei uns traditionell auf ihrem Rundgang auch auf unserem Stand, dem größten der Hannover Messe mit. Was schätzen Sie, wie viel Quadratmeter Fläche haben wir hier? mehrere Fußballfelder, würde ich sagen. 3.500 Quadratmeter Standfläche, vollgepackt mit Lösungen, Innovationen und wunderschönen Exponaten. Additive Manufacturing, also der 3D-Druck, auch hier sind wir ganz stark mit Partnern aktiv und bieten Lösungen, auch Maschinen- und Automatisierungsbau, um hier entsprechend bei dieser Technologie mit dabei zu sein. Ja, Digitalisierung, großes Thema. Discover the value of the digital enterprise. Deshalb sind wir auch hier, um Ihnen genau diese Lösungen zu zeigen, die Digitalisierung mit sich bringt. Nicht eine Herausforderung, es ist eine Chance, eine Riesenchance, genau das bei der Industrie 4.0 zu nutzen, was an Möglichkeiten gegeben ist. Hat der Föhn funktioniert bei euch heute Morgen im Hotel? Ich hatte da ein bisschen Probleme. War nämlich das Kabel war nicht so ganz in Ordnung. Sprich, ich hatte da so einen Wackler. Da kann man ganz schön ins Straucheln geraten, wenn das nicht passiert, was man eigentlich für eine Grundvoraussetzung hält, nämlich aufs Knöpfchen drücken und es funktioniert. Und zwar funktioniert die ganze Zeit und nicht an, aus, an, aus, an, aus. Und gerade in der Produktion ist es ein immens wichtiges Thema, dass die Qualität des Stroms und die zur Verfügungstellung des Stroms gewährleistet ist. Denn ansonsten Stopp in der Produktion, keine Produktion, die ich gut durchlaufen lassen kann. Und das ist ein sehr, sehr wichtiges Thema. Wir schauen uns nochmal den Energy Trailer an. Das Video ab, bitte.
The production line you see behind me produces an amazing amount of units per day. And it does this by using an incredible amount of energy, something we take for granted. But without power, nothing happens. Nothing can be produced. And that means the stores stay empty, and that means you would be missing your favorite product. So how can we assure a consistent power supply throughout, individually, but also as an industry? Find out how at the Siemens booth and in the Thought Leaders Forum at the Hannover Messe in Hall 9.
Frau hat es angeteased hier. Ich habe aber jetzt einen Experten, der sich richtig mit dem Thema beschäftigt hat. Meinen Kollegen Dr. Christian Blug aus der Energy Management Division. Und den begrüße ich jetzt ganz herzlich hier auf der Bühne. Herr Dr. Blug, die Bühne gehört Ihnen jetzt. Auf geht's.
Gut, vielen Dank. Jetzt haben wir in der Industrie keine Föhne, aber wir haben Ventilatoren und die sind genauso sensibel, reagieren genauso sensibel auf Spannungsqualitätsschwankungen und genau das ist eigentlich mein Thema. Wir wollen Störungsprävention, Lösungen wollen wir anbieten durch Beobachtung der Power Quality. Warum ist die Power Quality so wichtig? Weil wir in der Industrie keine Störungen haben wollen. Wir wollen keine, das war eine Störung, wir wollen keine Ausfälle haben und wir wollen natürlich keine Schäden haben. Und ein ganz wichtiger Indikator für solche Dinge ist die Power Quality oder auf Deutsch die Spannungsqualität, weil die Spannung beobachten wir und leiten daraus ab, was können wir machen. Und genau das wollen wir machen. Wir wollen gar nicht zu Schäden kommen, sondern wir wollen sie vorher erkennen und dann entsprechend schnell Gegenmaßnahmen einleiten. Und da stellt sich gleich die Frage, welche Geräte brauchen wir dazu und welche Tools brauchen wir dazu? Und diese Frage kommt nicht von ungefähr. Sie müssen wissen, ich bin ein Consultant, also ein Berater und arbeite bei der PTI in Siemens, das ist Power Technologies International, das ist also eine Beratungsabteilung. Wir machen also bei Siemens nicht nur diese tollen Produkte, die Sie jetzt hier auf den Ständen bewundern dürfen, sondern wir liefern auch Beratungsdienstleistungen rund um Ihre elektrische Energieversorgung. Und da haben wir 3 Säulen. Das eine ist eher die High-Level-Säule Energy Business Advisory. Da kümmern wir uns um Unternehmenstransformationen, um Effizienzsteigerung, um wirtschaftliche Effizienz der Unternehmen. Auf der anderen Seite, auf der mehr technischen Seite, und da fühle ich mich zu Hause, kümmern wir uns um die Performance der Netze und dazu brauchen wir Werkzeuge. Die machen wir in unserem Zweig Software Solutions, wo wir Werkzeuge für die Netzplanung, für die Analyse entwickeln. Und genau diese Werkzeuge setze ich als Consultant in meiner täglichen Arbeit ein. Und leider ist meine tägliche Arbeit natürlich die Störungsklärung. Dazu setzen wir stationäre Berechnungen ein. Stationäre Berechnungen beziehen sich auf Felder, wo wir langsam veränderliche Parameter haben. Aber ganz wesentlich sind natürlich auch dynamische und transiente Berechnungen. Da kümmern wir uns um sehr schnelle Ereignisse. Und diese Ereignisse, die sind eigentlich sehr gute Indikatoren für sich anbahnende Fehler. Und diese Fehler sind gerade für Sie als Industrienetzbetreiber natürlich sehr relevant, weil Sie einen hochzuverlässigen Betrieb haben wollen. Und Sie stehen vor verschiedenen Herausforderungen, zum Beispiel die Energiewende und die damit einhergehenden wirtschaftlichen Rahmenbedingungen zwingen Sie dazu, auch zu reagieren in der Netzstruktur Ihres Netzes. Zum Beispiel, indem Sie Ihren Blindleistungsbezug optimieren oder reduzieren, um Netzverluste einzusparen. Um so etwas zu machen, müssen Sie natürlich auch effiziente Antriebe haben. Effiziente Antriebe, die sehen wir also hier auch auf dem Stand, sind oft mit leistungselektronischen Komponenten ausgestattet. Leistungselektronische Komponenten erzeugen Oberschwingungen, harmonische. Und zusätzlich sind diese Komponenten auch sehr empfindlich gegen transiente Störungen. Und da kommen wir zu meinem Geschäft. Wir wollen eigentlich diese transienten Störungen nicht haben. Und wenn sie dann tatsächlich auftreten, wollen wir zumindest mal die Auswirkungen vermeiden, weil diese Geräte sehr sensibel darauf reagieren. Dazu werden zum Beispiel Filter eingebaut, aber das reicht nicht. Wir müssen auch Geräte haben, die diese Transienten auflösen können. Wir müssen Geräte haben, die diese auch verzerrungsfrei übertragen können. All diese Geräte sehen wir heute auf der Hannover Messe. Zum Beispiel den Siemens Q200, dieses hochauflösende Messgerät für Transienten oder die Breitbandwandler, die also in einem großen Bereich die Spannungssignale verzerrungsfrei übertragen. Und wenn wir dann diese Daten haben, brauchen wir auch Werkzeuge, mit denen wir diese Analysen durchführen, um halt eine entsprechende Versorgungszuverlässigkeit zu erzielen. Und warum sage ich das? Wir haben ja in der Vergangenheit eine Menge von Untersuchungen durchgeführt, eine Menge von Störungen analysiert. Und wir haben erkannt, dass mit den Geräten, mit den Power-Quality-Rekordern, die heute in Ihren Firmen oder in Ihren Unternehmen eingesetzt werden, dass wir da eigentlich nur in 20% der Fälle überhaupt die Chance gehabt hätten, eine Störung frühzeitig zu erkennen und Gegenmaßnahmen zu ergreifen. Das liegt einfach daran, dass diese Geräte in ihrem Frequenzbereich, in ihrem Auflösungsvermögen begrenzt sind. Aber zum Beispiel dieses Siemens Q200, das ich eben schon erwähnt habe, das ermöglicht es, weit größere Frequenzbereiche abzudecken. Und dann sind wir genau in dem Bereich, der uns interessiert. Sie sehen es hier auf der Folie, den Transientenbereich. Das sind kurze Ereignisse, die sich bei hohen Frequenzen abspielen. Und genau an denen sind wir interessiert. Und jetzt, wo wir diese Werkzeuge, diese Messgeräte haben, können wir auch unsere Analysen auf eine ganz andere Ebene heben. Wir haben eine Menge von historischen Aufzeichnungen. In der Vergangenheit sind wir immer mit mobilen Geräten in die Anlagen gegangen, haben gemessen, diese Aufzeichnungen gespeichert und damit Verknüpfungen zu gewissen Störungen gemacht. Diese historischen Aufzeichnungen, die transferieren wir jetzt in unsere Power Quality Monitoring Datenbank, sodass wir später über Mustererkennung ein Muster einem in der Vergangenheit schon mal aufgetretenen Event zuordnen können. Das ist die eine Sache. Die andere Geschichte ist die, wir können auch solche Muster synthetisch erzeugen, indem wir unsere leistungsfähigen Simulationswerkzeuge einsetzen, die also elektromagnetische Transienten erzeugen können. Auch diese Muster spielen wir in diese Datenbank rein und stehen zur Verfügung für die Mustererkennung. Und jetzt, da wir auch diese modernen Messgeräte zur Verfügung haben, können wir selbstverständlich auch die Messwerte aus den lokalen Messungen verwenden, um halt Analysen durchzuführen. Und das nennen wir Digitalisierung in unserem Kontext. Das ist die Transformation von unserem Wissen, von unserem Erfahrungsschatz in Daten, die wir in der Datenbank abgespeichert haben. Das ist aber nur die halbe Miete, oder ich würde mal sagen die Drittelmiete, weil mit diesen Daten, die müssen ja irgendwo hin. Und wenn wir hochauflösend messen, haben wir entsprechend großen Datenumfang. Das muss irgendwo gespeichert werden. Und wir stehen eigentlich immer vor dem Problem, wo machen wir das? Und wir finden hier die Lösung mit der Mainz 4. Das ist eine typische Anwendung für die Cloud. Wir haben einen sehr großen Speicherbereich zur Verfügung und wir haben den transparent zur Verfügung. Das ist super. Aber wir müssen mit den Daten auch was anfangen. Und da kommen wir dann also zu den Weiterverarbeitungsverfahren, Signalanalyseverfahren, Korrelationsanalyseverfahren, Mustererkennung. Das hört sich alles kompliziert an, ist es teilweise auch, aber vor allem braucht es Rechenzeit. Und wenn wir viele Messstellen haben, wenn wir viele Muster haben, brauchen wir viel Rechenzeit. Und wer bietet uns diese Rechenzeit? Ist schon wieder die Cloud. Und das macht das Ganze für uns als Consultants so attraktiv, weil wir jetzt die Infrastruktur haben, um genau diese anspruchsvollen Analysen durchzuführen. Insofern sind wir happy, dass wir jetzt die Mainz 4 Cloud-Lösung von Siemens wir als Consultants zur Verfügung haben. Und die dritte Komponente hatten wir schon immer. Das war die Simulation. Heißt in diesem Kontext der Digital Twin. Was macht der Digital Twin? Der hilft uns jetzt, die Reaktion des Systems auf Änderungen zu untersuchen im Vorfeld. Unsere Messungen liefern nur ein Abbild der Realität. Wir wollen aber wissen, was passiert, wenn man an bestimmten Eingangsparametern dreht. Und dazu haben wir im Digital Twin als eine Kernkomponente unsere Netzberechnungssuite, die PSS Suite, die uns also Netzmodelle liefert, die wir mit unseren Messungen adaptiv anpassen können, die uns die leistungsfähigen Analyseverfahren liefert und die uns dann natürlich erlaubt, mit numerischen Verfahren die entsprechende Bewertung der Spannungsqualität durchzuführen. Und somit sind wir dann in der Lage, Reaktionen des Systems auf Änderungen zu untersuchen und dann, bevor vielleicht eine Störung auftritt, entsprechende planerische Maßnahmen einzugreifen. Zum Beispiel ein Filterdesign oder richtige Filter auszulegen. Sodass sich jetzt unser Prozess als Consultants im Rahmen des Power Quality Monitoring so darstellt. Wir haben jetzt, Gott sei Dank, die entsprechenden Messgeräte, hochauflösenden Power Quality Messgeräte. Wir haben die Breitbandwandler. Und, was auch sehr wichtig ist, wir haben die Kommunikationskanäle. Bisher oder früher mussten wir immer in die Anlage fahren, unsere mobilen Geräte aufbauen, Kurzzeit-, Langzeitmessungen durchführen und dann wieder abbauen. Heute haben wir durch die Kommunikationsinfrastruktur die Möglichkeit, diese Werte remote und auch permanent abzufragen und damit auch die Spannungsqualität permanent zu überwachen und mit unserem Wissen abzugleichen. Dafür müssen wir einen Preis bezahlen. Das ist die Speicherkapazität und die Rechenkapazität. Ich habe Ihnen aber gesagt, wir haben jetzt die Lösung. Und sehr viele Stände hier bei Siemens setzen auf diese Mainz 4 Lösung auf. Also ist dieses Problem auch gelöst. Und nun können wir uns eigentlich auf den kreativen Teil unserer Arbeit fokussieren. Das ist nämlich die Planung, das ist die Simulation, das ist die Ableitung von Verbesserungsmaßnahmen auf der Basis der Erkenntnis, die wir durch das Power Quality Monitoring gewonnen haben. Und damit komme ich eigentlich schon zum Ende meines Vortrags. Ich möchte da kurz eine Zusammenfassung geben. Für uns als Planer, die wir auch öffentliche Netze planen, auch in der Hochspannung tätig sind, war zunächst mal Industrie 4.0 ein Fremdwort. Als wir aber dann darüber nachgedacht haben, wie können wir diese Infrastruktur, die Industrie 4.0 bietet, einsetzen, da haben wir gesehen, das sind ja ganz neue Möglichkeiten für uns als Planer, Consultants, um entsprechend Analysen und Verbesserungen zu erzielen. Die Geräte gibt es, die Power Quality Recorder. Die erzeugen zwar große Mengen, aber mit einer super Qualität, die wir natürlich gerne ausnutzen wollen. Wir können damit große Bereiche von harmonischen und transienten Ereignissen erfassen. Und genau das setzt uns in die Lage, eine effektive Früherkennung von sich anbahnenden Schäden durchzuführen, sodass man sagen kann, dieser Dreiklang Digitalisierung, Cloud und Digital Twin hebt unser Geschäft auf eine andere Ebene und Ihre Zuverlässigkeit, die Zuverlässigkeit Ihres Betriebs hoffentlich auch. Und wenn wir das vertiefen wollen, können wir uns gern an unserer Station 20 noch im Detail darüber unterhalten. Da habe ich auch eine kleine Vorführung vorbereitet, wo Sie dann einen Eindruck bekommen können, wie wir uns das Ganze vorstellen. Ansonsten bedanke ich mich für Ihre Aufmerksamkeit und wünsche Ihnen noch eine tolle Hannover Messe. Vielen Dank.
Let's move on, ladies and gentlemen, in English. And we'd like to introduce to you our electricity and energy special session, which will take place now at 10 o'clock. And we've invited 3 experts in the field to talk about this. We're going to be starting off with 3 keynotes, and then we'll go into a panel discussion. And if we talk about electricity, electricity is becoming an ever increasingly important energy carrier. Now, at the same time, energy systems are changing at a rapid speed. We've all heard about climate goals. We've all heard about energy-saving initiatives, about solar and wind power. And household and industrial companies are seeking to produce their own power, of course, to use it in a better way, but also with the aim to reduce costs and to make this world a better place. Now, digitalization plays a major role in this. And sensors, computers, but also communication technologies are now found in almost everything, from appliances for the home, but also to the most complex power systems, which you can also find here at Siemens right at our booth. And while I'm at it, I'd like to invite everybody standing outside now to just come inside. We still have a few free seats left on this side, but also on this side to fill it up. So just come inside if you wish. Now, also digitalization also creates growing consumer demand, though, for improved service and ever more convenient access. Technologies such as cloud, thinking of MindSphere, for example, digital simulation, data analytics, automation, and the Internet of Things, all driven by potentially expanding computing power, are bringing new opportunities, new challenges, and new threats. So who did we invite today? In this very exciting session this morning, we're going to entice you to explore this world full of opportunities and to look at it from 3 different but close-knit angles. Now, the perspective of a global technology powerhouse, which is Siemens, then the perspective of one of the world's largest investor-owned electric utility service providers, namely E.ON, and finally, Gestamp, an international top manufacturer of automotive components. And starting it off, I'd like to welcome, with a big round of applause, member of the managing board of Siemens AG. Please welcome Cedric Neike. Welcome.
Wow. Welcome to the Siemens stand. And it's news the first time I've been at the Hannover Fair. It's my 3rd week in the role as managing board, and I have Carsten and Pablo joining me. And the interesting part, we're going to talk about energy. I think Carsten is from the telco industry and Pablo is an IT specialist, so we're absolutely qualified. And I worked 17 years at Cisco before to talk to you about energy. But we will do this because it's probably my responsibility as a managing board member is the energy management, and it's probably the most exciting sector which is going on at the moment. So we're going to take you through it. We're going to go quickly on presenting us 3 the elements, and then we're going to go to the Q&A. Now, what's interesting to understand, and I said that this industry is in complete disruption, and it's important to understand that I joined 3 weeks ago, and I came from the telco industry. And what you have to understand in the telco industry, my world was 17 years ago, you had the internet, which took data, which was centralized and decentralized it. You had mobile phones with smartphone, which decentralized this data even more. And Industry 4.0 and Internet of Things has really sort of put it out. So you really had something which was centralized, decentralized massively, and changing complete industries. Now, if I look at the energy industry also at the same time, same thing, very centralized. You had coal plants, you had classical oil plants. We went to even more centralization if we go forward with nuclear. We went to gas, but then solar came, wind came, decentralized energy system came. So the 2 things is, if you look at Germany, in the 90s, we had 1,000 power plants, 1,000 power plants for Germany. We now have 1.5 million prosumers which produce and consume energy at the same time. So within 20 years, the energy market has completely changed. So if you look at the IT world, which completely changed, if you look at the energy world, which completely changed, the big question we're going to try to answer today, what does it mean for all of you? What does it mean for the industry? What does it mean for DSOs? What does it mean for TSOs? Because the reality is we're going to produce so much data with this decentralization, and we need to react on it, that we need to find the answers. And trust me, from the telco industry, I learned that if you do not go proactively into such a disruption, you're going to be disrupted yourself. Now, what does it mean? Is that the essence of how we look at energy is not to make sure that it just produces something or that you have access to it. It's going to be a source of data. It's going to be absolutely a source of data. If you look at Michael Dell, he says the oil or the energy of the 21st century is going to be data itself. If we look at the energy sector, data is going to be the key asset to take this super complexity which we generate with having 1.5 million which start producing and consuming energy and rebuilding it back together. So decentralization creates complexity, and data will bring it back together to be able to sort of put it forward. So that's an important sort of aspect of things. And if I look at all of you, there's three types of customers we have. We have the traditional TSOs, the transportation system operator, you have the DSOs, and you have the industry, everybody which is here at the moment. The three problems we have are very different. If you're a TSO, and now you basically have to make sure that with all the wind energy, with all the solar energy, you produce at an absolute stable level this capacity. That's the main thing. Stability is really what you're going for. If you're a DSO, and Carsten is going to come up and talk about it, if you're a DSO, you have a different issue. You have an issue that all of your consumers are also producers, and you need to connect with them. You need to create transparency. So the first one is really about stability. The second one is about transparency. If you're an industry, you have a different issue. You want reliability. You now have access to a lot of energy sources. The prices, if you're in Europe, are much higher than if you're in the US or if you're in Asia. You need to be able to take energy as something you can sort of compete with. So what has happened? You have an industry which was centralized, which got completely decentralized. You have the capability to bring it back together using the data you have to solve very different problems. To either solve the problems of stability, to either solve the problem of transparency, or either solve the problems of competitiveness. And we at Siemens, and we talked about it, and just for you to start sort of thinking about it, the first thing we've done is, in my industry, in my old industry, it was called software-defined networking. The idea is that software and hardware in the energy industry is still combined. In the reality, it's going to be sort of separated. In the reality, what we're doing, we're working with the University of Marburg in Ilmenau to really connect the two and build really what we call the grid control center of the future. So you take the brain, and instead of having sort of a central distribution, you dynamically understand what are the changes, what are the wind changes, what is the solar change, what is the production changes, and dynamically sort of start configuring these transmission systems to be much more dynamic than it used to be. So you're making out of an energy system which was centralized and sort of planned with a couple of very good mathematicians to a super dynamic environment where you build a brain which constantly controls it. So that's the first change you have. The second change, and I'm not going to talk for Carsten into more details, is the idea that I now have these millions of users, and I think there's even a necessity to over, I think, 6,000 kilowatts to be able to produce, to be able to meter, is how do I build transparency? And we're working together with E.ON to build, using the MindSphere product or the Energy IP product, to understand each one of those productions and be able to build transparency into the system. So I said the first problem you have is you need to have stability. We do it by putting a brain and dynamically adapt it. The second one is transparency. We work with E.ON to put as much as possible understanding of the different networks and building them back together. The third element is if you are an industry, the main issue you have is to say, how do I have access to reliable energy? How do I have access to cheap energy? How do I have access to these sort of, in a decentralized, should I even become a producer of my own energy? I don't know, and Pablo needs to answer that question. And what we've done is to say, okay, if we could give you the brains to understand on how to optimize your energy production, you can do all of those things. So we work together with Gestamp, and I think, Pablo, you're going to talk about it, on a cloud-based energy system where we basically connected the 14 plants of Gestamp, which is basically really big press. They're basically forming metal, taking the data and optimizing it so that they saved 15% sort of energy cost. But they're going to do much more, and I'm not going to take the line from Pablo here. So you have to understand, the world's become more complex. We have to live with that. We take IT systems to bring this intelligence back together to do three things. One, to make sure that we are safe, that we can build sort of the capability to transport this energy safe. We make sure that every prosumer has access to this information, and we make sure that the stability and the intelligence is there to actually save money for the industry. So how do we do this? This is our view of the world. In order to do this, you will have to connect every element of this chain, what we call digital and enhanced automation, either with new products or doing sort of backwards compatibility. All the network elements which didn't used to talk, all the transformers, all the elements of the energy chain now need to basically say, this is who I am, this is what I see, this is what I can do. So you make this energy systems communicate to you. The same way we have in other rooms, the same ways we make each robot, each industrial environment talk. The same way we do that every sort of city starts to have the capability to do it. We produce data, so that's the first thing. The second element we do is we build basically what we call an operating system. So the capability to take this data and share it across multiple environments so that we can build outcomes or application on top of it. And the idea of MindSphere is that we as Siemens will help you make those devices intelligent which you have, to build this operating system to be able to connect them with each other, and then build application around it. So you can start, and the idea, and that's the big advantage is, you could start, for example, in Gestamp, to understand where's my energy consumption coming from. You can then link it with an outlook saying energy will be very cheap because there's going to be a lot of sun in Spain at the moment, and you can then sort of optimize the production facility, which is in the production environment, to really take this cost advantage. So you start having each one of the elements talk to each other. The fundamental value of a network is how many elements are added to this network. The more elements we add to the network, the more value we can create. And that's really sort of where we need to sort of go and where we need to understand on where the world goes. The world of digitalization and the world of energy are coming together because this huge decentralization, this huge amount of energy produces the necessity for us to work on this. But it also creates opportunity when we start linking it to other parts of the world. And that's the one key thing I want to tell you is that I could tell you, all right, this energy world is changing, renewable energy is important, but what I'm trying to tell you is we need to build and take all of the capabilities we have in digitization to understand and optimize it for your problem. Saving power, being more secure, trying to have transparency. But this will give you an additional advantage because it gives you the possibility to understand your network and start looking at your energy network not as a cost center, but as a value creation. A value creation in the case of E.ON for your customers, for your consumers, in the case when you're in industry for your IT systems, and really go forward. So the discussion and the Q&A we're going to have is to take your mind and say it's not about only how do we get you the best transformer and how do we get you the best control system, but how do we put intelligence into your network, build a brain to connect it, and really connect it across multiple industries to add and create value. Because as I said, the oil of the new generation or the oil of this generation will be the data we create, and energy is the best and the key capability to sort of enable this. So without further ado, to make it even more real, I want to make sure that I invite Carsten up to the stage. Just for you, Carsten and I actually studied together 20 years ago at the same university. We didn't know, since I'm only 3 weeks, he's a year in E.ON. He came out of the telecom industry, and he will also tell you what is this link, which is between the energy and the telecom industry, which actually comes together. Thank you, and help me welcome Carsten, absolutely. Thank you.
Thank you very much, Cedric, and good morning, everyone. So I'm a board member of E.ON SE, and I'm I'm responsible for, in essence, the customer solutions, decentralized energy, and also digitalization. And I would like to talk to you about a little bit how we change as a company and how we think about this new energy world. So as Cedric mentioned, I worked in the telecommunications industry. And the whole communications industry worldwide today consumes about 3.5% of the total energy on our planet. And with all the devices, the connectivity that's happening, this is supposed to go above maybe 10% in the next years. My former company spent several hundred millions of dollars on energy, and yet we did not think about energy in a strategic way. It was just a cost in the P&L, and we didn't really know until very recently what energy can do for us and how much it is actually changing. And the way we look about energy at E.ON is, as Cedric said, we're moving away from the very central model to a totally decentral world. So everything is becoming decentralized, clean, sustainable, and obviously also much smarter based on data. And the fundamental shift is, like in many industries, technology and innovation, because the renewable energies are really mature these days. Last week in Germany, an offshore wind auction went through with 0 subsidies. No subsidy from governments whatsoever, just purely based on market investments. And this compares to massive subsidies, say, 2 years ago still, so there's a rapid change in this whole world. We announced at E.ON a few weeks ago for private customers, for households, a solar system that makes customers basically 100% independent when it comes to their electricity, because we offer them the possibility to store their energy in our grid, what we call the solar cloud. And for that, you actually need a very smart solution based on data flows that work both directions. So we have today clean and sustainable solutions in our portfolio. This is entirely what we focus on at E.ON. So our renewables business, we produced 12 terawatt hours last year, which serves about 4 million households worldwide. We operate 1 million kilometers of grid, and the grid is increasingly becoming smarter. Lots of investment from a digital point of view. Just in Germany, we have more than 400,000 decentralized assets connected to our grid, and that represents about 30% of all renewable capacity in Germany. We serve about 25 million customers with our decentralized solutions, and in the B2B space and the industrial space, which is becoming a much bigger business for us, we manage more than 10,000 distributed assets today, and very often in a totally automated way based on data. So when we talk about industry and business customers, our proposition are 3 things mainly. The first one is the reliability, the quality, and the stability of supply. The second one is cost savings. And the third one, very importantly, is sustainability, CO2 savings. So we engage with large industry customers actually very often on a CO2 agenda, always in combination with cost savings. But increasingly important is actually the stability and the reliability in a decentralized world, which is actually becoming more complex to manage. So in our portfolio, we offer all sorts of technologies, CHPs, fuel cells, batteries, how connect all those. We offer flexibility, virtual power plants, and I can't think of any of our current offerings that is not based on sensors, data collection, and smart algorithms. We partner a lot, which is also new to our industry, I would say, and we also partner with Siemens. And we usually achieve 30 to 40% savings for our clients in the first instance. That continues over time. And CO2 reductions of more than 60%, depending on where you're coming from, sometimes 90% possible. And that is for us an absolute growth area. So I spoke to a large client the other day, and they said, we couldn't operate anymore in a central system because the quality isn't good enough. Our robots wouldn't work with the same precision, we would have downtimes, and that's a lot of cost to us. So we actually have to operate in a decentral way. And the second point, what clients usually are very surprised by, is that you do not just achieve the savings one-off, but you realize a lot of the savings in the ongoing operations through the intelligence of the system, using the data, using algorithms, and going deeper and deeper actually into production lines and even optimizing those processes. And that only works when you have a strong collaboration between clients, customers, and actually companies working together. So this is an ongoing, if you like, project. And my last point is that energy of the future, and if I also take a German European perspective, is, in my view, not just a system topic, it's an economy topic which allows actually Europe to play a leading role to capture innovation and think about growth. This is connected to jobs, connecting different industries, and the question is, how, and that's what we're trying to do at E.ON, how can we think about this system cross borders so we can go actually to any country? So we are not bound by our today's footprint when it comes to decentralized energies. We follow where our clients are. And I think we all need to think, and also policymakers, how to change policies so that the decentralized energy world that will come, in my view anyway, will really take off. The second point is, I think, in many of the conversations, there are companies out there that are very advanced when it comes to energy. But there are a lot of companies out there where it's not yet top of the agenda. And I think we need to help companies to focus on their business and reap the benefits of what the energy world can actually do for them. And last but not least, I truly believe that also in a data-driven world, in order to be successful, it's also about partnerships. Not just on a chart and theoretically, but how do you cooperate and collaborate to make that successful? So that's something that we as an energy company, we are really taking very seriously, and we value the partnerships we have, and that's how we think about the energy future. Thank you very much, and with that, actually, I hand over to Pablo. Thank you.
Thank you. Good morning, everybody. My name is Pablo de la Puente. I'm the Global Systems Director. I'm not an energy efficiency expert, but I try to explain the detail of the project that we have launched with the partnership with Siemens. We have named with a very interesting green energy from the cloud, and it's totally true. That we have launched is a system that is not a proof of concept, it's a real system that we are using since 2015, at the end of 2015, and we have deployed in many of our plants. But permit me before, Gestamp, who is Gestamp? Gestamp is a manufacturing company in the automotive sector. We stamp parts for the main OEMs, the main brands in the automotive sector. We have almost 100 plants around the world in Europe, Asia, South America, North America, very decentralized, where our customers are, because the logistics for us is key. We produce big parts, doors, hinges, chassis, etc. Our total revenue at the end of 2016 is 7.5 billion euros, and we have an EBITDA of more than 800 million euros. Okay, now you know the company, you know our challenge, our problem. So I want to explain these 4 steps that we did in the project. I want to explain what was happened before the implementation and after and during the implementation, very quickly. When they came with the challenge, what was happening in Gestamp? The main problem in Gestamp is that we was increasing a lot our consumption in energy because of many reasons. Because of the pricing, because of we are leading one of the main technologies in the automotive sector, that is hot stamping, that is very intensive consumption in energy. We have more than 70 lines all around the world with this technology. Of course, with the regulations, ISOs, energy prices increase, as I said, and of course, our commitment with carbon footprint. So the initiative was born, as always, in a brainstorming, when the business people comes to IT and say, okay, I need to implement a new system, how can we do? And I always say, I'm in charge of all the digital initiative at Gestamp, and I say, why? Why do you want to do this? Because I need a why. Because if not, we cannot provide any add value to the business. At the beginning, I say, okay, because I want. No, it's not a reason. You need to explain a little bit more. So, and they begin to explain, and what you do? I want a real-time system, a flexible system. This is as always an analytic tool, but it's very important in this case. We need detailed information of behavior of our assets. We need a cloud-based model, easy to access. I don't want to pay. Do you know that automotive sector is not very profit business? So they don't want to pay any licenses. They don't want to pay per user, etc. So we talk with Siemens, and I say, okay, this is what we need. I need always partners. We are not a big company with internal resources, so we need companies like Siemens that can help us with this. So we create a system, and very important thing that I didn't mention before in the slide before, big data. Why is key big data? I think it's a term that we use a lot, but in the case of energy efficiency, is key. I don't know if you can see it well, but this is a comparison between two compressors with different resolutions. In the first one, per hour, you can see that the trend has changed a little bit, but you cannot analyze really, and you cannot define any patterns, which is the problem with these compressors. That the first one, when you can see in the graphic that is below, with 1 minute of resolution, that is working very well, the yellow line, and after it has problems. So with this data, the people in our company began analyzing this information. Before, they have no idea about this. They have no resolution about the systems. So what we did in the past, our current status of our development, we have deployed in 14 plants in Europe. We have the corporation at Gestamp in Madrid, based in Madrid in Spain. So we have begun in the plants that are close to Madrid, in Bilbao, in Barcelona, but we extend to the rest of Europe. And we are now launching this year in 2017 to the rest of the plant. As I said before, I have almost 100 plants. We need time because at the end, we need a little investment in the plants to cabling and many things. So it's not plug and play system. If we have all the cabling and this is easy, but if not, we need to provide capex to the plants. And I want now to deep in and permit me that explain a little bit real examples of problems that we have detected with the system. I want to talk about KPIs. What we did with the observation of the data and with the analysis of the data, okay, we take measure, we can see things, but we began, okay, now we need to do machine learning, we need to define KPIs, we need to define alerts, and in this case, as you can see, the purple line is a compressor that is working, and in one moment begins working at 80% of its capacity. So another compressor begins working, a variable compression that we have to support this decrease of the performance of the compressor. Both compressors are working bad. The energy consumption increased because we are working with two compressors. So we have defined an alerts that compare the current status of the compressor with the theoretical status that it needs and send an alert, an email, an SMS to the maintenance teams to analyze this. Another example, we can compare, because it's not only to solve problems, it's one of the key things of the system is to increase the productivity of our assets, to decrease the maintenance of our assets. In this example, you can see in the first graphic two different presses from two different suppliers. I didn't say the name. And in the standby way, one is more efficient than the other one. So that we did is to ask, to call the supplier and to say, okay, what's happening with this? Your competitor is better than you in energy consumption. Can you do anything? So they take measures, and after, you can see the red line that is before, they decrease almost 50% of the energy consumption in a standby mode. So it means that they can do. I think this system is helping our suppliers to improve their assets too, and we are working very, very close to them. We are providing access to the suppliers to see in real time which is their consumption. That is very important. It's a win-win for everybody. Below, we have different presses, an hydraulic and a mechanical press. We know that the consumption is very different depending on the press. But this information for the commercial team is very interesting for RFQ process in order to do investment or not in what technology we want to implement, mechanical or hydraulic, and in the business case, they can include this. We can split in the RFQ which is the price in energy consumption per part that we are producing in each technology. This is unbelievable 2 years ago. And integration. The next step that we thought is, okay, we have the energy consumption data, but why cannot mix with another information? For example, production data or ERP. So that we did is to mix energy consumption with our manufacturing execution system. And as you can see here, is that in red color, for example, is the production is stopped. It's Monday morning in one plant in Europe, and they are switching on the furnaces in hot stamping technology and have a big peaks, and we have no production. Two things that we have to consider here. The control of the peaks that we have, very interesting, for example, in Germany, that the invoices are very related with the peaks that we have in terms of invoicing, and to analyze that we consume energy without produce any part. So we take different measures, we talk with the maintenance teams, we implement changes in the processes of the plant in order to switch on the 4 furnaces that has this plant sequentially to try to avoid any problem. In the graph you have below, so we do this more slowly during the day and before, of course, begin the shift. But we have avoid this type of peaks that all the plants have. And finally, we have implemented a big number of measures, and all these efficiency measures come directly from the plants, from the operators that are looking at the information that has, for them, are mandatory to send every week a lesson learned, an analysis that they did. So we have a very collaborative way of work between the plants, because when we began the project, and it's a joke, we say, okay, this information is fantastic, but we cannot compare. So after we have the second plant, we cannot do anything. So we were very happy with the system, with the data, and I say, okay, it doesn't work. We need more things. So this is measures that we have implemented in Bielefeld here in Germany with laser welding cells, different measures that has decreased 20% the energy cost of the laser welding cells in average, a lot. So these are different examples that we have, real examples. Believe me that people is very excited with the project, and many of the plants are telling us we are implementing many of the measures in plants that haven't the system because are very easy. We are talking about setting of compressors. We are talking about performance of many of our assets. Although they don't have the system, we can implement. So we are launching many of these initiatives. After this, we are implementing the system and they can detect new things. So the result, try to summarize. We have implemented more than 130 measures during this 1 year and a half. We have reduced 10% in terms of 50 gigabytes per hour. And in the 14 plants that we have implemented, it means more than 4 million euros in costs. We have analyzed which is the business case with the return of investment of the project is more or less less than 1.5 year, 1 year and a half. And we have saved 14,000 tons of CO2. That is very important for us. In the graphic, you can see in which areas we have implemented all these measures. Next step, as I said, new plants in the Asia plants, mainly in China and in India. 4 plants in the US and Mexico. And after next step, we will have South America. South America now, Brazil and Argentina are not well business, so we'll wait a little bit to implement. But we have put objectives to everybody. So we have included in our budget add a 5% of saving in the current plants and a new 10% for the new plants. So we will save at the end of 2017 50 gigabytes per hour more. So it means that in accumulated, we will save, we expect, save almost 8 million euros. So this, you have talked about the profit and loss account, is direct to the profit and loss account. That for us is very, very, very interesting. Thank you very much for your time. I think it's a very detailed information, but I try to explain it very quickly. Thank you.
And I think you did that. So Pablo, about your results so far and the expectations.
Yeah.
Now, we saw some of the expectations in 2017, plus 5% and so forth. The first results you had now, the 10% energy savings, was that what you had expected, or did it even exceed your expectations?
Yes, a little bit. We were thinking more or less in 7-8%.
Okay.
Because from the beginning, we see that all the challenge that we have at the beginning, we can exceed. But it's exceed a little bit more.
So you were pretty much on target. Good to know. We're going to fill up the stage now, ladies and gentlemen. So let's bring them back on stage. Cedric Neike and also Dr. Carsten Wildberger. Please have a seat wherever you feel like. We'll just start right over there. There we go. And like I said before, we have 3 gentlemen here, 3 basically complete different, but also very close-knit angles on this topic. And first, there is Cedric Neike, member of the managing board of Siemens AG. And he is someone that merges the data and the energy worlds for greater efficiency, security, and sustainability. Then we have Dr. Carsten Wildberger, a commercial member of the board of management at E.ON. And he kind of cleans and decentralizes the energy world, right? Can we say that like that? Kind of. And we also have Pablo de la Puente, who we just had on stage, from Gestamp, who reduces his carbon footprint by taking energy from the clouds. Yeah. This is kind of how I would describe...
And saves $8 million.
Yeah. Our 3 experts here on stage. Now, I'd like to find out in this discussion what the 3 of them, or better said, the companies they represent, could achieve by working even closer together than they have done so in the past. So before we get into this topic, just a short warm-up here. Maybe you can tell me your initial thoughts when you hear the words digitization, digitalization, and digital transformation. I'd like to start with Dr. Wildberger.
Well, that's the mother of all buzzwords these days. Well, to be honest, the first thing that comes to my mind are still customers, because the most fundamental thing that in my view is changing, how customers engage with companies, how they purchase products, the type of products they have. It's the whole customer relationship. And one level behind that, data, models, algorithms, is actually changing not just that relationship, creates new business model, but data at the end is a means to an end. And the end is actually the customer.
Mr. Neike.
He thinks customer, I think my kids. I mean, when I think of digitalization, my kids don't have a phone anymore, have better information of what's going to happen than me, are linked in a completely different way. And I'm saying this for a different reason, because I think that this digitization, which is a buzzword, and it finally reaches in the industry, is something which came out of the consumer world. The consumer world has completely changed the way information is being produced, consumed, and analyzed, and it's going now into different sort of other elements like the energy sector, like the industry sector. So for me, digitization is the capability to make sense out of things we didn't know before and do it much, much faster. That would be my view.
So, Pablo?
Okay, in my case, I think I said before, I think in collaboration. I think digitalization, you can say that it's a new collaboration way of work. And for me, perhaps it's more important, it's something that I've heard in a plant, implementing not this project, another proof of concept, that one operator told me and said, okay, that you are doing is digitalize internal knowledge.
Exactly.
So it's putting in context, putting for everybody the internal knowledge that the people in the plant has.
So, Dr. Wildberger, the first question goes to you. Where do you see the biggest opportunity when we talk about digitalization in the electricity sector, also for your customers?
Well, the biggest impact is actually on the decentralized world, because such a decentral world which has to optimize flexibility in a way that was not possible before, you need real-time data exchange to connect everything, that you can provide a stable energy system. Beyond that, that's the primary, I would say, driver for us. Then you have other layers that, for instance, in the home, through energy, you will get new applications in the home. Everyone talks about the smart home. There are different ways of being smart. One is how you manage your whole, say, dishwasher at home, the washing machine, the fridge, and you can do so much more with energy. So there's also other value add on top of that. And at the end, if I think about customers, the whole sectors are becoming more emotional. Customers become an active player in this world. It's a great feeling when I, as a private customer, can produce my own energy. I become independent, and I actually also can do something meaningful for the environment. So I think that is only possible through the combination of the new technology, assets, and data.
Next question goes to Mr. Neike. Now, looking at industrial power applications, what are the specific levers from the Internet of Things to open up the next level of opportunity and energy savings?
I mean, Pablo had the best examples, to be very honest. The idea, and I'm going to build on this, the idea on taking your plant and making visible what wasn't visible before, which is exactly what he did, is the first step for me to really link the energy and the production technologies together. But I think it's the first baby steps. Imagine he doesn't have to. You said that you see a different change, you send an SMS or an email. Imagine this would happen automatically. Imagine this is becoming a process in which the presses automatically adapt depending on the energy prices Carsten produces. Carsten has a lot of sun, a lot of extra energy. He gives it over to Pablo, and he starts sort of producing those energy elements together. So I think digitization takes us out of being blind of what's happening and being stochastic to being much more dynamic. I think the next stage of where we need to build more intelligence and where we're focusing on is to make this continuous. A continuous process which optimizes itself. Yeah. And that's where the buzzwords where we were starting, artificial intelligence and big data, actually make sense. Because imagine that Pablo now has a dynamic environment to do this. He will save not 8 million, but 10, 15, 20, and being much, much more productive than any of his competitors. And I think that's where we're going, in which direction we're going.
Moving over to Pablo. Now, you gave us some great examples of the potential digitalization has when it comes to improvements in sustainability, for example.
Yeah.
And you also showed us some of your expectations we just talked about. So what is the next big thing in this area that you're working on?
Well, I think have explained before, next step very, very quickly, but I think we have to keep researching and dive into the optimal behavior of our assets with the analysis of the data. And of course, finalizing try to finish the deployment in all the plants because they provide more data, more information, more casuistic in the different plants, and to try to reduce our objectives, to try to reduce our compromise with the carbon footprint. So many of the things that we have said before.
Okay, so what are your specific expectations, let's say, towards utilizing or towards utilities and digitalization partners like Siemens, for example, regarding your
for example,
next big thing? What is at the top of your wish list? We already heard what at the top of
I think he has anticipated again, but for us, not only in this project, I think next step could be auto control of the machines. For example, with the information that we are receiving in energy or any problem that we can have in the asset, to try to avoid more maintenance, to try to avoid to stop the production line. That for us, the availability of the presses are key. So if we can, in a cloud base, in real time, an auto control of our elements, and we don't have to wait for a maintenance person to do these things, and we can, by any algorithms or machine learning or whatever, can control the machines. I think will be the next step on my wishes. I think it's not so close, but why not?
And I'm just going to jump
Sure.
on it. Just if we partner, I mean, imagine a world where you become the best in the industry at running energy to parts. This is what you do. Actually, you take energy and you make parts with a certain format of it. That's what Gestamp does. And you become so good that you could tell other similar producers on how to sort of optimize it. You become really sort of good at it. Now imagine you telling, and we could learn from it and we could take it to another industry. Now you go to Carsten and say, this is my peaks of energy at this place.
Yes.
He could optimize his production. He knows, you know what, I have lots of sun, I have lots of wind, Pablo, let your stamping go faster. That's the partnering in this. It's not only the link within your industry, it's the link to Siemens, it's the link to E.ON. It really becomes an ecosystem which saves energy, which becomes more efficient and becomes self-learning. And I think that's the world which we want to go into.
Yes, finally to add, so we are working, by the way, we are working in a project, it's not in an energy efficiency, a multi-step process. It's a technology that we are implementing to increase the OE, to increase the productivity, and we are trying to do this with you, with the industrial team, to trying to auto-control the machine and not depend on people.
To optimize it.
Next question goes to Dr. Wildberger. Now, what are your future plans to support the key digitalization endeavors of industry customers, like Pablo just mentioned?
Well, we have, of course, kind of off-the-shelf solutions that we sell. We also partner. MindSphere is something which we also have in the portfolio. But the real creation, if you think of products these days, we come in the 20, 30 years ago from a more static world. You build a product, you use it for 10 years, you sell it to a customer, etc. The world has become much more dynamic. There is no such thing as the product, you build it and it's finished. It's a continuum. And the real innovation happens actually with customers and clients by working together, which are called co-creation. So you have to go through natural steps. So if you want to reach the point where you have full automation with kind of artificial intelligence solution, you have to go through the phase of transparency. So if you want to be the master in algebra, you still have to do algebra 1. You can't miss it. So there are steps, and I would say the future for industries is actually learning better to partner across companies and work with clients. So those solutions, the most successful products we have, the value we bring to customers are those clients where the teams manage to work together on a continuous basis to develop things for the client. And this is how software gets developed these days and also products gets developed these days.
And also saw from your keynote, you give a guarantee, basically, right?
We underwrite savings for our customers for a period of time. And actually, we often change the view what's possible in the process. And that's why I'm a true believer in business. It's actually not a transactional world. In a digital world, it's also more about relationships, connectivity, but also amongst how companies work together on a client's problem.
Mr. Naika, now alongside the Internet of Things, digital twins seem to be the new species arriving here on our planet. At least you can see a lot of them here at the Siemens booth. Now, how can they help Pablo also with his next big plans, for example?
What is the idea of a digital twin? So the idea of digital twin is instead of doing something physically is to virtually sort of simulate it. Might it be, I don't know, I think a sneaker with what we do with Adidas, might it be a machine tool, but might it be also a process for Pablo? So imagine Pablo he's going to build more plants, but with all the knowledge he has, he could simulate how this plant of the future would look like. He could talk to actually Carsten and say, how's your energy consumption? And he could really sort of think through before he has to physically build it and then optimize it. That's what it happens. So we go in a world where we virtually build something, test it, optimize it before it even has a physical application. And I think that's something which we're at the beginning, and we're doing a lot of those in Siemens. But I'm just at the beginning of this, where I could go to a mayor, I could go to somebody who runs IT and says, let me virtually simulate the perfect world and let me see on how we go there, and we go in this direction. So I think this idea of this virtual and physical world coming together and learning from each other is what I think, which digital twin, which is yet another buzzword, which we have, but I think has a huge, important application in the real world. Pablo, and tell me if it's true.
No. The general managers of our plants are very happy when I talk about digital factories, because they are very worried about when you go with a proof of concept that can affect the production. So for them, please don't affect my production, because for them you cannot stop. Okay. So with this new concept, it can help us to do the things in a new secure mode.
Digitalization and the Internet of Things are always also discussed in conjunction with rising cybersecurity concerns, right, and insecurities here. Are there any special considerations for securing services in the cloud? Man-in-the-middle attacks, as we'd say?
Yeah. Perhaps Carsten can help me, but okay. I think we have tried to isolate all the information, all the data that we are gathering from the equipment to try to avoid any problem, and we are doing this in an encrypted way with different VPN channels. So we try to isolate the information and try to put them behind firewalls and different tools that we are implementing, because why not? If it's a risk. It's a risk for the plant. It's a risk for all of us that we are here, and we have to manage. It has the same importance that all the projects that we are doing. We have to take in account not only the development. You have to take in account communications that are key, because you are connecting with the cloud, and all related with security. You have to take care a lot about this.
Well, security, cybersecurity, or whatever you call it, is front and center for any energy company.
Yeah.
Because imagine that something happens and the energy system goes down. And luckily, we haven't seen that very often. So you can also assume that there is a lot of effort, knowledge behind the system. Nevertheless, you can never say you're totally secure. But if you think about smart meter discussion in Germany, many years of conversations about what is the standard profile to make it really secure, endless debates. We have to eventually not forget about going to market at some point. But also when you have a background of running nuclear power plants, I can tell you the security levels and the knowledge behind how to run a nuclear power plant from a data point of view in a safe way, of course, helps us to make sure that we also engage with customers on all those security issues. Because the worst thing that can happen to a company like yours is that your production line is standing still.
Yeah.
And so that's something we continuously work, and also with other companies on, but 100% safety, security is not possible. You can also, what you can do is you can apply the best standards possibly available, thinkable today, and use those, and that's a core part of our business.
Anything you'd like to add?
Yeah, I mean, for me, I come from this world, and the first good news is you're going to be hacked. I mean, I need to tell you, everyone will be hacked. So we need to think the other way around, and you said it perfectly. The first thing you need to look at is to make sure that we have processes which are in place. You cannot imagine how many people have as their admin password admin, right? I mean, this thing starts like this. It's a perfect system, but something in the human place starts. So we need to look at the processes. We need to look at the people. The second thing, and we put a lot of energy in Siemens, is to make the product secure. But as I said, it's a race, which is always a two-way race. The third one, we have to assume that we will be hacked, and we need to look at how quickly can we react to a hack. because that's the way it is. So you look at your process, you make them as secure as possible. You look at your product, you make them as secure as possible. And you build a process which adapts quickly to isolate the threat so it doesn't take down a whole energy system, it takes down a couple of customers. I think that's where we're going. And it's a change in the world, but it's probably the most important question we have today also, is how do we make sure when we connect everything that we don't endanger everything at the same time?
Speaking of questions, we'll be getting to questions from the audience if you have any in just a couple of moments. But before we close, maybe you can give us a quick, let's say, list of do's and don'ts when it comes to the Internet of Things and digital transformation. Like, just real quick, what comes to the top of your mind? Do's and don'ts. Carsten.
Well, I won't give you don'ts because there are an endless number. I'll give you the do's, and the don't is the opposite of the do's. So the first thing that comes to my mind, I can't say that enough because I don't hear it very often, is actually the customer obsession. Whatever we do, is my personal opinion, deep conviction, whatever we do as companies, no matter if you're a B2B company or not, when you think about digital, it's a means to an end. It's about the customer. The second one is, when we think as companies, and that's something we are embarking on as well, we try to avoid proxies. We try to avoid trade-offs when we think about solutions. You either go all in a process, you digitize or automate the whole process, but not just bits and pieces, and you don't compromise. And the third one is really incredibly fast decision-making. Thinking bold and breaking that down, how to implement it, but being incredibly fast along the way, because you may not get it right, but you have time to react. So customer obsession, no proxy, no trade-off, that's the ambition level, and then being incredibly fast in that implementation cycle. And last, I think you can only successfully transform, and that's a leadership job, by being positive. Positivism, I mean, when I think about the debate sometimes about how we do it in Germany about becoming digital and then finger pointing, are we doing enough? I mean, nothing great can be created without being positive. And I think when you think about a digital agenda, which is actually quite exciting, it has to be also positive and full of energy. And I think that's a leadership job to create that environment.
And that's why we don't hear don'ts from Mr. Daga, right? Okay. How about you, Pablo?
Okay, I think do's, perhaps. I think we have to think in the people to find the correct people in each plant. I think if the people that has initiative, that has to make the first step to say, okay, I want to participate in this. When we do a proof of concept in any plant of any project, one of the main things to select the plant is if the case that we want to treat, the plant has the best performance, are the best people that are in the plant, because if we can increase the efficiency, the quality, or whatever we are treating, we can to do in the rest of the plants. So try to find the best people in the plants that exist, believe me. There are people in our plants that has enough knowledge and have the capacity to participate in this type of project. And there are no resistance with this, because they participate, they collaborate, and again, the collaboration, lesson learned, all these kind of things promote. You have to promote, because if not, you don't take any outcome for the proof of content, so you will stop the project and you will not escalate all the initiatives that you are working on. And don't provide any bad value, and I begin why we have to do the project. If you don't ask this question, don't make any project.
Okay. And
for me, a lot has been said. You have two options. Either you are driven by change or you drive change. In this case, you have to drive change, because if you wait for something to happen to you, you will not shape it. So the way you positively engage and the way you put this emotional element into it is the only way for us to embrace it and make it something which is positive for all of us. So that would be my take on it.
Some nice words here at the end. Are there any questions now here in the audience? Just raise your hand. We'll get a microphone to you right away. Everybody looks very happy. Look at this audience. They're all
we have
smiling.
answered all your questions, so that's...
Okay, but there's one question right over here. Can we get it up in the third row? There we go.
My name is Tom de Vries. I'm from Bentley Systems. We work with Siemens. I have a question for Dr. Karsten Wilberger. You said you had 400,000 renewables in your infrastructure. Does that include all the renewables from the 25 million customers that you have as well? And what is your expected growth rate, and how does that influence the quality of your services to your customers? Because there's a lot of disruption that comes in with those renewables, and how do you manage that?
Yeah. So to first part of your question, it also includes all the PV systems from residential homes. So it can be from a larger wind farm down to a single panel, solar panel. That's all connected, so that's all those decentralized assets. And well, look, the growth rate, batteries are coming. That is changing quite the system. So if you think about the roofs, the area that's available, and in Germany with the current technology, apart from the north side, you can use any direction on the roof. We probably have just from an area about 15% to 20% covered today. Then you have what we call Mieterstrom, where you have more bigger residential houses. This market is evolving. So I would say in the residential space, for instance, there are scenarios, always based on certain assumptions, obviously, but 40% of the residential space in the foreseeable future could go completely decentral. It's not impossible. And then also think about e-mobility, which is, if that is an exponential growth rate, we're in the beginning, but by doubling every year, it will grow very fast. And that's also a decentral asset connected to the grid. So we are actually investing, developing software as we grow, and that is increasingly important. So we are very positive about the opportunity, how the growth will unfold. And we haven't talked about storage as part of the whole game, which is, I think, also in your case, something potentially very interesting, for instance, to reduce to shave your peaks off, etc. And we have a special team that manages the flexibility in the system and markets that as well. So anything we sell today has a component of flexibility involved. So give you an idea.
He's nodding his head, so hope that answered the question. Any questions from this side? All right. So then I'd like to say thank you to our guests here today. Let's give them a big round of applause, ladies and gentlemen. Cedric Neike, Dr. Karsten Wildberger, and Pablo de la Puente. Thank you very much. Also to you watching at home, feel free to stick around. We'll be with our next presentation in about 15 minutes. No? We have? Now? All right, we have it now. Okay, well, we're faster than we expected. So we're going to clear the stage, and I wish you guys a great time here at Hannover Messe 2017. Thank you very much for being with us. Bye-bye.
Thank you.
Bye-bye. All right.
Hi, Helmut.
Hi, Edwin, my automation engineer.
How are you?
How are you? So please take a seat. We are going ahead in 1 minute, but I'd like to take the opportunity so you can take a seat. If you come in, please. Still some free spots.
Come on, join us here.
Good. Welcome to Electrification Meets Automation. Today, we show how you can benefit from the tools of digitalization. First, let's listen to our customer.
Hello? Yeah, Wolfgang Müller speaking. We have a problem. Yeah, we had an auditor in our production. He found out that last year our energy consumption was way too high. He said this was due to our old gift packaging machine. In addition to that, the machine failed quite often, so we would urgently need a new machine. Please find a solution. Yeah, thanks. Thanks, and talk to you soon.
Wow, this customer is in a real tough spot, isn't he? And so are we. Actually, he's under a lot of time pressure to update his machine before Mother's Day. So, do you experience time pressure in your daily work? I think, yes, you are. Right, it's quite common. So what we have to do is rather clear. The physical layout of the machine is given. The functionality, very well defined. But, Edwin, I think we can do something about the control cabinet, right?
The control cabinet, now many people would say, let's take now to grasp the opportunity to have maybe new innovations there. What about more efficient drives or software tools which will help us look for energy waste maybe?
Exactly, and there's one more thing that even concerns me more. The customer was mentioning that the machine was failing quite frequently. So of course, a common cause of that are issues with power quality. We for sure should implement the functionality to check power quality in this updated machine. Since the energetic footprint of the machine will be much lower, also we have to reduce the fusing.
Now, many of you may ask, nice ideas. However, that all will probably end up with a new control cabinet. So, building up a new control cabinet can be, let's say, quite hard, difficult. Maybe there are other alternatives to have a maybe more efficient way for a prototype of a control cabinet. What about that?
Right. A prototype, I think we need. That's the basis of our work always. But on the other side, these days we build a prototype virtually. That means we are building a digital twin. So, doing so, it's rather easy. We actually have everything in our system already. The CAD data from Siemens. So we build, model, and simulate the complete machine, the functionality, the dimensioning, and not only drawing single line diagrams as we always used to do. That's a big benefit that helps us to shorten the process. After we have done that, we let out a bill of material of the components, and Edwin, you can do something with that on the automation side.
Everybody knows that this bill of material will contain exactly those components, hardware and software, which I have to consider in my new automation program. And while I am configuring the new automation task, you can redesign the cabinet, for example.
Yes, as an electrical engineer, I know very well electrification is the basis of any automation. So by using standard components, communication is ensured and data gets exchanged automatically.
Communication is of great relevance to us, since we are using the TIA portal of Siemens, the totally integrated automation portal. And there, especially based on this perfect communication, we can obtain a perfect interplay of both worlds, electrification and automation components.
Yes, the TIA portal is very powerful and very well known for the automation world. But as an electrical engineer, I'm interested, can I configure already all the electrical components there as well?
Of course. It all starts with a common communication network. So by TIA portal, we can set up this network, assign, for example, all IP addresses automatically. So communication can work, data exchange can work. Later, we can set up a common HMI, human-machine interface, common SCADA system, to operate and monitor, again, both components, electrical and automation components.
Sounds marvelous, excellent. But isn't that too complicated for electrical engineers, though?
No longer, actually. In the past, you might have needed more tools to configure and design different products. Nowadays, it has all become obsolete thanks to TIA Portal.
Yeah, hello, this is Wolfgang Müller again. I forgot to mention that the new machine must be integrated in our energy management system. We need full energy transparency. Yeah, please consider that the new machine can't be more expensive. Yeah, thanks, bye.
So, ladies and gentlemen, what you have seen here is real life. While we are redesigning the cabinet, our machine, new requirements are coming up for our customer, which we have to consider in our design phase. I'm an automation engineer. I'm really happy that my electrician colleague has selected the right components from the Siemens portfolio, Simatic, Centron, Sirius, or, well, Sirius components, for example. Why? Because all these products can not only do their job, but thanks to digitalization, we can achieve a perfect integration of energy management in my automation task. I don't have to take care of energy data recalculations. And we heard that our customer also needs to consider, well, energy efficiency. So if he uses any energy management tools, we can perfectly integrate the complete data there too, thanks to digitalization. And if in next year, for example, new meters are needed, our customer needs to expand the system, no problem. That all can be done without adjusting your cabinet design.
Right. And you saw it in our real-life example. The customer was coming very late before we had to finish the machine. And given all that time pressure, he even gave us a change order in the middle of the process. Thanks to the tools of digitalization, we were able to fulfill his requirements. Now, after updating this machine, I give out again the bill of material. It's the final one.
Because I'm going to place this bill of material now, the final one, in a Siemens mall to have all products, hardware, software, electrical, and automation products right in time. Since our customer needs to start the production quickly, and don't forget it, their gifts wrapped by this machine are necessary for the Mother's Day ahead of us. And these gifts may be even more important than those for Christmas Day.
Right. Ladies and gentlemen, so we showed you a perfect interplay between electrification, automation, and digitalization. So in the end, we achieved a fast, reliable, safe, and very flexible process for our customer. I think he should be happy.
Yeah, hello, this is again Wolfgang Müller. Yeah, so I would like to thank you. The new machine is running very well. The energy consumption is much lower and we had no more failures. And thanks to the energy transparency, our employees were able to optimize the production process even further. So thanks again for realizing this so quickly and on a short notice. Bye-bye.
So what we witnessed today was a quick redesign of a machine, of an existing machine, under time constraints. At the same time, we could implement new requirements of our customer, the requirements for higher energy efficiency. We managed to do all the job, and at the same time, the operators, plant operators of our customer, can not only start the production right in time, but they can also get support from the tool to increase the energy efficiency. All data needed, reduced to a certain amount to have them at their disposal at their machine level. And all that was possible because we could integrate the three core topics, digitalization, automation, and electrification, by means of TIA Portal in one environment.
Right, and it goes even further than that. Here on the Siemens stand, 126 meters from right here, we have this application. So we would like to invite you that you join us so we can show all these benefits based on your applications that you have as our customers. And even more advanced, we have integrated that machine on the Siemens stand even into MindSphere, our open IoT ecosystem, so you can process, visualize, and manipulate all this data, energy data, as well in a cloud-based system. So we'd like to thank you for now. Please join and come with us to the Siemens stand. Thank you.
Thank you.
Thanks, Edwin.
Also, thank you, Helmut Ketterer and Edwin Schizar. You guys have a great day, doing a great job. Break now, ladies and gentlemen. About 15 minutes. We'll be back again at 11:30 then for our next presentation. And in the meantime, why don't you just explore the Siemens stand here? There's so much to see. 3,500 square meters of space. We have the highlight cubes, talking about additive manufacturing, for example, or go get your own protein drink. You can mix your own drink over at the food and beverage stand. Also something you don't want to miss. And I'd encourage everyone to check out the MindSphere Lounge. Now, MindSphere is the open and cloud-based Internet of Things operating system by Siemens, which you can find up in the round spaceship cloud-like structure we built here on our stand. Fits very perfectly, actually. If you want to see what the cloud looks like inside, well, just go up and see. So, besides that, hello to our viewers watching at home or from your mobile devices from wherever you are. We are streaming live. Every presentation here, every day, 250 presentations in total. And also here, once again, if you feel like watching tomorrow or the other days, go to siemens.com/hm17-livestream. And last but not least, last information, and then you can go or stay. If you wish to receive these presentations as a PDF, we can send them to you via email. Just leave your email address with one of our colleagues, with one of our hostesses with the iPads. They'll take your email address, and we'll send you the presentation within the next 24 hours. All right? Okay, so I'll see you again at 11:30. Have a great day. So, and there we are, ladies and gentlemen, 11:30, and it's time for our next presentation. May I ask everybody standing outside, coming down the aisles, come a bit closer and come inside. That's the best thing you could do now, to come inside our Thought Leaders Forum, take a seat. We have some seats set up for you right here, some cozy, comfortable pillows. Really, this is the most comfortable place you could be here at Hannover Messe 2017. I'm sure people in the audience now agree, right? Very comfortable sitting where you are? I hope so. Okay, so welcome everybody watching at home also on the live stream. We're going to get right into our next topic to stay in time, and we're going to be talking about customized energy solutions, new approaches to an economical energy supply. And we're going to show you how to save energy costs, basically, or how to optimize energy costs by using local implementations. Well, I'm not going to do it. but our next expert is. So let's welcome him, Head of Distributed Energy Systems. Here's Dr. Bernd Koch. Welcome.
So yeah, hello to you all. I'm happy to see you here on Hannover Fair. My name is Bernd Koch, as you already heard, and I'm responsible for the Siemens business for distributed energy systems in Germany. So the next presentation that you are going to hear is about what exactly are we doing and why are we doing that. So mainly, one of the key indications we see is that the portion of the energy which is used in Germany coming out of the renewables is constantly increasing. The chart that you see here is showing that we have produced more than 30% of the energy that has been used in 2015 was actually produced coming out of renewable sources like wind and solar. These are the main contributors, and a little bit coming out of biomass. That's an important trend, and this trend is even more important because it's economically sensible, and it gets more and more sensible because the prices of the major contributors into the system, they are coming down considerably. If you look at that, for example, on the onshore wind turbines, looking at the last 20 years, the price is about half what it was 20 years ago. Even worse, this decrease in price is based on the PV solutions, the PV modules, as well as the inverters that you need to connect it to the grid. This price has come down by about 75% looking at the last 10 years, which is more or less the same for another key element, the storage element, the lithium-ion cells. They came down about in the same order of magnitude, about 75% during the last decade. And in the end, we have now a system where you have, on a cost basis, comparable or even lower cost compared to the traditional centralized system. And for that reason, we see clearly this is a shift, and this shift is going to be there as a constant change in the energy system. It's not like only because there is subsidies. No, it's really an economically sensible change in that. So we, from the Siemens perspective, we have identified mainly four segments where we really see these cutting into an economical benefit. First of all, there are optimizations based on grid fees, so how you connect to the grid, how you use your energy. Maybe some of you have heard the panel discussion earlier. We were talking about peak loads. So managing your peak load is giving you an economical benefit, and we can support solutions in this area. Secondly, about city districts and city district development, more and more the topic CO2 footprint is getting important. Sustainable energy supply, which is not only based on electricity, but also heat and cold for living and working in areas within cities or smaller towns is very important. Looking forward and seeing upcoming the challenge of e-mobility as well, connecting the infrastructure for charging poles is an important driver for that. Hybrid power plants, that's the next step in generating energy. So it's not only about gas and coal-fired plants. It's more smaller CHPs combined with PV, for example, or combined with wind to get these power plants in a constant production, and you really have them as a key player in the energy market. And last but not least, that's the key topic for this presentation. That's the energy park, customer-oriented. In this case, it's the industrial customer on site. You are now in a position to decide what's the best to do. Is it just buying from the grid and using energy as you did before? Or is it implementing in own generation and using that directly on site to optimize your overall cost for energy and potentially even make more out of that as soon as you have understood for what exactly you need the energy? Is it more heat? Is it more power? Is it a combination? Are there changes between days and nights? So how is actually this process optimized versus the energy production cost? I've prepared two examples to give you a little bit of insight what we are doing there. First is looking at how you optimize your fees that you have to pay in order to be connected to the grid. And of course, this obviously starts with the connection to the grid. So the first part you need is some sort of transformer where you connect to the grid. So that's the first step, obviously, because you don't want to run on an island. And the solution is still the German grid, at least, is pretty reliable. So you want to make use of that. Secondly, in order to manage your load curve, you need something which is able to react very quickly and to manage these peak loads. One of the key elements here is an electrical storage system, a battery based on lithium-ion cells. And what you see here is coming out of an example. You see how many times this actually cuts into on the basis of 1 year. It's about 530 events that you actually need the battery in order to control your load curve. If we have not only a small peak, but you need a little bit more energy over some period of time, it's not really cost effective to do all that out of a battery. So what you're going to use, you use what you typically know already, that's a CHP. So you use the CHP in order to cover that for a longer time. And mainly the different what it is, you're now using the CHP electrically controlled, not thermally controlled. That's really the change. It's still the same equipment, it's just another way how to use it. And if one is not enough, you just add a second one. And what you see is that the number of events is coming down even more. And last but not least, in the very rare event that even this energy is not enough in order to cover your peak load, you get sort of a load reduction in your process. And based on this example, you see this at a maximum 4 times a year. Because this is what you normally don't want to do. You don't want to interact with your primary production process. That's only really in the case that you have a very strong deviation from your normal load curve. And 4 times a year, which saves you up to, it depends a little bit actually on the size of the energy bill you have, but typically this saves you about 15 to 20% of your energy bill. You have to take into account potentially 4 times 15 minutes change in the production might be worth it. Yeah? And the good thing is that in this case, we did all the simulations, we did all the transients, that's all working, we did the right dimensioning, and we have a guarantee in place that you actually meet this reduction of your load curve. So this is where we see this is really, you only can do that if you understand all the components, like the transformers, how they react, batteries, CHPs, as well as your process, how to control it and optimize it. A second example is looking at something that you can see over here as well, food and beverage. Typically you need heat, cold, and electricity. So you probably have a CHP already. Yeah? And this is why in this chart you see CHP optimization. In many cases, we see that CHPs had been bought some years ago. They're still in operation, but first of all, you don't really know whether this is effective, or potentially you even know already that it's not optimized, but you don't know sort of how to improve it. And on the other hand, you potentially have CO2 targets. You want to reduce your CO2 footprint. So what we did in this case is we did a combination. We changed the way how the CHPs are running in order to have them on a constant operation, not on a peak operation. We added PV generation. In this case, it was 3 megawatt peak, and a battery in order to optimize the use of the CO2-free production out of the PV cells, in combination with what we call microgrid manager. And that's the managing software which is taking account about your use of the energy, as well as what the prediction of the weather is, because you need that at least in the 15 minutes looking ahead. How would be the sun actually helping this process? So you need a little bit of additional equipment in order to save money, and as you know, you need a little bit of equipment means you need a little bit of money in order to put that forward. And now there is the good thing from the Siemens point of view. It's not only about technology; it's also about financial offering. So what you see on the right-hand side is, first of all, there is a reduction in energy cost, which is roughly about 25% in this case, which is a typical number. So we always speak about 20 to 30% as on average that you can save with such a solution. And on top of that, we have a financial model called managing service. That's a 10 or a 15 years contract where you have the equipment served all the time. We take care about the capital invest, and you see sort of a managing fee for the next 10 to 15 years. And as this has a return on invest which is smaller than 10 years, in the end you see the profit or the benefit right in the first year. So, which means in the first year after the installation, you already get money back. That's a very good combination out of a technical solution that we really understand, and therefore we can guarantee the work and the proper functionality over the next 10 years. Combined with Siemens Financial Services, they take care about all the components, how to optimize that for your balance sheet. Looking a little bit in technology, this is mainly the examples that you have seen are examples coming out of this block diagram. This block diagram more or less is our blueprint, where you see all the components that we use in order to optimize that energy challenge. And in several workshops with you as a customer, we identify what are the core elements, how can we optimize them for your use, and finally to save money. That's the overall goal. We save money, and secondly, we save CO2 in using PV or wind generation on site. And I'm pretty happy actually in this position because I'm part of Siemens in this area, and we have combined the knowledge of many of our divisions because we really have a very good knowledge if we start from the power generation point of view, power and gas. So we know about CHPs, how they are working. We know about small industrial turbines, how they work and what the output is. We have a very good knowledge about energy management. So how are we sort of transforming the power from high voltage down to low voltage, how to distribute it. So that's one of our key knowledge points. We know how modern buildings are run in the building automation to optimize the buildings in this area, sometimes even to use buildings as a storage, as a thermal storage, for example. And last but not least, we know about production, like within digital factory and process process industries. We exactly know about how are the processes called, how are the processes run, and sort of in many cases there is an automation system of Siemens already there, and we can connect that into our overall solution, and we can combine it with wind power generation as well. So that's a very good position to be in from my side. So we have access to all this know-how, and from your side, because you have one partner you can talk to. Because we cover all this complexity, and from your end, we have a very detailed discussion on what's the benefit for you in this area. And one of the key drivers beside that are new technologies that we incorporate. And because these are incorporated into solutions, it's not that you have to bother about the nitty-gritty detail about the technology. This is what we are doing for you. In the end, we give you a performance, which is you get heat for the next 10 years, you get electricity for the next 10 years, and how we actually do that, this is what we cover from the technology point of view, and how this is financed, this is what the colleagues from Siemens Financial Services are able to cover and discuss with you. Some of these key innovations is we are back into the world of engines. So we have a gas engine with 2 megawatts that can run, of course, for generating electricity, but as well as a CHP. We have Energy IP as the main cloud-based platform for energy, combined or precisely running on MindSphere, which is the IoT platform that we use. So we are perfectly connected through that into your primary process. And it's a cloud-based solution as well, so there's no need for tons of computers at your site. Then we have cooperation with SMA for the PV topic. And last but not least, we see the storage topic. One is, as I mentioned already, electrical storage with a new product, Sealizer. And last but not least, we have an electrolysis, a solution which is called hydrolyzer. You can use that as the component into storage of hydrogen, but you can use it for several additional applications as well. And the next presentation is going to dig up on this detail a little bit to make that more transparent. Overall, to sum it up, this is what we understand in new approaches to economical energy supply with customized solutions. We use proven products, we combine it with a good business case and a financial solution, and we do that actually in workshops together with you to have the best solution for the next decade to come. Thank you.
Thank you also. Just said, you're already introducing our next topic very nicely. We saw it on the last slide, talking about ideas for a sustainable future and how hydrogen electrolysis, there we go, offers new perspectives. So please welcome the CEO of Hydrogen Solutions. Here is Gabriele Schmiedl. Welcome.
Hi to everybody. My name is Gabi Schmiedl. I'm heading the Hydrogen Solutions business within Siemens. And I'm showing you, as Ben Koch mentioned, what can you do with this technology. What you have heard a lot of times is that the renewable energy, that means wind and sun, brings challenges to our energy networks. We have a lot of wind and sun at times where you don't need it, you can't bring it into the network, so it's surplus. What to do with it? And what you see here is on the left-hand side, this is a prognosis for 1 week to 2020, and the peaks which you see is wind, and also the sun comes explicitly when the load is not that much needed, and there are times where you don't have wind and don't have sun or not enough, and there is load needed. So that is the one side. The other side is what you see on the right-hand side. You see curtailment. This is a figure from 2011. That means the value for 2010 was at that time already known. The value for 2015 was like that, like it was prognosed. And we assume that the value for 2020 will happen like that. What does that mean? And if you travel in Germany, you see that. There is wind, but the wind mills are not turning, so they are stopped. Now, there is a solution what to do, that is energy storage. And Bernd already mentioned it. There are different technologies which have to be judged differently. That means depending on how much power you want to store and how long you want to store the power. So there is not one technology which fits for all. And this is what you see here. That means you have, as Bernd mentions, if you have not that much power and not that long duration, then battery takes a big part of it, like the lithium-ion batteries. But what you see also, if you need a storage for long-term and for a lot of power, large-scale storage, you have to transform the electric energy into a chemical energy like hydrogen, or from hydrogen further to methanol or to ammonia, which you then can store a much longer time and a lot more. And the hydrogen can be stored where you store the gas today. That means in pipelines, that means in tanks, that means in all different sorts of caverns, what you have for the gas storage today. If we look to the electrolysis, what is the electrolysis doing? The electrolysis is doing what you see on the left-hand side. Wind and photovoltaic is coming in, very volatile, and goes to the electrolysis. That means the power together with water, then it is split up by the electrolytic factory in hydrogen and oxygen. And then you have those two gases. And the hydrogen can then be stored and used in different ways, and this is what I'll come to. If you store it, you can then store it for a longer period. You can then feed it into the gas network, transport it like that, or also store it in there. And you can also do in the middle, you can further transform it to ammoniac, and then you can ship it, what is done in big ships already today. But the hydrogen which is generated today is generated out of methane, that means of natural gas. It is with a big CO2 footprint. That means hydrogen is a means also for decarbonization, not just for storage. And this is the main topic which is important. So it is not just a storage. You can use the hydrogen in 3 different ways after you have stored it, or for some even directly. That means you can use it in mobility, and you have maybe seen in Hall 10D7 and also outside there are cars which are driven by a fuel cell and powered by hydrogen. This is one possibility, not just for individual transport, but also for trains and also for fleets like buses, or even in mining truck cars. Also there are discussions ongoing to feed them instead of diesel with hydrogen and fuel cells, or even also gas motors. That's the first application area. The second application area is you can re-electrify it. Like you take the surplus energy, you store it, and you do a long-term storage, and you use the energy by re-electrification whenever you need it, and you don't have one from natural sources, and you don't want to use it from the grid. That's the second one. The third one is the biggest one, or a very big one, let me put it like that. Who knows how much of the yearly used hydrogen is today used by electrolysis? It's a very, very small portion. It's only 2%. That means of the most 89% of hydrogen which is used today is used in chemical industries, in food industries, in fertilizer industries, and a lot of that is already transported via trucks from all the different gas companies day by day. It is around there, so people know how to use hydrogen, and in this area it is used as a mean for decarbonization. That means if you go to a refinery, they are doing already today fuels or other topics, and hydrogen is one intermediate step. If you do that greener, that means by using renewables, you're already reducing your CO2 footprint. And this is a big area of application aside of storing it and using it as energy, as electrical energy, back into the network. So the hydrogen is manifold. It's a storage, and it can be used in 3 different application areas. And this is what we are dealing with, what we are tackling at, and where we are using the industries we are connected to, refineries, fertilizer business, but also steel industry, and we are already doing with customers and implementing there also plants. So this is, you can use it in all different ways. And what is important is hydrogen is used today in a way which can reduce can work for decarbonization. What we have to do with the regulations is to value hydrogen as a means, and a very good means, to already reduce CO2 footprint today. And this is what we are also dealing with. So it's not just technology, it's also doing regulation stuff, and it is doing applications. Now, if we look to the references, we started within Siemens with smaller systems where we could take 300 kilowatt as power input, and then to do that in a containerized version, and we still have 3 containers at those 3 projects which are named there. The next, the actual product version is a 1.25 megawatt system, where we have 3 of them in the energy park within Mainz, where it produces hydrogen in a professional way. And this hydrogen is used in different ways. It's fed into the gas network. It is also used for for other applications which are surrounded there, and it is also used to fill hydrogen tanks. So there's a filling station connected to it where you really can feed in the hydrogen into trucks and distribute it to filling stations or wherever in the industry it is needed. Then we have another one in a municipality, a small system, and we are in the process of delivering 4 systems to a refinery in the north of Germany, where this is directly located in a refinery, and they use this, the outcome, the hydrogen and the oxygen, directly in their refinery processes. And we are going to build with the newest application, and with the new product version, we are building another one in the steel industry, where we implement 6 megawatt in Linz directly in a steel plant. So, but this is the actual status, and we're discussing a lot more of applications, and we're discussing already the world is not ending in that size, because if you assume you want to have it as a storage near to a wind park or a PV plant, you have to go into 3-digit megawatt sizes. That means 100 megawatt and larger, which is not there today. But we're discussing about that, and we're preparing, and we're already developing how should that look like, how should the technology evolve so that we can do bigger plants, not just by covering a lot of space, but bigger plants and do them very efficiently so that the price per kilowatt comes down. And this is where there are 2 conditions to go in that direction. The important thing is, at what price do you get the power? And at what price do you get the renewable power? Because the energy or the hydrogen is only green if you use the renewable power. And if you use that one, at what price do you get that? And there are areas where you can get it for 2 to 3 euro cent, and then it is very attractive. The second one is supporting the environment has to support green energy, green hydrogen. That means value hydrogen as decarbonization means. And here you see a bit of mind. Where do we talk? We talk in the Sun Belt. That means Middle East. We talk about Australia, everywhere where you have a lot of sun, and the areas where you have a lot of wind. These are the topics where we are talking about this technology. And we are talking about refineries, we're talking about mining, we're talking about steel and fertilizer industries. So the range is very big. And the time frames for those big systems is not today, it's not tomorrow. It's 2020, the first requests we get, 2025, and also 2030. It depends on how big the plant should be. And there are some of them we talk about 400 megawatt, and this is still some way to go. So what you can see, it is a means for doing storage, but it is also a means for decarbonization and feeding it into other industries. So you can generate the hydrogen, you store it, and you use it wherever it is needed. Thanks a lot.
Counting down right here, she ended at 3 more seconds to go. But besides that, I'm always amazed. Me as a, well, I'm not an expert. I'm a layman, I gotta say. I'm the presenter. I'm always amazed about how diverse this industry actually is and what also Siemens has to offer in all kinds of fields. And we're gonna move on to the next one, and we're gonna be talking about grid connection of photovoltaic utility scale. Now, I had to have that explained to me, what that exactly means. Now, we have residential scale, then comes the commercial scale, and then comes the utility scale, right? From the sizes. And from the modules to the grid connection, the question is what happens in between? And to answer this, we have the global head of photovoltaic utility scale here today. So please welcome him with a big round of applause. Here is Dorko Eliashevich. Almost. Welcome. You gotta say the name again.
Dorko Eliashevsky. So
Eliashevsky.
you
It's
have
actually
to train
way
it. Huh?
easy. I'm
Just
not
say
trained.
Dorko, please.
Have fun.
Thank you. So I found it very interesting what Gabriele told about the triple-digit megawatt power plants. And in fact, we are looking also to the sea laser and how to combine it with our utility scale PV. Please allow me to give you first a little bit an overview about the market and what the analysts are saying. If you're looking for a long-term view until 2040, very long term, I have to admit, then you can see there is a bright future for renewables and especially for PV. 3.9 trillion US dollars will be invested in PV only, PV utility scale. And that is 33% of all the invests. And this is more than it will be invested in wind. Wind will represent 24% of it. Together, more than 50%. And why is that so? Because one very clear fact we could see over the last year, during the auctions from different IPPs, we could learn that the prices are dropping for PV dramatically. This is coming from the scalability effect on the photovoltaic modules. So the modules are getting produced cheaper and cheaper. So what we could see is in Mexico, 3.9 US dollar cents per kilowatt hour. Then we could see in Chile, 2.8 US dollar cents per kilowatt hour. And at least in Dubai, 2.4 US dollar cents per kilowatt hour. And the analysts are saying during the next 12 months, it will go for sure below 2 US dollar cents per kilowatt hour. You will never ever see this on the conventional power plants. So PV, and this should go in our heads, PV utility scale will be the cheapest source worldwide for electricity. And this is, of course, then affecting into the deployment of PV fields. They are getting larger and larger, and therefore, Siemens is taking care also for the grid connection. So what we are offering are not the modules and not the rackings, but we are focusing on the power conversion. So I'm from EM, Energy Management, and Energy Management is looking after the power conversion. So we are taking off the energy coming from the PV, which is the DC power, bringing it into the medium voltage, so-called medium voltage inverter station. The medium voltage inverter station is the key element here, the most important one. If you are just looking to the shares of value, the complete PV power plant, if you say this is 100%, the electrical balance of plant is just representing out of this value 15 up to maximum 20%, not more. It's just a small part, but a very crucial part. Technically seeing a very crucial part. If this is not working, the complete power plant will not deliver you the electricity. So it has a direct effect to the harvest and the efficiency of your field and also on your return of invest. So therefore, it's so crucial. So what Siemens is doing, we are supplying to you, we are offering to you a turnkey system saying, okay, from the combiner box on until the grid connection and even more, also operation maintenance, SCADA system, all of the other things we can supply to you. So having a look to the next slide, I hope it's working now. Yeah. So here you see what we are going to offer. You're speaking about engineering, we are speaking about the planning of the EBOB, financial concepts, so also SFS has some very attractive financial concepts which are providing for you, for example, deferred payment or leasing models, whatever. So here we can help as well. We are taking care for procurement, for the commissioning, warranty, and operation maintenance if everything is installed and commissioned. And afterwards also looking for repair services if something has happened. So we are able to give you an availability guarantee and a performance ratio guarantee to make sure everything which is coming out of one hand from Siemens will work properly. When we are speaking about utility scale, you have to think about the size of those PV installations. As I mentioned, we are already in the triple digits. So we are starting thinking on 30 megawatt, 50 megawatt upwards, not below. And here you can use the full strength of Siemens. We do have excellent products coming from the medium voltage and systems. And here you see the first integration of that in the medium voltage inverter station. So the inverter is one part, it's a very important part, and then afterwards we are transferring the power into medium voltage, so the low voltage which is coming out of the inverter will be transferred by a transformer to medium voltage. And then going into the well-known products, the ring main units, the switchgear stations, all of that which is belonging to the portfolio of medium voltage and systems. And afterwards, we are transferring this with a high voltage transformer also to the high voltage grid. So this is what we are doing. What we are not doing, we are not a full EPC, as you can see it here on the slides. So we are not taking care for the blend preparation. We are not taking care for the modules and the rackings and all of those things. This is not the strength of Siemens, but the strength of Siemens is the conversion of the electricity. So have a closer look to the medium voltage inverter station. This is a very important element in the solution. So here you can say that if you see the invest in the development of a new inverter, this is not just going into the development of the mechanic, electromechanic, conversion of DC to AC. It is also a lot of software in. We are speaking about the harmonics. We are speaking about reactive power. And what is also important to achieve the today's goals of very cost-efficient production, we have to see that this element is also cost-efficient as well. Just to give you an imagination about the size, this, what you see here, is a so-called open skid, and the size is typically 5 megawatt. Could be 4 or less, but 5 megawatt is the most cost-efficient today. And if you are going for a 5 megawatt, it means in a 50 megawatt field you have 10 of them, in a 500 megawatt field you have 100 of them. And they represent more than 50% of the cost of the electrical balance of plant. So very crucial for us, very sensitive item. We are speaking here about power electronic and all the mechanism to protect that. And think about cybersecurity. So we are speaking here a lot about digitalization. You can control here very, very sensitive parameters, like the harmonics, for example. And if a hacker would coming into such a system, of course, that could disturb the grid in total. So that is one of our focus in the monitoring control system and the firewalling and all this, what we are doing to protect the system as best as we can. So if you are looking one after the next of those three parts, as I told you, the ring main unit, this is for protecting your circuit, protecting that in failure case, all the other inverters, if you have 100 in a field, of course you don't want to get disturbance going into the others. So therefore, we are placing ring main units in here. We are going for the medium voltage with our transformers coming from TR. We have a wide portfolio here. And the inverters are, according to our Synacon family, we are naming ourselves as inverter agnostic. So what does that mean? So we are looking also for the best solution on the inverter part. And as you might know, we are cooperating also with SMA in this field, with a world-leading inverter supplier, and working out the best inverter for our complete electrical balance of plant, together with SMA as well. So everything is starting from one point, and that is the starting of the discussion. We are looking very intensively on the so-called single line diagram. And just to give you an overview on that, it's very technical, I have to admit. But from below there is coming the power from the solar modules. And then you see the combiner boxes. And there are a lot of combiner boxes combining the strings, the cables coming from the modules. Why we are starting with the combiner boxes? Because here's the monitoring starting. So we are looking with the combiner boxes into the several strings and have an early detection of failures if there is something happening. And then it goes to the bunch of inverter stations. And the inverter stations, as I said, in high quality, high efficiency, made for harsh environments, they are converting then the electricity into medium voltage. Then in the picture you see everything is collected, and this makes it very visualizing clear. Everything will be connected into one big substation, connecting all the rings coming from the different inverter station, and then transferring them to the high voltage transformer and feeding it into the grid. So in general, this is our short explanation about that. I have to say that we are here in a digital world, and monitoring and control is an extreme important subject. Just think about all the modelings we have to refer to and we have to deliver to the utilities for guaranteeing the grid compliance, and also thinking about all the monitoring control subjects over the cloud, remote control, which has to be protected via our power plant controllers delivered by Digital Grid, for example. So Siemens can deliver a complete portfolio for this solution, everything out of one hand, and if customer has a need, also financed by Siemens with very attractive financing modules. And that is exactly where the customer are looking for those large power plants. They are thinking about partners which are, of course, also existing after 20 years from now, having a good bankability and a strength in all fields. That was my presentation. Thank you very much for this. If you have any question more, you can visit us on our dialogue station, which is on booth number 27. You will find us there over, and we would be happy to answer your question. Thank you very much.
A big hand of applause for Darko. Thank you, very impressive.
Thank you.
How long have you leaving my stage? How long have you been working on that topic?
A long time, and really. Am I still switched on?
No.
It doesn't
No.
sound like.
Anyhow,
Yeah.
a long time.
You
you say.
cannot leave. You should stay. Sure.
Okay, if you can hear me, I can speak also loudly. A long time, and what is interesting, it was also a long time when we have to convince our customers about how important these renewables are. Oh, now I'm coming back, huh? You hear me? And all the time we argumented about being green, and it's so good for the emission, for the environment. But today We have the wind of change and solar, we should say the solar of change, and we see it's more economical. And that is the most important point, and I'm very proud to say that it's the most cheap electricity form we can deliver out of photovoltaic.
So affordable for everybody. Thank you very much, Dorko.
Thank you.
Ladies and gentlemen, yeah, we're back. We've seen how important energy is and what possibilities are offered by Siemens. Offered by Siemens is also another topic, which is one of the hard pieces, and a lot of customers are happy with it. Who does know something about the TIA portal? All right, there are 2 hands up. Also, you also know what the abbreviation stands for, TIA? Totally integrated automation. It's the central tool for digitalization, to be honest. And from engineering until really starting with your machine, you can use it. But what can I say? I mean, I have experts here who know more about it. And I would like to call up on stage Annemarie Lötsch and Oliver Nahr to present the TIA portal.
So, welcome everybody. Today we will show you how you can take advantage of the TIA portal openness for digitalization. My name is Annemarie Lötsch, and here comes my colleague Oliver Nahr. But Oliver, what do you have there?
Well, Annemarie, I can't get through a trade fair like this without some chocolate. And besides, I think chocolate is an excellent fit to our topic today.
So also, I can definitely understand his point. As we are presenting right now, why don't you give me that?
Okay. But what is your favorite kind of chocolate? Is it peppermint? Dark? Okay, dark. Also delicious. Is it white? Or mochaccino maybe? Just as individual as your tastes are, that's exactly how individual the machines must be that make chocolate like this. Now think for a minute, what does this mean for the automation, for the mechanical engineering? It means all that has to be programmed too.
And this is exactly what we are here for today. So we will show you how the TIA portal makes your life sweeter and saves you a lot of engineering time as well. And this sometimes entirely automatically, as the TIA portal is your master key to digitalization.
The openness of the TIA portal enables us to automatically generate a significant portion of the automation code for every case. Of course, I don't need to tell you what that means in terms of saving time as well as money. For us at Bühler, that is a huge advantage.
So there you have it straight from Bühler, a plant manufacturer from Switzerland, making, for example, chocolate machines. It enables their company to create up to 90%. I mean, 90% of the automation automatically. And how? With TIA portal.
Exactly. And it also lets you avoid mistakes. Like this, you can easily configure, modify, and even adapt your installations individually. And this is all done with the TIA portal openness.
The openness interface is your digital link between the planning and the automation. Here how it works at Bühler. The engineers plan each installation individually. For example, a machine to make chocolate. The planning data, in this case in the software ePlan, already contains the devices, the input and output names, the network configuration. So this planning data is exported and later imported into TIA portal.
And the best, this is all done without any additional effort for you. This allows you to integrate the electrical planning data directly from ePlan to TIA portal using the Open Standard Automation Markup Language, AML for short. And this also works in both directions. So you are able to integrate changes from the engineering stage back into the electrical planning.
The openness to planning tools and automated engineering further reduces the project run times. This allows us to cooperate seamlessly with systems such as plant engineering and electrical planning.
Yeah, now we just push the button to take over the planning data into TIA Portal. And it works that easy also for the control program.
Which is exactly what Bühler does. So Bühler is an already living example of how digitalization can also work for your company. And they do it with the TIA Portal openness. First of all, they define standards for the automation functionalities and manage them with the help of the TIA Portal. This allows them to assemble the required plant control program depending on the plant constellation.
And at the same time, the code generator analyzes the planning data and uses predefined components to generate the automation. Since the predefined components are already tested, the automation contains no errors. I mean, no errors. And everything is just done by a touch of a button, an absolutely added value.
The major advantage of the openness interface in the TIA portal is that we can seamlessly integrate our own engineering tool. From the project-specific software model, we can use our steadily growing TIA portal library to automatically generate a significant part of the project. This enables us to implement customer projects in a very short time.
Kinds of melts in your mouth. Completing customer project in a very short time. But usually the control program is only half of the story. What's the situation in visualization? Normally, each machine has its own needs where. So can TIA Portal also offering something for that?
Of course, TIA Portal can. We offer you an intelligent tool to create the visualization automatically. It's called the Semantic Visualization Architect, CVARC for short. This allows you to use the control program and the library of prepared visualization objects to generate the operating device automatically based on rules. How does it look like in TIA Portal? Instead of linking up variables in between the controller and the operating device manually, all I have to do is to click on Generate, and the required images are automatically generated in just a few seconds. And as I'm working with TIA Portal libraries, I'm easily able to define standards and make sure that all my operating devices are structured the same way.
And the changes in the control program will automatically be updated in the visualization. At the end of the day, this eliminates a lot of sources of errors. And the generation of the automation program goes a lot faster.
In this way, digitalization already offers you very concrete advantages today. Automation tasks are performed automatically, and sources of errors are eliminated.
But finally, no plans are alike. Usually you have always individual requirements, and those can be very tricky.
That's right. And therefore, we also offer you tools that make it easier to test new functionalities. The keyword here is simulation.
The PLC Sim Advanced virtual controller, it enables us to test and also to optimize the automation even before the planning phase is over. So we can eliminate errors at a very early stage, and we can also conduct trainings without hardware.
And with PLC Sim Advanced, you are also able to control virtual models of your machines, of your plants, like we've done it here with the NX Mechatronic Concept Designer. This allows you to validate and even optimize your machine sequences or error scenarios before the real commissioning comes along. And the earlier you find an error, the better for you. Because you might already know the rule of 10 that says that the costs of an error multiply by the factor of 10 with each additional development step. So of course, your goal is to find and solve errors as early as possible in the engineering process. And PSSM Advanced supports you to do exactly this.
Sound tests are essential for quality assurance. The PLC SIM Advanced Controllers Virtualization option offers us the perfect environment for the integration tests. This allows us to achieve enormous cost savings with regard to the hardware infrastructure and the lifecycle of the test environment. We'll not only meet the requirements of digitalization, we'll also benefit from it.
The import of the planning data, the automatic code generation, and simulation. All these possibilities are possibilities to implement digitalization in your engineering that you can already use today.
But digitalization is a lot more than that. It also means network information through the whole machine value chain. Therefore, we offer you secured communication protocols. Profinet for communication on machine level, and OPCUA for vertical communication. Like this, you benefit from a seamless connectivity and have the fastest access to all the required production and diagnostic data.
Have you noticed that in the past 10 minutes, we digitalized your entire engineering process with TAA Portal?
First of all, open and intelligent tools automate your engineering tasks, and like this, relieve you of routine processes.
And with simulation, we can eliminate errors at a very early stage. That saves you time, and at the end of the day, the money.
And last but not least, open communication standards allow you to integrate your data into existing processes or innovative solutions.
And now we are done. So may I have my chocolate back?
But of course, here you are.
Thanks.
And also for you, the TIA portal can become your gateway to automation in the digital enterprise. So if you want to learn more about how TIA portal makes your life sweeter, then please don't hesitate and ask us or our experts at the TIA portal dialog stations for further advice. And we would like to say thank you very much.
Na. Yeah, it was all about digitalization, what they just offered to you in the presentation. And I'm switching back now to German language. So bear with me if you don't understand it. If you're looking for another English presentation, there are a lot of them in the afternoon. And you can also check in the internet via live stream. We are available from 9:30 in the morning until 5:45 in the afternoon. You can follow the full program. You can repeat what has been shown on Monday. You can follow us and be with us until the end of the week. So do so. Und jetzt komme ich zurück auf Deutsch. Meine sehr verehrten Damen und Herren, herzlich willkommen. Ich freue mich, dass Sie hier sind. Es geht um Digitalisierung hier, das Motto Discover the Value of the Digital Enterprise. Und ein wichtiges Thema ist dabei auch die Elektroplanung. Ja, die digital verknüpften Tools, die können das Leben eines Elektroplaners definitiv vereinfachen. Wie das geht? Das ist die große Frage. Das ist eine Vision natürlich, dass man das am einfachsten hat, was man da plant, dass das dann anschließend auch funktioniert. Mein Kollege Marcel Schulz ist einer, der einen Teil von dieser Vision schon Wirklichkeit werden lässt. Und was das genau ist, das erklärt er Ihnen jetzt in seiner nachfolgenden Präsentation. Viel Spaß. Marcel?
Ja,
digitale Workflows in der Elektroplanung ist das Thema. Mein Name ist Marcel Schulz und ich möchte Ihnen heute zeigen, was wir darunter verstehen, was wir Ihnen da anbieten können, um das Leben eines Elektroplaners ja, sprichwörtlich einfacher zu machen. Fangen wir an mit der Digitalisierung an sich. Das ist ja ein Wort, das kreist überall herum. Ja, die Digitalisierung ist quasi überall angekommen. Ja? In der Automatisierung, in der Maschinenplanung und auch beim Elektroengineering. Und genau der Elektroplaner oder der Elektroingenieur erlebt auch eine Zeit des Wandels. Das heißt, seine tägliche Arbeit hat sich in den letzten Jahren stark verändert und wird sich auch noch stark weiter verändern. Das sehen wir hier an einem guten Beispiel. Vor nicht allzu langer Zeit hat man noch sehr viel mit manuellen Dokumenten gearbeitet. Mit Katalogen, mit Papier, teilweise sogar noch gezeichnet auf Papier. Das hat sich heute schon ganz stark geändert. Das heißt, wir sind heute schon mitten in der Digitalisierung drin. Es gibt noch wenige Tasks, die irgendwo manuell ablaufen. Wir wissen aber auch, dass morgen die ganze Arbeit digitalisiert sein wird. Das heißt, es wird quasi nichts mehr am Papier, nichts mehr Manuelles erstellt. Alles wird mit Hilfe von Computer und Software gelöst. Sie sehen aber auch den Anstieg der Kurve. Das heißt, nicht nur die Arbeit wird von manuell in digital gewandelt, sondern auch die Komplexität steigt ganz stark an. Das sehen wir an einem Beispiel, wo wir heute schon mit Makros arbeiten, mit digitalen Zwillingsdaten. Das wird morgen noch viel mehr werden. Und genau diese Komplexität, die auch ansteigt, die ist dafür verantwortlich, dass ein normaler oder typischer Elektroplaner nicht nur mit seinen täglichen Aufgaben des Elektroplans konfrontiert wird, sondern eben auch mit klassischen Datenmanagementaufgaben. Das heißt, er wird schon ein kleines bisschen mit zum IT-Fachmann. Er muss darauf achten, dass seine Daten sicher sind. Er muss sich sauber strukturieren. Sie müssen leicht auffindbar und wiederverwendbar sein. Das sind so klassische Anforderungen an ein Datenmanagement, die da auch mit auftreten. Wir wissen aber auch, dass wenn wir genau das handeln können, wenn wir diese Themen ja, täglich ohne Probleme bearbeiten können, dann können wir genau die Vorteile der Digitalisierung ausspielen. Dann werden wir effizienter, wir werden flexibler, wir werden schneller und zuletzt steigt die Qualität unserer Arbeit. Und ein wesentlicher Punkt dieser Thematik ist das richtige Zusammenarbeiten von unterschiedlichen Disziplinen. Das heißt, wie der Elektroplaner, wie der Automatisierer, wie der mechanische Planer, wie die untereinander arbeiten können. Also diese digitale, vernetzte Welt quasi. Das ist das, wo wir ein Augenmerk drauf legen und wo wir Sie auch begleiten möchten. Wo wir eine Lösung anbieten wollen, die für Sie Sinn macht und die Sie täglich unterstützt. Schauen wir uns das Beispiel mal an beim Entstehen einer ganz klassischen Maschine. Es beginnt immer erst mit der, ich nenne es mal, mechanischen Planung. Ja, eine Maschine wird einfach konstruiert. Es werden irgendwann Aktoren, Sensoren definiert und dazu kommt dann die passende Automatisierung und letztendlich auch die Elektrokonstruktion. Das ist ein sehr sequenzieller Prozess, den wir heute abarbeiten. Das heißt, es läuft relativ stark nacheinander ab. Und die klassischen Probleme dabei sind immer, wenn ich irgendwo mal vielleicht einen kleinen Fehler habe oder wenn ich nur eine kleine Änderung habe später im Prozess, dann wirkt die sich oft ganz stark aus auf eigentlich vorgelagerte Prozesse. Das heißt, ich habe viel Aufwand. Oder auf Deutsch gesagt, wenn ich hinten an meinen Daten etwas ändere, dann kommt es vor, dass ich eben durch den Datenaustausch, durch die neue Synchronisation der Informationen viele Aufwände verursache. Und nicht zuletzt oder oft muss auch dieser ganze Prozess mal neu durchlaufen werden. Unsere Vision ist es, diesen Prozess nicht mehr sequenziell zu haben, sondern integriert. Das heißt, wir möchten, dass ein kontinuierlicher Austausch von Informationen zu jedem Zeitpunkt möglich ist. Das sieht man hier mal prinzipiell dargestellt. Ich habe mein mechanisches Design. Ich kann die Informationen direkt zur Elektroplanung schicken. Parallel kann ich sie auch direkt zum Automatisierer schicken oder zum Programmierer. Aber auch der Austausch zwischen diesen beiden Parteien, Automatisierung und Elektroplanung, soll möglich sein. Und das fortlaufend. Das heißt, nicht erst, wenn ich an einem Punkt angekommen bin, dann ist mein Meilenstein erreicht und dann müssen die Daten weitergegeben werden, sondern kontinuierlich. Und so kann ich letztendlich den ganzen Prozess verkürzen. Wie das möglich ist, das sehen Sie, oder das möchte ich Ihnen gern zeigen, anhand unserer digitalen Toolkette. Die digitale Toolkette ist der digitale Workflow, den wir herstellen möchten. Hier sehen wir ein schönes Beispiel, wie diese Maschine, die wir gerade genannt haben, wie die konstruiert wird, welche Tools da zum Einsatz kommen. Und da reden wir nicht unbedingt nur von den Engineering-Tools, wie ein TIA-Portal oder für die Elektroplanung beispielsweise ein E-Plan. Da reden wir auch von vielen intelligenten Tools für die Produktauswahl. Das ist nämlich ein Kernpunkt, den jeder Elektroplaner machen muss. Er muss die richtigen Produkte auswählen. Der Mechaniker muss die richtigen Motoren auswählen, die richtigen Getriebe. Der Automatisierer muss dafür sorgen, dass die die PLC-Komponenten richtig dimensioniert sind. Und nicht zuletzt der Elektroplaner ist dafür zuständig, alle Schalt- und Schutzgeräte sauber in einem Steuerschrank zu vereinen. Und genau für diese Aufgaben haben wir passende Tools. Als Beispiel ein Sizer. Mit einem Sizer können wir heute Motoren und Frequenzumrichter dimensionieren. Das heißt, anhand einer Lastkurve bekommen Sie die passenden Produkte ausgewählt. Mit einem TIA Selection Tool wählen Sie die komplette Welt der Automatisierung aus. Von einer großen Steuerung bis zu einem kleinen, über ASI-Feldbus angebundenes Gerät. Können Sie sauber und einfach auswählen. Natürlich haben wir auch eine Reihe von Konfiguratoren und Dimensionierungstools für den Elektroplaner. Als Beispiel kann ich das Simaris Design nennen. Simaris Design ist ein Dimensionierungstool, mit dem Sie anhand der Anforderungen, welche Motoren Sie haben, ganz einfach auf Knopfdruck die passenden Schalt- und Schutzgeräte auswählen können. Das ist eine Aufgabe, die müssen Sie heute noch relativ manuell machen und die erfordert ganz viel Expertise von Ihnen. Wir können Sie dabei unterstützen. Jetzt ist nur noch ein Problem. Diese Tools sind, ich nenne es mal, eigenständige Tools. Das heißt, Sie haben zum Beispiel mit einem Sizer mal einen passenden Motor ausgewählt und jetzt möchten Sie die Information eigentlich zu Ihren Kollegen geben, die damit weiterarbeiten können sollen. Und genau das wird unsere digitale Toolkette werden. Und ein Punkt haben wir jetzt schon entwickelt, haben wir jetzt zur Verfügung stehen, nämlich die erste Integration zwischen Automatisierung und Elektroplanung. Das heißt, wir können heute schon Daten zwischen dem Produktauswahlprozess für die Automatisierung, dem Elektroplaner und dem Automatisierer austauschen. Meine Kollegin, Frau Annemarie Letsch, hat es Ihnen im vorgehenden Vortrag schon mal kurz angezeigt. Diese Toolkette ist heute verfügbar und das passiert nur über Standardschnittstellen. Das heißt Automation ML, Automation Modeling Language. Mit diesem Instrument, mit diesem Schnittstelleninstrument können wir heute Daten zwischen den Tools austauschen. Und es wird noch weitergehen. Nicht bloß die Automatisierung und die Elektroplanung können später miteinander reden oder können heute miteinander reden. Später können auch noch weitere Tools miteinander reden, genau über solche Standardschnittstellen. Und das bewirkt letztendlich diesen digitalen Workflow in der Elektroplanung. Eine Information muss nicht doppelt eingegeben werden, was natürlich zu Fehlern führen kann, sondern eine Information wird einmal eingegeben und wird dann einfach weiterverwendet von allen anderen Parteien. In dem Fall Automation ML-Schnittstelle können wir quasi Daten vom TIA-Portal ins TIA Selection Tool oder andersrum austauschen. Das heißt Produktauswahl und ich gebe die Information weiter in mein TIA-Portal, wo ich die Programmierung der Steuerung durchführe. Ich kann Daten aber auch direkt in die Elektroplanung schicken, zum Beispiel E-Plan. Das ist ein Knopfdruck. Ich klicke auf Exportieren, speichere mir die Datei ab, gehe in meinen E-Plan, sage Import und schon habe ich alle Geräte dort zur Verfügung stehen und brauche sie letztlich nur noch in meinem Netzplan oder in meinem Elektroplan platzieren. Und natürlich ganz wichtig, letztlich der Austausch wieder zwischen einem E-Plan, zwischen dem Elektroplanungstool und dem TIA-Portal, dem Automatisierungstool. Wir wissen alle, dass oft die Elektroplanung die führende Schiene noch ist. Das heißt, da kann ich Adressierung machen, da kann ich auch teilweise Automatisierungskomponenten auswählen. Und genau diese Information kann ich jetzt per Knopfdruck direkt ins TIA-Portal schicken. Ja, das sind natürlich eine ganze Menge Vorteile, die Sie da genießen können. Ja, das habe ich Ihnen gerade schon mal aufgelistet. Sie haben die Produktauswahl, Sie haben eben die Übertragung der Informationen, Sie können integriert arbeiten zwischen Automatisierung, Elektroplanung und der Produktauswahl. Basis des Ganzen ist bei uns der digitale Zwilling. Das Wort haben Sie bestimmt auch schon mal gehört. Der digitale Zwilling ist nämlich genau dafür verantwortlich, dass diese Informationen ausgetauscht werden können. Wir haben quasi von jedem Gerät eine Menge an digitalen Daten vorliegen und diese Gesamtmenge an digitalen Daten, das ist unser digitaler Zwilling. Und die haben wir auch für jede Ebene zur Verfügung stehen. Das heißt, ich kann keine Daten austauschen, wenn ich keine digitalen Zwillingsdaten habe. Und hier, wie Sie sehen, für die mechanische Planung haben wir die 3D-Modelle. Da haben wir die Produktdaten, da haben wir teilweise auch schon Simulationsdaten. Für die Automatisierung sind natürlich sämtliche Komponenten in digitaler Form im TIA-Portal enthalten, plus die Funktionsweise, damit ich zum Beispiel simulieren kann. Und letztlich für die Elektroplanung sind alle Geräte in bestimmten Formaten, Datenformaten verfügbar, sodass wir auch da in der Elektroplanung sauber arbeiten können. Die ganzen Daten sind auch harmonisiert. Das heißt, Sie brauchen sich quasi keine Sorgen darüber machen, ob ein Datum in dem einen Tool auch das gleiche Datum in dem anderen Tool ist. Das ist bei uns quasi sichergestellt. Und dieses Zusammenspiel, die kann Ihnen Zeit und Kostenersparnis bringen. Und das sehen Sie hier. Wenn wir von einem sequenziellen Prozess auf einen integrierten Prozess umstellen können, dann heißt das schon mal Zeit sparen, weil Sie nicht warten müssen, bis ein anderer Prozess abgeschlossen ist. Sie können einfach losstarten und können so weit arbeiten, bis Sie vielleicht wirklich mal noch Input benötigen. Und letztendlich können wir die Gesamtkosten sparen. Warum? Wir können durch das Optimieren des Designprozesses eines Steuerschranks letztendlich die Gesamtkosten eines Steuerschranks oder auch der gesamten Anlage letztendlich optimieren. Das heißt also nicht nur, Produktpreise sind interessant, das Engineering und auch bei dem Einsatz von digitalen Zwillingsdaten können wir dafür sorgen, dass Sie nicht nur die Engineering-Prozesse optimieren, sondern letztlich auch führende Prozesse, wie zum Beispiel bei einem Steuerschrank sehen wir hier das Beispiel, die Montage und die Verdrahtung optimieren können. Zum Beispiel, wenn Sie die Anschlussinformationen in Ihrem Elektroplanungstool nutzen, können Sie einen virtuellen Geräteaufbau, einen virtuellen Schaltschrankaufbau umsetzen. Und der bietet ganz viele Vorteile, weil Sie zum Beispiel millimetergenaue Kabelplanung machen können. Sie können die Kabel komplett vorkonfektionieren. Sie können sich die Bohrpläne oder mit Hilfe von Bohrplänen sauber Ihr Panel präparieren. Und letztendlich geht es so weit, dass wir automatisiert bestücken und verdrahten können. Das alles sind Vorteile, die wir durch verkettete Tools, die wir mit den Zwillingsdaten in Kombination anbieten können. Es ist also nicht nur Vision, es ist auch schon Wirklichkeit geworden. Digitale Workflows in der Elektroplanung. Wenn Sie mehr Informationen dazu möchten, können Sie uns gerne an unserem Stand besuchen. Der ist gleich hier vorne rechts. Da können wir Ihnen das auch nochmal direkt zeigen, wie das funktioniert. Vor allem dieser Workflow mit dem Austausch der Daten. Und ansonsten bedanke ich mich für Ihre Aufmerksamkeit und wünsche Ihnen noch einen schönen Tag auf der Messe. Vielen Dank.
Liebe Kollegen, haben wir neben dem Marcel noch ganz viele auf unserem Stand. Wo finden wir dich genau?
Sie finden mich genau hier hinter der Bühne, rechts hinter der Bühne.
Na, also dann ist
bei
doch,
den Industrial
da stehen schon zwei auf. Ich glaube, die wollen schon zu dir.
Die werden Sie auch gerne hingelassen.
Alles klar. Vielen, vielen Dank dafür. Ja, dann sind wir auch zeitlich schon wieder dabei, auf den nächsten Vortrag überzuleiten. Es geht um Elektrifizierung trifft Automatisierung, Energiedatenmanagement in der Produktion. Was hat es da auf sich? Ja, Elektrifizierung und Automatisierung wachsen zusammen mit Hilfe der Digitalisierung. Die Digitalisierung dient hierbei als Brücke, aus zwei separaten Tools eins zu machen. Dadurch, ja, was wird dadurch ermöglicht? Was stellen Sie sich vor? Höhere Effizienz, schnellere Prozesse. Und das wiederum hilft Ihnen, Ihr Geschäft so richtig nach vorne zu bringen. Und dazu begrüße ich meine beiden Kollegen, die Experten zu diesem Thema, Mr. 1000 Volt und Bits and Bytes, Sebastian Winkelmann und Edwin Schiersat.
Hallo Sebastian.
Hi Edwin. Hallo und herzlich willkommen zu Electrification meets Automation. Elektrifizierung trifft Automatisierung. Sie sehen, wie die Digitalisierung uns als Elektrifizierern, Schaltschrankbauern oder wie Edwin als Automatisierern hilft, die Anforderungen unserer Kunden im innerbetrieblichen Energiemanagement zu lösen.
Ja, hallo, hier ist Wolfgang Müller. Ja, wir haben ein Problem. Wir hatten einen Auditor hier in der Fertigung und der hat gesagt, dass letztes Jahr unser Energieverbrauch viel zu hoch war. Ja, er meint, das läge in der alten Geschenkverpackungsmaschine. Die ist im Übrigen auch sehr oft ausgefallen. Wir bräuchten also dringend einen Ersatz. Wir bräuchten eine neue Maschine. Wenn Sie sich da was überlegen könnten, das wäre nett. Ja, vielen Dank und bis bald.
Puh, so einen Kunden wie Herr Müller kennt man ja. Er möchte die Geschenkverpackungsmaschine jetzt bis Muttertag überarbeitet wissen. Wer von Ihnen hat auch Erfahrungen so mit diesem Zeitdruck, wie wir ihn jetzt durch Herrn Müller erfahren? Hier oben, ja. Auch auf der Seite der Zeitdruck in der veränderten Planung von der Maschine. Passiert bei Ihnen auch? Ja, also doch gut die Hälfte geht regelmäßig mit Zeitdruck um und muss schnell und flexibel auf neue Kundenwünsche und Kundenanforderungen reagieren können. Jetzt steht das mechanische Design unserer Geschenkverpackungsmaschine steht fest und für mich als Elektrifizierer, ich denke da jetzt sofort an den Schaltschrank. Was meinst du, Edwin?
Ja, jetzt werden viele sagen, das wäre jetzt doch die Gelegenheit, Innovationen vielleicht mal mit einzuführen. Da denke ich vielleicht mal an effizientere Antriebe oder irgendwo Softwareprogramme, die uns helfen könnten, Energieverschwendung zu vermeiden.
Ja. Herr Müller hat uns aber auch darauf hingewiesen, dass die Maschine häufiger ausgefallen ist. Und ich denke bei sowas inzwischen sehr häufig an Power Quality, Netzqualität. Das kann zu Störungen in der Netzqualität kommen und die kann ich wiederum durch dedizierte Messtechnik erfassen und bewerten und somit in der Zukunft vermeiden. Also ich würde hier auch noch dedizierte Messgeräte einsetzen. Dazu der gesamte energetische Footprint unserer Anlage wird durch die effizienteren Antriebe deutlich geringer und ich kann die Absicherung der Maschine hier auch verbessern und auf den neuesten Stand bringen.
So, jetzt werden sicherlich viele sagen, tolle Ideen habt ihr da, aber das hört sich alles an wie das Neudesign einer kompletten Anlage, eines kompletten Schaltschranks zumindest auch. Da stellt sich die Frage jetzt, geht es noch vielleicht einfacher? Kann ich den Schaltschrank zumindest mal den Prototypen einfacher bauen oder brauche ich einen komplett neuen Prototypen?
Wir fangen natürlich mit einem Prototypen an, aber Sie werden es ahnen, auch die Vorredner haben ja darauf hingewiesen, heutzutage gestalten wir so einen Prototypen digital, virtuell. Wir bauen also einen digitalen Zwilling des Schaltschranks, der Maschine, der Anlage. Und dabei können wir nicht mehr nur wie in der Vergangenheit die Stromlaufpläne entwerfen. Wir können den gesamten Schaltschrank in 3D planen. Wir können die Verdrahtung testen. Das Zusammenspiel von Elektrifizierungs- und Automatisierungskomponenten simulieren. Die gesamte Verdrahtung, wie gesagt, lässt sich auslegen und dann natürlich automatisiert kommissionieren. Ja, und so spare ich natürlich wieder Zeit, bin effizienter und am Ende des Tages erhalte ich meine Stückliste und diese Stückliste, die gebe ich doch dann einfach wieder dir in die Automatisierung rüber.
Jeder weiß, in dieser Stückliste werde ich die neuen Hardware- und Softwarekomponenten vorfinden, die ich in meiner neuen Automatisierungsauslegung berücksichtigen muss. So, und während du den Schaltschrank umplanst, kann ich schon mal meine Automatisierung umkonfigurieren.
Genau. Ich plane den Schaltschrank um, und zwar mit einer sicheren, effizienten, nachhaltigen Energieverteilung. Denn diese Energieverteilung oder Energieversorgung ist schließlich die Basis für die Automatisierung. Ohne Strom läuft an dieser Stelle nichts. Die Komponenten, die Niederspannungskomponenten, stellen die Energie zur Verfügung und können sich mit der Automatisierung über Standardbussysteme austauschen. Ja, so ist die Kommunikation sichergestellt und wir können hier die Standardkomponenten verwenden und einsetzen.
Kommunikation ist sehr wichtig, weil wir damit beide Welten, Automatisierung und Elektrifizierung, zum Beispiel mit Hilfe TIA-Portal, Totally Integrated Automation Portal von Siemens, in einer Umgebung bestens vereinheitlichen können.
Und das bedeutet jetzt für mich als Elektrifizierer, dass ich auch meine Messgeräte und meine Leistungsschalter schon direkt im TIA-Portal parametrieren kann?
Natürlich. Das fängt alles schon mal an mit einem gemeinsamen Kommunikationsnetzwerk. Mit TIA-Portal können wir nicht nur das Netzwerk einfachst erstellen, zum Beispiel wir könnten auch die IP-Adressen automatisch vergeben. Und später können wir eine gemeinsame Bedienung und Beobachtung für wiederum beide Welten, die Elektrifizierung und die Automatisierung, erstellen. Sämtliche Alarme beispielsweise wären alle an einer Stelle zu sehen.
Sehr cool. Aber für mich als Elektrifizierer klingt dieses TIA-Portal, diese Automatisierung schon noch sehr komplex. Edwin, was hat sich in der Vergangenheit getan, dass es das nicht mehr ist, dass es jetzt einfacher ist?
Ziemlich viel. Früh hätte man vielleicht mehrere Tools benötigt, um verschiedene Produkte zu konfigurieren und in Betrieb zu nehmen und vielleicht noch zu betreiben. Aber dank TIA-Portal ist das zum Glück alles passé jetzt. Ein Tool für alles.
Ja, hier ist nochmal Wolfgang Müller. Ich hatte vergessen, etwas zu erwähnen. Ja, die neue Maschine muss natürlich in unser Energiemanagementsystem eingebunden werden. Wir brauchen volle Energietransparenz. Ja, teurer werden darf die Maschine natürlich dabei nicht. Ja, vielen Dank, wiederhören.
So, meine Damen, meine Herren, das ist jetzt mal reales Leben. Während wir den Schaltschrank umplanen, kommen neueste Anforderungen für unseren Kunden auf, die wir natürlich in unserer Planungsphase berücksichtigen müssen. Ich bin ja der Automatisierer, bin aber froh, dass mein Kollege Sebastian, der Elektrifizierer, schon die richtigen Produkte vom Siemens-Portfolio ausgesucht hat. Simatic, Centron, Sinamix, Sirius-Produkte. Warum erwähne ich die? Denn diese Produkte können nicht nur ihre eigentliche Aufgabe erledigen, sondern auch noch dank Digitalisierung kann das gesamte Energiedatenerfassen mit erschlagen werden. Ich muss mich als Automatisierer gar nicht mehr um die Umrechnung von Energiedaten kümmern. Das fällt einfach mal hinten ab als Nebenprodukt, sage ich mal. Wenn der Kunde, jetzt haben wir gehört, Herr Müller hat auch nochmal Energiemanagement-Anforderungen, wenn er mal ein Tool oben drüber setzen muss, für Energieeffizienz beispielsweise, können wir nicht nur die Live-Daten, was man schon immer ausgetauscht hat, übertragen, sondern die gesamten Messstellendaten mit wenigen Klicks nach oben übertragen. Und das Beste ist auch noch, wenn Herr Müller nächstes Jahr neue Messstellen anbinden muss, Erweiterungen hat, 10, 20 neue Messstellen, kann er das einfachst machen, ohne dein Schaltschrankdesign anpassen zu müssen.
Ja, und durch dieses Zusammenspiel eben von Elektrifizierung, Automatisierung und der Digitalisierung war es uns möglich, die Anforderungen von Herrn Müller jetzt nochmal zeitnah umzusetzen, auch die nachträglichen Anforderungen, die er uns gestellt hat. Und ich sage, ich lasse jetzt einfach nochmal die Stückliste raus und dann kannst du doch bestellen.
Diese finale Stückliste wird nämlich die neuesten Hardware- und Softwareprodukte für Automatisierung und Elektrifizierung enthalten. Und die kann ich dann in der Siemens Mall platzieren, um die Produkte alle rechtzeitig zu haben. Denn die brauchen wir rechtzeitig auf der Baustelle. Denken Sie dran, der Muttertag steht bevor. Die Geschenke, die hier verpackt werden, brauchen wir für den Muttertag. Und die Geschenke können sogar wichtiger sein als die für Weihnachten.
Durch dieses perfekte Zusammenspiel unserer Komponenten, Elektrifizierungskomponenten, Automatisierungskomponenten, ist es uns möglich, die Anforderungen flexibler zu realisieren. Wir haben die 3D-Daten zur Planung zur Verfügung. Wir sind also hier einfach sehr, sehr flexibel.
Ja, Wolfgang Müller hier nochmal. Hallo. Ich möchte mich ganz herzlich bei Ihnen bedanken. Die neue Maschine läuft wirklich hervorragend. Energieverbrauch ist deutlich niedriger, ja. Und wir hatten keine Ausfälle mehr. Und durch die Energietransparenz konnte unser Personal den Produktionsprozess sogar noch weiter optimieren. Ja, also danke nochmal, dass Sie das so schnell und unbürokratisch umsetzen konnten. Vielen Dank und Wiederhören. Tschüss.
Ja, was haben wir jetzt gesehen? Was haben wir erlebt? Wir haben es geschafft, eine Maschine in kürzester Zeit unter Zeitdruck umzuplanen. Zudem haben wir die neuesten Anforderungen hinsichtlich Energieeffizienz, Effizienzsteigerung mit umsetzen können. Der Anlagenfahrer auf der Kundenseite kann jetzt nicht nur rechtzeitig anfangen zu produzieren, sondern er wird auch die erforderlichen Daten auf seinem Bedienpanel erhalten, um die Maschine noch effizienter zu betreiben. Das alles war möglich, weil wir dank TIA-Portal die 3 Kernthemen Digitalisierung, Automatisierung und Elektrifizierung in einem Tool vereinheitlichen konnten.
Und wenn Sie sich davon jetzt selbst ein Bild machen wollen, laden wir Sie sehr gerne dazu ein. Kommen Sie mit uns mit, 126 Meter in dieser Richtung. Am anderen Ende des Siemens-Standes haben wir eine ähnliche Maschine für Sie aufgebaut, die das komplette Spektrum vom Efficient Engineering des Schaltschranks über das Zusammenspiel der Elektrifizierungs- und Automatisierungskomponenten zeigt, wie diese im TIA-Portal zusammenwirken, wie die Energy Suite es uns ermöglicht, die Energiedaten aus all diesen Komponenten zu analysieren, zu verarbeiten. Ja, und wir gehen sogar noch einen Schritt weiter. Wir können diese Energiedaten dann ganz einfach an unsere MindSphere anbieten, an unser offenes IoT-Betriebssystem, damit die Daten auch für die Zukunft zur Verfügung stehen, in weiteren Analysen genutzt werden können und noch mit weiteren Daten angereichert und verknüpft werden können.
Dankeschön.
Danke sehr. Ganz nach hinten und dann ist eine riesige Maschine da, die könnt ihr gar nicht übersehen.
Energy for Industry, dort stellen wir zur Verfügung. Kommen Sie gerne vorbei.
Also 120 Meter bis ans andere Ende vom Stand. Sie sind übrigens auf dem größten der Hannover Messe und da sind wir wirklich stolz drauf, dass wir Ihnen so viele Lösungen und Highlights präsentieren können, an denen meine passionierten Kollegen das ganze Jahr über gearbeitet haben. Vielen Dank an euch beide.
Danke.
So. Jetzt würde ich sagen, starten wir mit einem kurzen Teaser zum Thema Digitalisierung.
Digitalization is everywhere. Isn't it crazy what's possible nowadays with the use of digitalization? I mean, how much easier things turn out to be, and the number of possibilities that come along with it, endless. It's amazing. And the thing that excites me the most is that this is just the beginning. There's so much more to come. And this again will make our lives just a bit easier. Find out how exactly at the Siemens booth and in the Thought Leaders Forum at Hannover Messe in Hall 9.
Welcome, ladies and gentlemen. For our next presentation, I switch over to English language. I hope you are with me. Discover the value of the digital enterprise. That's the motto of our presentation here in Hall 9 in the Thought Leaders Forum. And I'm proud to present the next topic. And obviously, it's also about digitalization. But let's check what it is about, really. All right, the digital enterprise in the manufacturing industry. I know what you're thinking. How often did I say digitalization now within the last 3 minutes? Digitalization again, how predictable. Good morning.
Yeah, the digitalization is changing everything. What I want to tell you that I don't like the way you talk about digitalization, because I tell you one thing: we're living in some really exciting times. And looking at you, you don't seem to be the woman who likes to be living in the past, right?
Well, yeah, of course. Not everything was bad then. You're right, Magnus. Remember, we had the analog music on vinyl, the crackles, and you sat there, you looked at the LP cover. It was really nice.
Yeah. I totally agree with you. I mean, after all, vinyl is going through a revival as of today. But what you're forgetting is also all the time you spend sitting there on your recording and trying to get that mixtape together, control, pause, recording.
And then the moderator talked into it and messed up your whole cassette, right?
Yes. Can you change the speaker notes a bit, the size of the windows? Thank you.
And, well, then music got digitized.
Yes.
Everything became much more comfortable.
Yes, and that's a very good word, with digitized, because that's kind of what's happening when you go from analog to digital media. But what I want to say here, but you need to remember we are in the age of digitalization. And if you look at the way we're consuming music today with those streaming services of various kinds.
That's cool.
Yeah,
it's really
you
cool
easily
and easy.
put together your playlists and don't have the hassle of copying music onto your little iPod. And thanks to those, a bit of a nerdy statement, those adaptive algorithms, the software is even analyzing your way of listening to music. So I know you're very sporty. Every morning you go for that 10-kilometer run. And the solution actually provides you with music that gets an extra couple of seconds out of your 10K run. Is that nice?
I wish I really could have that for my running shoes, yeah?
What do you mean?
I wish I could have that for my running shoes.
Do you want the shoes that you're running for you? I can look into it. Could be tough to arrange. But what I can tell you, though, is that already today, you can go to certain stores and you can analyze your, say, stature, your weight, and your way of running. And will you get that perfect Christina fit to your shoes in the color of your choice, of course, and delivered in the same time as a mass production product and, of course, in a comparable price.
You start talking now into a lot of technical things. I think I leave you here with your topic and I'm out of here.
Okay. I'll call you back in a few minutes. So that with the shoes is one thing. Things have changed drastically over the last years, and some things remain the same. If you look at the challenges today's industry are facing, you have time to market. It's always been like that. You need to take a product to market as fast as you can. Flexibility, being able to produce those mass customized product to all needs. You need to produce with quality, because poor quality is immediately being punished. And you need to be efficient and, of course, also secure your intellectual property against cyber attacks, etc. And one of the reasons that you guys are here today is probably to discover new technologies. Let me talk a bit about that. If we take the way products are evolving or being developed nowadays, for example, generative design or topology optimization, which is kind of adopting nature's way of creating things, trees and other organic things. We're able to print that on, let's say, additive manufacturing solutions, which is kind of printing either steel or some components in a layer-by-layer type of way, which enables us to create amazing products. So that's the creation, and that's how we build them, and also how products are evolving. I'm fairly sure all of you are one way or the other connected to cloud solutions. Cloud is much more than just storing data. Today, cloud technology is being used to analyze both production facilities and also the product as it is put in use. And the nice thing is, with the data we're collecting, we're able to turn it into knowledge and push it back into the value chain to further optimize the entire cycle. And if you want to incorporate these new technologies into your business, you need to reconsider the 3 steps of ideation, realization, and utilization. And basically take on this value chain approach, which goes from product design and all the way to services. And you want those steps to align. you want to weave a digital thread throughout all those steps. So why is this transformation necessary? Well, to me and to us at Siemens, this is the only way for you as a company to respond to this increasing complexity in products. At the same time, this gives you the opportunity to reduce cycle times, increase margins, and in the end also get more innovation at less risk. And we call this the holistic approach. It's enabled by a team center, which sits as a fundament beneath the collaboration platform, which enables data to flow back and forth. And on the rear side, you got MindSphere, our open IoT operating systems for data analytics. And when you're analyzing data, you basically flow the data back into your value chain. And at this very point in time, you have a complete alignment, data is flowing back and forth, and at this point in time, magic is happening. You're getting a digital twin of your value chain. And with this digital twin, you're able to develop your product in a virtual environment. You can simulate, test, optimize, validate everything in a virtual environment without consuming any real resources, and perhaps also not the need to build as many prototypes. I guess I'm still a bit too theoretical, but it's a really passion of mine to work with this. Let me show you this example, what I just told you, with one of our own products. This is a Simatic Field PG. PG stands for Programmiergerät, and it's German for laptop, I'm told. I might be wrong. It's a fairly tough notebook that's been used in manufacturing environments. It can take one of the other bounds. And let's say you want to simulate or build this laptop. You can use our NX solution to model it up, test it, for all the way from the first idea through the industrial design phase and moving forward. And also simulation and manufacturing planning is part of this very nice solution. Simulation. So if you take a look at a simulation case, in a laptop of this type, you got processors. Processors are generating energy, energy as in heat. This cooling bracket sits on top of the processor. We want to make sure that enough heat is being transferred away as this computer is working. What we see now in this physical behavior simulation, heat development, is that the bracket is too small. What can we do? Take a smaller processor would be one solution. Or since we are in an associative environment, we simply go back to the engineering step and using synchronous technology and expand the size of this cooling bracket. Or perhaps even add one more ventilation hole on the side of the cage by copy and paste, easy like that. Some of you may have heard that we got a new family member at Siemens since a few weeks, Mentor Graphics. So now we also offer solutions for design and simulation of electronic components. So now we can finalize the first part. We've developed a digital twin of the product. And it doesn't stop there. So we have it in a virtual environment. We want to make sure we can build it. And we do that also in a virtual environment using Team Center. And in this environment, we're connecting the product with the process, the resource, and the plant data. Get a bill of process, basically showing what step we need to build this part. We can use that list to simulate the ergonomic on a workplace. This is Jill working. Because it's important to avoid work-related injuries in this type of environment. You can scale her up and down, and the same goes for Jack. What percentage you like? Some environments got robots working, like in this case, a dual-arm robot carrying out the same type of work in a different type of way, because now you need also to program the robot. It's also something you can do in our environment. Simulation of material flow throughout the facility. If you fly up a bit higher and look at the entire facility, it is very important to locate those bottlenecks, scale the buffers to a correct size, and we can even simulate the consumption of energy in this environment to get more efficient in that field as well. And at this point in time, we may also have one or the other machine in the environment, in our 3D environment, and we're able to do what we call automated engineering. So based on our simulation, we can basically push down and generate the PLC code more or less automatically. So we transfer the PLC code from our process simulator environment or mechatronics concept designer environment into the TIA portal, our engineering framework. So the overall result is validated holistically in the phase that we call virtual commissioning. So what you see here is our digital twin of the production line. We got the TIA portal, and we also got PLC Sim Advanced, which is a virtual controller. So we're validating, testing, debugging the code, and then we start producing. And this leads to significant time saves in the commissioning phase. And the rest of the engineering is, of course, done in our engineering framework, as I said before, the TIA portal. And thanks to our world-leading automation equipment and the concept of TIA, the entire production now running smooth and efficient. So that's what the digital twin for the production. So at this point now we're starting to really to produce our product. Sometimes you need to optimize the order of your orders, and for that you have a pre-actor solution, Simatic IT pre-actor, in which you can drag and drop and change the orders in what order you want to produce it. To be fast and efficient and be able to offer quality, you also need quality solutions. Same here. You have work instructions coming down. So this is what you see here in those pictures that will occur soon, like there. That is a spin-off product from the planning phase. It could be also Jack and Jill standing there doing their operations, showing what tools to use. Documents, pictures, and videos can be displayed in Simatic IT for MES. Quality, we want to make sure we are producing quality. And what our QMS solutions are doing is actually monitoring the product throughout the assembly phase. And if you see that one of those bullets goes out of bounds, you can be a bit proactive and basically analyze where this error actually comes from. Better to be proactive than be reacting, I would say. So we're producing our laptop, and with that, a lot of data. Data, as you know, is of a great value we want to use, and with our MindSphere solution, we're able to both analyze the use of the laptop and also the production process. And we turn it into knowledge and feed it back into our process chain. So at this point in time, we've got the digital twin of the product, of the production, and a digital twin of the performance. And the data, as I said, you feed it back to the product and also to the production. The nice thing with our approach is that we got everything on one integrated data model, the team center data model. So no matter where you are on this planet, in what time zone, etc., you will always have access to the right data, to the correct data, the release data, to work with that and able to, and then with that be able to take that decision to make the best out of your situation. So what do you need for all this? Well, it's a digital enterprise suite. As you see here, the fundament of a team center as behind. You got PLM, Product Lifecycle Management, MOM for Manufacturing Operation Management, TIA for Total Integrated Automation, and MindSphere behind it. All connected to MindSphere. And this is probably one of the only ways you can actually get faster to market, be more flexible, produce quality, get even more efficient, and of course also protect your intellectual property. And with that, become the game changer you need today in order for you to enable your digital enterprise and make the future yours. Christina, I'm done.
Make the future yours. Hey, I still have been writing down some notes because your presentation was so interesting. I'm going to ask the audience about bits and bytes in here. No. Thank you very much, Magnus.
So.
Big hand of applause to you.
Thank you.
Ladies and gentlemen, if you want to hear... Actually, all over the booth, but the heartbeat of the digital enterprise can be found right in the center of our booth. This is also where you will find Magnus and his colleagues. It's all about digitalization and data. There is a lot of data generated, and what are we doing with the data? Where is the data going to? You all heard about cloud services, and MindSphere is the cloud-based open IoT operating system from Siemens. Let's see what it is about in a short video.
Digitalization changes everything. The volume of data is growing day by day. And just the amount of data I'm producing by accepting this order is incredible. But how can we use this data in a smart way? How can we benefit from it? Find out how at the Siemens booth and in the Thought Leaders Forum at the Hannover Messe in Hall 9.
Siemens booth, Hannover Messe, Hall 9, Thought Leaders Forum. You're here. And also here are two experts who will explain what the MindSphere is about. Please welcome up on stage Sebastian Wolf and Matthias Lutz.
So, very good afternoon. My name is Sebastian, and actually I was hoping Matthias is somewhere around because normally he's doing the presentation with me. Matthias, where are you?
Sebastian, I'm sorry.
This happens now since 3 days. What's
I
going
never
on?
had an Hannover fair with such a customer interest in MindSphere. It's crazy. Have you ever been on a cruise ship?
Well, I've been on a cruise ship a couple of years back, but what has this to do with our presentation here?
Sebastian, I just talked to a guy. He wants to connect cruise ships, whole cruise ships, big like a small city, to the Internet of Things.
Okay, hold on. So we're here at Hannover Fair in Hanover, obviously. And we were talking about MindSphere quite a lot. But when I remember last year, we were talking about connecting motors, drives, machine tools, these kind of things. So why now a ship?
Sebastian, a lot of things can happen within 1 year. 50% of all the data generated worldwide since beginning of humanity was generated last year, and only 0.5% was actually used. Only 0.5%.
Okay, so that's not a lot, yeah? But why is this not happening? I mean, 0.5% sounds to me like a great opportunity to do business.
Of course, and imagine, for example, with the cruise ship, the operator of the ship knows exactly how the ship is performing, how all the hardware, drives, engines are performing. This would be of a tremendous benefit for you, for the operator, for everyone in the supply chain.
Okay, so a lot happened over the last year, so that sounds amazing to me. But I mean, we're here in Hanover, and what happened over the last days?
Yeah, it's our third day. We made the half of the third day, and just today, more than 5.5 million devices are getting connected to the Internet of Things. So while we are talking here, hundreds of thousands of devices are getting connected to the Internet. So a revolution is going on.
Okay, so 5.5 million devices getting connected every day, and only 0.5% of all these devices is used. I mean, Matthias, that sounds to me like a major challenge, yeah? So how can we tackle this? I mean, what is the overarching topic? Why is it so important that we are here and talk about it?
I think all of you experience that digitalization is changing everything. Your private lives, how we interact with other systems, and digitalization is changing as well the whole industry which we are in. And MindSphere is our solution for your path to digitalization, and MindSphere changes everything.
Okay, now MindSphere is the IoT operating system, but let me come back to your cruise liner.
Yeah.
So, I mean, I understand connecting a machine, yeah, because you have it on the ground and you can put a cable. But how do we connect a cruise liner?
It sounds pretty complicated, doesn't it? But with MindSphere, we are offering a whole connectivity suite. A suite of hardware and software which allows you to connect each and every machine, from a small motor to a whole cruise ship to the Internet of Things. And this works like that. You will see here on the booth a couple of so-called Mind Connect elements, ranging from dedicated IoT gateways, like our Mind Connect Nano, to Siemens products, like drives, like control systems, PCS7, which are directly connected to MindSphere.
Okay, so but how does this work? I mean, we have a Mind Connect Nano. What is this?
It's a small box, big like a carton of milk. It comes with a very easy configuration, and you just plug it in to a PLC, for example, a Siemens PLC. It speaks open standards, such as OPC UA. You plug it into the internet, and you are securely, also very important, securely connected to the IoT based on MindSphere.
So what I would be curious about is how long would it normally take to connect such a cruise liner to MindSphere?
Okay, a cruise liner is quite a big machine, so maybe as big as this hall here. But going to a typical industrial machine, like a filling line, for example, it takes you from connecting to visualizing and analyzing the data roughly 30 minutes. So our experts and your experts can do it within a matter of half an hour, 1 hour.
Okay, that sounds absolutely stunning to me. 30 minutes and you're online and you have the data, you can work with it. That's great. But Matthias, the MindConnect Nano is a Siemens product. I assume that we have not only customers here at our booth using Siemens product. What about third-party products? How can they use the data from the machine? And do we have a solution for this as well?
I personally believe that openness is key to build up an ecosystem which is benefiting you with your needs in the industry. And from the beginning, our design criteria for MindSphere was openness. Openness on the connectivity side and openness on the app side. So to achieve this, we are bringing as well an open connectivity software layer into the game called MindConnect Library. I always explain it as a piece of tools or toolbox which you can use, any other hardware developer can use to engineer his own IoT connectivity, MindSphere connectivity in literally each and any hardware device.
Pretty cool. So let me sum this up. We have connectivity from Siemens, but we have also software solutions that can be integrated in third-party products. So basically, we make it very simple to connect, and in a couple of minutes, you can use the data. So great stuff for me. But Matthias, next question would be, once the data is in the operating system, what happens next?
Connecting is key, but connecting is as well, let's say, the base. While connecting security devices, we can capture data, we can store them in a platform in the Internet of Things, but the whole story gets interesting when we are thinking of apps.
Wait, 1 second. Apps? Like on my smartphone?
Yeah, apps. So you remember maybe, so the iPhone was released in 2007. It was by then a very nice phone, but it didn't come with any app store. And the whole thing began to be very interesting when this US-based company released the App Store. And nowadays, I'm using my iPhones in the morning when I wake up. I turn on the radio. I use it for navigating in streets. I use it for booking flights, for everything. So the App Store and the concept of an open ecosystem made it a really tangible customer benefit and a whole world of possibilities.
Okay, so we will see a lot of applications. So you're telling we see a lot of applications for the industry in the same concept like of an app store. But Matthias, what would an application for a cruise liner look like? And what is the benefit out of that?
So for me, a cruise liner is a very big machine. And like in machine building or in other industries, discrete and process industry, everything starts in digitalization and the Internet of Things with making the things visible. Therefore, our standard and basic app in the MindSphere is the so-called Mind App Fleet Manager, which allows you to visualize your things, in this case cruise ships, all over the world. You can even use this Fleet Manager to start an interaction between a service provider, maybe the maintenance department of the cruise liner, and a service consumer. In this case, I would call it the captain maybe. He's in charge of operating his ship. And you can immediately start to analyze your data based on our visualization and analytical capabilities. That's the start, the Fleet Manager.
Okay, so but how would this help me as a cruise liner operator? What can I benefit from such an application?
So Sebastian, imagine you are on a remote island in the Caribbean, and the cruise liner you're on is bound to the harbor because the drivetrain doesn't work anymore.
Okay.
Wouldn't it be of a great benefit if this cruise liner knew before when this drivetrain will break? So this is possible today, possible based on data analytics in the Internet of Things. So the cruise liner benefits, saving costs, and he has more happy customers, Sebastian, which can cruise to the next nice island in the Caribbean Sea.
Okay, so prediction of failures is one thing that you're saying is benefiting the whole thing. Sounds interesting. But it sounds like also applications from Siemens, but can anyone else do applications, program applications for MindSphere?
That's the real cool thing. And Sebastian, I didn't experience anything like this before on the last fairs. I'm walking around here talking to customers, talking to app developers, and they really approach us. Okay, listen, got it. I want to develop apps. How can I start it? And that's why we are opening up MindSphere. And we are enabling app developers, customers, machine builders to develop apps for MindSphere, deploy them, and distribute them in MindSphere. So I have seen very, very cool ideas for apps during the last 3 days. And on our MindSphere booth here, you see as well this little vending machine. It's our app store. And there you can already see a lot of Siemens apps for Siemens hardware here, for example, for charging stations for electrical cars. You can see apps from partners like Atos. They are showcasing and a running app here for the dairy industry, and they are monitoring this dairy line. So great. For each and every application industry, you will find an app in MindSphere in future.
Wow, that's really cool stuff, Matthias. I cannot say anything more. That's really, really cool stuff. So, Matthias, I mean, we heard about the easy connectivity and the plug-and-play things. So we learned about applications. So you just said before, digitalization changes everything. But to me, it also sounds like that MindSphere changes everything. What to expect from MindSphere?
MindSphere changed everything for me. And you see it here really like in our MindSphere lounge. It's not only about a piece of technology. It's not only about a piece of connectivity. It's not about bits and bytes. And you really see as well how our discussions with the customers are, let's say, advancing. 2 years ago, we were talking about protocols like OPC-UA, bits and bytes, Modbus. And nowadays, we are talking with our customers about new business models based on data. Business models, for example, for hardware providers, which don't want to sell their hardware anymore, but their output. So this shows really the transformative character of MindSphere, of the Internet of Things, and of digitalization. And what I also want to highlight, what is really great, here on the Siemens booth, you see a lot of devices from Siemens directly connected to MindSphere, and from many of our customer industries, you see specific apps. So great. A lot of things are, let's say, starting, growing. Every day we see more apps, more connected devices, so a whole new universe of possibilities is there.
Okay, so what I will do now is I will go to the MindSphere booth. I will get my hands on the connectivity, try it myself. Then I will talk to our partners about the apps, maybe get some great ideas myself.
Yeah.
And then I will be up in the MindSphere lounge, and I can only invite you to do the same. And with this, we would like to thank you for your participation and see you in the MindSphere lounge. Thank you so much.
See you there. Bye-bye. I have to run.
Thank you, Matthias.
Bye-bye.
Thank you, Sebastian. Great presentation. Is everything clear? Collect data, what you can do. Yeah? So if not, MindSphere, that's the UFO-shaped area above our food and beverage exhibit. So if you want to go into the data cloud, you have to go 1 floor up to the MindSphere. But do stay here. We will be more touching topics which are connected to the MindSphere. We're talking about how totally integrated automation for MindSphere works. TIA, Totally Integrated Automation, that's what it stands for. We've been talking about that we generate data. A lot of data is generated. For example, 5.5 million assets are connected to the Internet of Things just here on the fairground. That's about the city of Berlin. I mean, it's massive amounts of data. But I'm asking myself, this data is generated. Okay. Where is the transfer cut between the generation of the data and where it arrives, that you actually can do something with it? Must be difficult, I suppose. And since I'm not the expert, I'm just the one who is introducing the experts. I would like to call up on stage Katrin Kunz and Timo Mühlhausen. Good luck.
Welcome. Welcome to our presentation about totally integrated automation as the foundation to generate data and to transfer those into MindSphere. We will show you how simple it is. And believe me, it's not, as Christine mentioned, might be difficult. It's really, really simple. I'm doing it not alone. My name is Timo Mühlhausen.
And my name is Katrin Kunz.
And in order to start, we would like to give you an overview. Where does data from the automation come from?
Right. And the data comes out of the Digital Enterprise Suite. The Digital Enterprise Suite is a suite of software components which lay the foundation to realize the digital enterprise. It is composed of 5 key portfolio elements, starting with product lifecycle management. Product lifecycle management is the key to transfer your innovative ideas into marketable products. On the other side, we have the totally integrated automation, which seamlessly integrates automation components on a horizontal, but also on a vertical way, from the field to the enterprise level. In between, you find manufacturing operations management with our real-time software layer, Simatic IT. It transfers from the virtual world of product development to the real world of production. And of course, we store everything within one central database, which is our collaboration platform, Teamcenter. If we go one level higher to the cloud level on top of the roof here, we can do data and lifecycle analytics. And the cloud helps answer a question which a lot of companies have. How can I optimize and continuously improve my production based on data?
But let's focus on 2 aspects. Most importantly is now how to transfer data from a totally integrated automation portfolio into MindSphere. And for this, a comprehensive portfolio is needed. It's a foundation in the production of the digital enterprise. And this foundation starts with a comprehensive portfolio on the field level, goes up to the controller level, even higher to the operations level.
And on all levels, data is generated. Like, for example, within controllers like our S7-1200 or S7-1500 PLC. Also within PCs, with our industrial PCs, or even one level higher, you can also transfer pre-calculated data within our SCADA system.
But one thing makes all this portfolio very unique in the market. That's one single engineering framework, the totally integrated automation portal, or short TIA portal. With this single engineering framework, the automation engineer can bring life into each single component.
Right. And if you want to connect even higher levels, such as IT level or MindSphere, you have to have a perfect fitting network as a backbone.
And data, as we've heard, are generated everywhere. But the value of data is growing along this automation pyramid. So the higher the data is aggregated, the more value is in the data. So we have several possibilities to connect to MindSphere.
The first possibility is to use integrated functionality within our PLC, within our S7-1500 PLC. And you can use connectivity using Mind Connect function blocks.
And I would say in the middle, there we have gateways. A Mind Connect Nano, or even third-party gateways to connect existing machines. Those gateways have appropriate connection interfaces like Profibus, for instance, to connect even already installed machines in your production line to MindSphere.
The highest value data is generated within SCADA, and SCADA can also be directly connected with MindSphere. Now, I have a question to all of you. Who is already transferring data into a cloud? Data from your enterprise into a cloud? Some are doing so. So it's simple, isn't it? Transferring data is good and it's a basis, but it's not all. I mean, within the cloud, you have to do something with the data. You have to add further information to the data to get further insights. I would like to make a concrete example now. Let's assume within your enterprise you have various types of machines. Let's say you have a machine park. Every machine generates data. And this automation data can be combined with information from other domains, such as temperature information, geographical information, maybe also pressure information. And you get further insights of impacts.
So, in other words, I can do predictive or preventive maintenance scenarios. I can schedule my maintenance slots.
Exactly, Timo. So you can keep your machines running because you know in advance when the next maintenance slot needs to be terminated, for example. And this works globally. You can connect various locations and also perform a benchmarking.
Well, this is, for me at least, a huge benefit because I can understand, I can document the lifetime of the machines I may be supplied to all my clients. I can understand in which performance parameters was this machine really operated.
Right.
But let's focus on maybe the most simple way to connect machines to MindSphere. And I tell you, it's really, really simple.
Right. You can use the Mind Connect function blocks within your S7-1500 PLC. And you just need to follow 3 very simple steps connecting your automation to the MindSphere world. First, you define which asset you want to connect. Second, you configure the asset. And third, you just go into MindSphere and observe your data. To make it a little more concrete, I would like to go a little more detailed into the steps you have to configure. So we start within MindSphere. So you define the asset you want to connect to. In our example, we want to connect a S7-1500 PLC. And this S7-1500 is located here on the Siemens booth. So the location is Hannover. You just store this information, get an asset ID and an onboarding key. And this was basically everything which you have to do in step 1. The second step is within our TIA portal. But before you can do something within the TIA portal, you need to download the Mind Connect function blocks from our SIOS platform. SIOS is our Siemens Industry Online Support platform. And there you can download the S7-1500 Mind Connect function blocks for free. Just download them and add them into the TIA portal library. Then you can drag and drop them into the PLC program whenever needed. Furthermore, you insert the credentials, asset ID, and also the onboarding key, which you need to log on to MindSphere. And third, you define which data you want to transfer to MindSphere. And this was basically everything. You just store the program and download it into your S7-1500 PLC. And this was everything you have to do in step 2 within the TIA portal. Then we go to the third step, Timo, right?
Exactly. So I leave my known environment, the TIA portal, and I go back to the browser. I log into the Fleet Manager, and I navigate to, for instance, a robot cell, which we have here on the booth. I can simply monitor performance data as you have seen here. And if I have a closer look, I see there's some alert. Probably, maybe someone will accompany me to this nice exhibit, and we can, I would say, check out this alert. It's located, what a surprise, directly here in Nuremberg. So that's not the only showcase we have here.
No. So we have two showcases where we show the connectivity, the simple connectivity to MindSphere. The first one is our Bausch and Ströbel Corporation machine. This is a pharmaceutical use case where we use the gateway solution to connect to MindSphere. We have MindConnect Nano in there, and they transfer operational data to the cloud.
And this robot cell stands in the core of our entire booth, I would say in the digitalization core. There we have a connection with the S7-1500, everything engineered with TIA Portal, so the environment I like as an automation engineer.
Right. Now, thank you for your attention. We invite you to get to the showcases and convince yourself about the simple connectivity to the MindSphere cloud.
Thank you, and see you in a couple of minutes.
We have further questions.
Just, I would say, in front of MindSphere, in the ground floor, there we have the robot cell.
Exactly. And you would find me in the HMI IPC area.
And this is also like in the center of our booth, right next to,
exactly,
underneath the MindSphere area, in front of the food and beverage.
Right.
All right, thank you very much. Big hand of applause.
Thank you.
At the end of this presentation block, and we'll go into a 50 minutes break.
Okay.
Ladies and gentlemen, if you're interested in what's up at our stage program further on, please do have a look into our program sheets here. You can find which presentations are coming up in which language, but you also, if you have no time anymore and you think, oh, I would love to see more of these presentations and listen to the experts, use the possibility to go on our live stream. So even though you have to leave Hanover today, you can be with us tomorrow and on Friday, because via our YouTube channel, we are live streaming all the presentations which are shown here. So do use the chance. You can also go back to Monday and see what has been happening here when the Chancellor, for example, was here for her visit, or if some other interesting panel discussions have been going on, you can repeat these and have a look into these. Further on, we will have the next presentation starting at 2 o'clock precisely, and it's about the heart of the Siemens technology. It's about the Simatic PCS7. The 9th version already is on the market, and my lovely colleague Manuel Keldenich will present that. But before, we will have a few possibilities to see all the highlights what we are presenting here at the booth, and we will run some videos on the screen. So enjoy your time, enjoy your break, and we'll be back with you in 15 minutes. Thank you. We're back. Welcome, ladies and gentlemen, and do come closer. We just started with our program. Don't be shy. We have super comfortable seats here. Your feet might be hurting because you've been running around all morning, maybe even yesterday. Been partying probably, huh? So come here, do take a seat. We just start with our presentation from the experts to the experts. Listen and learn and find out about our solutions and innovations from Siemens. Here, Hannover Messe. We're here for the 70th time. And you're at the largest fair booth at the Hannover Messe, 3,500 square meters, full of innovations. And what we are doing here as well is not showing exhibits and solutions at the booth. We also present what our experts within Siemens are working on all year, and they are super curious to show you what they have been working on and which solutions we provide. And one of my colleagues, Manuel Keldenich, is working on the Simatic PCS7 version 9 already we have. It gives the room for new perspectives in process automation. And the new version of our distributed control system, Simatic, is using Profinet. And the new hardware is bringing digitalization down to the field. And what that all is about and which content really is included in this, Manuel Keldenich, he's going to tell it to you.
Thank you very much, Christine, for the nice introduction. Welcome also from my side. I'm going to talk a little bit about room for new perspectives in process automation. And the next couple of minutes, I will tell you what that means. So when we're talking about digitalization all day long, we're coming from the mind sphere. We talk about the digital enterprise over there. And with our solution, we really need to go down to the field level where all the process instruments, flow meters, pumps, etc. are installed in the field. And in the process industry, we have different challenges. On the one hand side, plant availability is key because you can imagine the plant is only really running economically and providing value in the time it is running and not in the time where it's shut down. So investment protection is another really important challenge that we have to face because the investment into a process plant is really huge, and then it is running, has a runtime of about 30 years, sometimes more, and within this time it will not remain the same as it has built and planned and engineered in the beginning because you have to modernize it, you will have to extend it, rebuild it. So how can we overcome these challenges, especially in regard to modernization and brownfield projects? And as you might imagine, when you have a look at the Siemens booth, digitalization is the answer. And when we talk about digitalization, Profinet as an industrial Ethernet standard helps us to bring digitalization down to the field. And what that means and the benefits I'm going to show you right now. I mentioned Profinet. Profinet as a communication standard enables us to provide communication in nearly real time. And what's really important for us is that we can have really flexible and scalable network structures. That means it is really much easier than with the common solutions to set up the networking structures and provide the communication in time to all stakeholders, from the field devices to the operator station where the operator of the plant is sitting and coordinating each and everything. Based on Profinet, we developed our new hardware innovation, basically. And that's why we talk about room for new perspectives, because we enable our customers to get more space within their plants and more flexibility in regard to modernization projects. When I talk about hardware innovation, we have 3 major levers within our new Simatic PCS7 version 9 control system. One is our remote I/O Simatic ET200 SPHA. Then we have a compact field unit that allows us to go with a really decentralized approach. And for sure, as we're talking about a complete system, we also have software innovations that make it much easier for the operator and the maintenance staff to operate the plant. Starting with a couple of use cases of our new remote I/O Simatic ET200 SPHA. SPHA stands for high availability. That means we have a redundant Profinet connection that makes sure that it is operating. And even if there's an interruption, like an error or a defect module, it does not have an effect on the process. Means the availability that I mentioned in regard to challenges in the beginning will be there consistently. We talked about space a little bit. And first of all, we reduced the width of the remote I/O by nearly 50%. The benefit is that you can put much more of these remote I/Os into your cabinet. And in the end, you can operate with less cabinets, more devices in the field. For us, that means we can put behind a head-end station, this is the one here that is connected to Profinet, with up to 65 modules. In the past, or with our existing solutions, we are only able to connect 12 modules. And what this means is that we can integrate into a standard control cabinet more than 900 or 1,000 I/Os, depending on how you use the space, and that's quite a lot. Another topic is that we get rid of distribution cabinets that are placed within the plant or in the control room, because we have standardized terminal blocks and we do not need MTAs down in the field. That means also we reduce a lot of cabling, and so we have more space available for modernization projects. The other use case besides flexibility is what we call change in one, online change. When we change different modules, we can, for example, see we have an error in module number 6. What do? We just put it out, replace it with a new one with a push-in technology. We do not need any equipment to exchange it. The error is fixed and it continues to run. We do not have a downtime. It is all operated online in run. And what are the benefits of this? It's obvious. We don't have the downtimes. The risk of errors or failures is minimized absolutely. And so, the plant is up and running. Another possibility that we have with our new remote I/O based on Profinet is that we can standardize the setup of the control cabinets. That means we have uniform terminal blocks that we use, and insert it into a cabinet, so we can pre-configure it already and use a fixed wiring. And for our customers, that means the factory acceptance test is much shorter. We have the documentation available. And for sure, the costs and the effort for the planning process, for the commissioning, for the installation is much lower. So you have direct effect. And in case of troubles, troubleshooting is much faster done. So summing it up, the benefits of our new remote I/Os is, on the one hand side, it is designed for field use. You can also put it down in the field on site in a temperature range of -40 to +70 degrees, which is, for example, important if you think about an oil rig being operated in the Norwegian Sea. It can be implemented in up to X zone number 2. We have much more connection, and I already talked about the cost and space savings. Another innovation, a real innovation that we have, is our compact field unit. this one enables a really decentralized approach. And what that means, you can see here. You have the mixer, you have the tubes, you have the connection, and you have the redundant Profinet interface. It can be installed outside in the field, also to X-Zone 2. And the benefit is that things that you had to place within your cabinet in the past can now be put with a simple box of this size somewhere in the field. You have the Profinet connection, you need much less cables, making a complete cabinet new. Another use case is the device integration that I can show you right now. You see the flow meter over there, it's red. There has been an error, for example. This happens at night, and now you inform your maintenance staff, oh, there's an error in the plant. You have to go and exchange it. Nowadays, you need an expert who goes there, does a completely new cabling, makes the assignment within the software. And this is a process that lasts over round about half an hour. The compact field, and due to the automatic address, recognizes which device is connected, gives an information to the control system, and you just have to confirm. And yeah, within a click of a button, you have exchanged the field device, and things that lasted up to 30 minutes, now it's done within 1 minute and one press of a button. So we call this plug and produce because it's quite simple, or similar to the way you connect a printer or a mouse to your computer at home. So benefits, for sure, you have much higher flexibility because you can go with this decentralized approach down to the field. Enormous time savings and cost savings, it's obvious. Just to sum it up, we also have some software highlights in our new distributed control system. On the one hand side, we can much easier integrate field devices into the software with our new thematic process device manager, version 9.1, which is a perfect supplement to the compact field unit and also now has Profinet capabilities. With our new thematic batch, we have the opportunity to import recipes from an external system easily and do the equipment module engineering, the equipment moduling in a separate step. In the past, it was just one process, and now you have two different approaches. So our customers are much more flexible when they are doing it. And this is something relevant for pharmaceutical industry, for example, in regard to recipe management or for food and beverage. With our new maintenance station, we have some functionalities that make sure that the data from the mechanical or the maintenance stuff in the field is much better or much more efficient integrated with the control system, so we have a vertical data consistency enabled. And with our management console, we can make sure that our customers always have an up-to-date information on how their hardware, their software, their installation in the field, which status it has. And we can support them in addition with information on how they can optimize their equipment. So at a glance, our customers benefit from less workload, minimized error potential, they have time savings, and the data and the documentation is always up to date. This is something really important, for example, for pharmaceutical industries, because if a legal authority like the TÜV comes and says, okay, I need the documentation for this and this process, you have it there just right at the push of a button. Yeah. All this plays together when I'm talking about room for new perspectives with our DCS. And yeah, just to sum it up, we have more flexibility and scalable based on our new hardware and Profinet. We have space and thus cost savings for the cabling, etc. And in the end, our customers benefit from higher profitability. Thank you very much for your attention from this time. And yeah, have a nice day here at the Hannover Fair at the Siemens booth.
Thank you, Manuel. Perfect.
Courtyard, which is really interesting. You can see us and discover it all for yourself, and you can prove that what I told you is really the truth, and it's working out perfectly. Thank you very much.
It's not just
Bye.
a fake show, it's really happening
real, yeah.
here. Thank you, Manuel. Perfect. Yeah, ladies and gentlemen, it's all about digitalization. And I'm swapping over now to German language, so please, I'm really very sorry, bear with me, but the next presentation is in German language. Und deshalb starte ich jetzt auf Deutsch. Begrüße alle recht herzlich, die Sie neu dazugekommen sind. Willkommen hier im Thought Leaders Forum auf dem Siemens Messestand in der Halle 9. Die Industrie, die steht vor sehr großen Herausforderungen. Immer schnellere Innovationszyklen und Time to Market sind ein Schlüsselbegriff hierbei. Es braucht Lösungen, um diese Marktanforderungen auch erfüllen zu können und ihnen gerecht zu werden. Umrichter und Motoren müssen vernetzt werden, um weitere Effizienzvorteile zu erreichen. Mein Kollege Thomas Kühnrich, der aus dem Drives-Bereich bei uns hier kommt, wird Ihnen entsprechende Informationen bieten, wie Digitalisierung im Bereich der Antriebssysteme bei uns realisiert wird. Thomas Kühnrich, bitte auf die Bühne.
Grüß dich. Wie geht's dir?
Hallo Thomas, ja, was soll ich sagen?
Viel los, oder?
Dritter Messetag. Dritter Messetag.
Richtig,
und
ja.
der Stand ist voll. Da hat man
Wunderbar.
schon Probleme, sich bei uns hier auf dem Stand rechtzeitig an die Position zu bewegen.
Mir ging
Wie
das
ging es
genauso.
dir heute?
Ja, es war der Wahnsinn. Alles vorbereitet, aber jetzt freue ich mich, hier auf der Bühne zu sein und
Hast
heiße
an
Sie alle
alles
herzlich
gedacht?
willkommen.
Hast du an alles gedacht?
Ja, aber Moment. Ein was habe ich, glaube ich, vergessen, wo wir es gerade ansprechen. Jetzt habe ich mich so geschickt und habe zu Hause vergessen, das Licht auszumachen. Ich hoffe, aber liebe Gäste, es gibt ja auch tolle Lösungen mit Smartphones und da frage ich mal das Smartphone, ob das zu Hause bei mir das Licht ausmachen kann. Einen Moment, wir probieren das einfach mal.
Okay, das Licht ist ausgeschaltet. Viel Erfolg in Hannover.
Also wie gesagt, es gibt so viele Funktionen jetzt heutzutage, dass man sogar zu Hause das Licht ausschalten kann.
Mir
Also,
scheint so, als wärst du so ein Technikfreak. Und ich glaube, das wird jetzt sehr interessant, was wir hier sehen von dir.
ja, danke schön für die
Viel
Einladung.
Erfolg.
Jawohl. Also nochmal herzlich willkommen. Sie können ruhig näher kommen hier. Die Kameras können Sie dann vorbeilaufen. Sie sind alle herzlich eingeladen. Ja, worum geht es heute? Wichtiges Thema, Digitalisierung und vor allen Dingen auch in den Antrieben. Das mit dem Smartphone war natürlich eine Einleitung, das, was wir im privaten Bereich sehr, sehr schätzen. Das heißt, über die Vernetzung von Komponenten wie zum Beispiel Smart Home haben wir wesentliche Vorteile. Das heißt, wir können dezentral auch die Anlagen zu Hause steuern. Und das, was sich natürlich zu Hause oder privat durchzieht, sehe ich auch und viele Kollegen in der Industrie. Denn die Industrie steht natürlich auch, wie Christine schon gesagt hat, vor Herausforderungen. Immer schneller müssen die Produkte auf den Markt kommen, natürlich in unterschiedlichsten Formen, unterschiedlichsten Farben und das recht schnell. Um das zu erreichen, müssen natürlich auch unsere Antriebssysteme hier mitspielen, digitalisiert sein, damit ihre Produktion niemals steht. Darum geht es heute. Ich bin Promotion Manager für die Antriebe. Jetzt versetzen wir uns mal in die Lage, Sie als Gäste wären jetzt ein Anlagenbetreiber oder vielleicht sind Sie es sogar, dann stehen Sie ja auch vor großen Fragen immer. Sie beschäftigt meistens etwas, nämlich zum einen möchten Sie ja nicht, dass Ihre Anlage vielleicht mal stillsteht. Das ist doch das Schlimmste, was Ihnen passieren kann. Oder vielleicht hatten Sie schon mal einen Anlagenstillstand. Und das Resultat daraus war natürlich, dass der Anlagenstillstand sehr, sehr teuer ist für Sie, jede Minute, wo Sie nicht produzieren. Und es war vielleicht auch schwierig, dafür den geeigneten Servicetechniker herzubekommen, der auch genau Ihr spezifisches Problem versteht. Und das sind eben die Herausforderungen, die wir uns heute mal anschauen werden. Vielleicht haben wir da für Sie eine tolle Lösung. Weil nämlich ein großer Teil der Befragten, 87%, hat gesagt, dass die Industrie, die Vernetzung aller Antriebe, das bietet mir einen wirklichen Vorteil, den ich nutzen kann. Denn dadurch habe ich dann ein Gefühl, wo es mit meiner Anlage steht. Also die Vernetzung aller Komponente ist definitiv ein Hebel, um mir das Leben leichter zu machen. Jetzt schauen wir uns das mal an, was aktuell im Bereich der Antriebstechnik möglich ist, wenn Sie jetzt hier ein Antriebssystem haben aus Motor, Umrichter und Getriebemotor. Welche Zustandsinformationen bekommen Sie denn ohne Digitalisierung schon bereits von Siemens zum Beispiel? Also das Getriebe und natürlich auch der Motor können über die sogenannten Condition Monitoring Systeme schon gewisse Informationen ausleiten, wie Geschwindigkeit oder die Wärmeentwicklung. Aber Sie sehen, dass ganz links oder ganz rechts von Ihrer Seite ist der Umrichter, der Taktgeber der Produktion und der liefert Ihnen aktuell keine Informationen. Außer Sie stehen natürlich direkt vor dem Gerät, das ist natürlich klar. So, und jetzt stellen wir uns mal vor, Ihr Antriebssystem könnte sprechen, das heißt, ist vernetzt. Welche Informationen bekommen wir dann heraus? Auf einmal meldet sich hier unser Getriebesystem und sagt, mein Öl, was ich im Getriebe habe, ist nicht mehr so gut. Wenn das weiter so geht, dann kann es hier zu einem Ausfall kommen oder einer Verlangsamung des Prozesses. Oder beim Motor ist es so, dass die Lager nicht mehr so gut sind. Die sind schon ein bisschen oder haben schon viele Betriebsstunden hinter sich. Das heißt hier, wenn es zum Lagerschaden kommt, auch Ausfall. Also bitte proaktiv etwas tun. Und auch der Umrichter liefert Ihnen jetzt Informationen. Das heißt hier zum Beispiel könnte er sagen, okay, meine Eingangsqualität, mein Eingangsstrom ist nicht das, was ich benötige, oder es gibt eben auch Störungen im Netz. All diese Sachen bekommen Sie jetzt protokolliert. Somit ist der Idealzustand, dass Sie als Anlagenbetreiber jetzt sagen, wenn ich diese Information habe, dann kann ich definitiv besser schlafen. Und auf das wollen wir heute eingehen. Siemens ist natürlich schon lange Zeit ein Wegbereiter der Digitalisierung. Sie sehen das hier auf unseren 3500 Quadratmetern. Viele, viele Produkte aus dem Bereich der Elektrifizierung. Das heißt hier Umrichtermotoren, das alles, was ich Ihnen gerade gezeigt habe, stellen wir schon seit vielen, vielen Jahren her. Motoren übrigens schon seit ungefähr 150 Jahren. Also wir haben da eine sehr, sehr lange Erfahrung. Natürlich auch im Bereich der Automatisierung. Steuerungssysteme haben hier den Markt mit geprägt. Und das, was wir natürlich jetzt als nächsten Hebel sehen, ist die Digitalisierung. Denn die Digitalisierung verknüpft Ihre reale Welt mit der virtuellen Welt. Und durch diese Vernetzung haben Sie entscheidende Vorteile, wie dass Sie eben die Zuverlässigkeit massiv erhöhen können, weil Sie immer ja einen Informationsstand haben Ihrer Anlage. Und Sie können natürlich auch die Performance massiv verbessern und den Service so einplanen, wie Sie das benötigen. Weil Ihr System meldet ja, wenn es Probleme gibt. Was können wir Ihnen heute schon anbieten an Portfolio? Das heißt, wir haben zwei Portfoliotypen. Das eine ist, was aktuell schon möglich ist. Das heißt, wir können erkennen, welcher Fehler liegt vor und was können Sie dagegen tun. Also Sie bekommen Fehlerprotokolle, Fehlermeldungen in mehreren Sekundentakten auf Ihr Rechner gespielt und sehen da und können da gegebenenfalls gegensteuern. Und natürlich auch zukunftsgerichtete Aussagen, die sogenannte vorausschauende Wartung ist hier ein wichtiges Thema. Und da können wir auch sagen, was könnte denn passieren? Ich kann Abschätzungen machen, zum Beispiel am Umrichter, was könnte da mit den Zellen sein oder mit dem Motorlager. Ich kann aufgrund von Algorithmen eben abschätzen, nach so und so vielen Betriebsstunden müssen Sie einfach Ihr Lager tauschen. Und das ist eben der große Punkt. Also was könnte passieren und was könnte ich dann tun, sodass Sie da keine Zeit verlieren. Und das ist der wichtige Punkt. Aber natürlich, was nützt ich habe jetzt viel über die Theorie gesprochen, wichtig ist auch die Praxis zu sehen. Die Praxis sieht folgendermaßen aus. Es könnte jetzt hier ein Kraftwerkskunde sein, der für ca. 2 bis 3 Millionen Leute eben Energie herstellt. Und was ist das Schlimmste für einen Kraftwerksbetreiber? Wenn natürlich der Strom ausfällt. Also das sogenannte Blackout. Das ist übrigens nichts Untypisches, das hat man vor 4 bis 5 Tagen in den USA auch gehabt. Also dieses Beispiel ist wirklich reell. So, also das Schlimmste, was eben für unseren Kraftwerksbetreiber A, sagen wir mal, passieren könnte, ein Ausfall des Systems. Und das schauen wir uns einfach mal an, wie das jetzt ohne die Digitalisierung der Antriebe aussieht. Das heißt, alles noch in Ordnung soweit, aber dann gab es eine Störung im System. Vielleicht haben Sie nicht rechtzeitig Ihr Getriebeöl getauscht oder Ihre Lager optimiert. Jetzt kommt es tatsächlich zum Stillstand. Das heißt, 2 Millionen Leute sitzen jetzt ohne Strom zu Hause. Und das ist natürlich unschön, vor allen Dingen, weil der Kraftwerksbetreiber jetzt sofort handeln muss. Er muss teuren Strom von einem anderen Unternehmen zukaufen. Das möchte er nicht. Und zum Zweiten verärgert er natürlich die Kunden. Und die Kunden haben natürlich auch ein Recht auf Strom. Und das ist natürlich ein Thema, was absolut vermieden werden soll. Natürlich bieten wir hier auch umfassenden Service an. Das heißt, der Servicetechniker bekommt erstmal die Protokolle zugesendet, meistens per E-Mail oder vielleicht auch Fax noch, wird dann übermittelt das Ganze, analysiert und dann tut der Servicetechniker entweder eine Fernwartung durchführen oder er fährt eben direkt zum Unternehmen. Und wenn das Unternehmen auch noch dezentral, ich sage mal, in den USA ist er auch recht groß, zum Beispiel, dann wäre das ein hoher Zeitverlust. Und Ihre Kunden sitzen immer noch im Dunkeln oder der Netzbetreiber hat eben hier vorgesorgt und extra teuren Strom zugekauft. Das ist natürlich ein Thema, was unser Netzbetreiber A extrem vermeiden möchte. Deswegen schauen wir uns jetzt mal an, wie könnte das Ganze jetzt im Optimalfall in unserer Digitalisierung aussehen. Also Antriebssysteme wie Motorenumrichter sind jetzt digitalisiert. Zum einen haben wir nämlich da unser brandneues Smart Motor Konzept. Sie sehen schon hier, sehen Sie diese kleine Box, die hier in unserem MindSphere, die über allem hier schwebt, in unser offenes IoT-System kommuniziert und dadurch haben Sie immer den Überblick, wie es um Ihre Motoren steht und können dann eben auch über die sogenannten Mind-Apps hier Optimierungen durchführen. Natürlich von Low Voltage auch zu High Voltage, also die ganz großen Motoren, die auch Kraftwerke antreiben. Das sind solche Motoren hier, Hochspannungsmotoren, die wir hier auch im Portfolio haben, können über die Condition Monitoring Boxen auch wesentliche Zustandsinformationen liefern. Und ich hatte schon gesagt, der brandneue GH180 hat hier auch Möglichkeiten der Datenübertragung, so dass die Eingangsspannung oder die Eingangsstromqualität jederzeit geprüft werden kann. Also jetzt gehen wir in das Beispiel hinein. Es würde tatsächlich auch wieder passieren, dass ein Blackout passiert, aber zum Beispiel unser Umrichter kann alle 30 Sekunden Daten, die werden eben automatisiert aus dem System heruntergeladen, werden über eine direkte Remote-Verbindung an unser Service Center gespielt. Sie sehen schon, da ist ein Riesenunterschied dazwischen, weil Siemens hat diese Daten fast real-time auf dem Tisch liegen. Und falls es tatsächlich dann ein Problem gibt, dann guckt sich das der Servicetechniker in seiner Leitwarte an, kann hier gewisse Informationen oder kann hier per Fernwartung eingreifen oder er muss eben doch vorbeikommen, was natürlich je nachdem daran liegt, welche Art von Problem liegt vor. Aber ich kann Ihnen sagen, Sie haben eine massive Zeitersparnis, die von mehreren Stunden her optimiert ist und das ist ja wirklich das Ziel des Netzbetreibers und Sie als Kunden wollen natürlich auch Strom haben. Deswegen ist das hier unser Beispiel, wie wir mit unseren digitalisierten Antrieben hier massiv zur Zuverlässigkeit beitragen können und dass Sie als Netzbetreiber auch besser schlafen können. Also ich fasse nochmal zusammen, mit unseren digitalisierten Antriebssystemen haben Sie als Kunde ein umfassendes Portfolio und das ist eben durchgängig von der Niederspannung bis hin zur Mittelspannung. Und ich werde jetzt nochmal mein Handy natürlich auch fragen, ob es alles verstanden hat, denn das ist ja auch mal wichtig in der vernetzten Welt. Einen Moment, Smartphone, hast du jetzt auch alles verstanden von den neuen Antrieben?
Ja, alles klar, aber bitte zeig mir noch die neuen Umrichter und Motoren.
Also irgendwie kann das Gedankenlesen, das stimmt. Das wollte ich Ihnen nämlich noch sagen. Und zwar finden Sie das Portfolio, was ich Ihnen gezeigt habe, inklusive der Drivetrain Analytics, hinter der MindSphere Launch, die da auf der Seite ist, Stand Nummer 59. Die Kollegen sind gerne für Sie da. Ich freue mich, dass Sie hier waren. Mein Name ist Thomas Kühnrich. Gerne wieder beim nächsten Vortrag. Viel Spaß noch auf der Hannover Messe heute. Dankeschön.
Genau. Sehen Sie, wunderbar. Vielen, vielen Dank. Wie geht's Ihnen? Noch guter Dinge? Haben Sie sich schon eine Liste gemacht, was Sie denn so alles heute einkaufen wollen bei uns, was Ihnen gefallen hat, welche Lösungen Sie gerne für sich bei Ihnen im Unternehmen umsetzen möchten? Stellen Sie sich wahrscheinlich auch die Frage, es kostet ja alles ein bisschen Geld. Aber auch hierfür haben wir Lösungen, nämlich aus unserem Siemens Financial Service Bereich habe ich einen Kollegen, den Peter Welp. Er ist eigentlich Ingenieur mal gewesen. Aber dann hat er sich gedacht, das, was er da entwickelt, das muss auch irgendwie verkauft werden und ist auf die Bankerseite gewechselt. Also ist es unser Elektrobanker. Und das, was wir zeigen hier auf dem Stand, daraus entstehen neue Geschäftsmodelle. Und die Finanzierung dieser Geschäftsmodelle, dieser neuen Technologien, darüber wird Peter Welp referieren. Viel Spaß!
Ja, meine sehr verehrten Damen und Herren, ja, liebe Christine, danke dir für die Anmoderation. Ja, was kann so ein Elektrobanker, was macht so ein Elektrobanker? Ich könnte Ihnen jetzt natürlich eine ganze Masse erzählen über Finanzprodukte, aber genau das möchte ich in den nächsten 10, 12 Minuten auf keinen Fall. Kommen Sie ruhig näher, kommen Sie rein, hier kann man noch viel besser sehen und gucken. Ich möchte Sie in den nächsten 10 Minuten mal neugierig machen für genau die Fragestellung, wo wird eigentlich morgen Geld verdient, was muss man dazu machen? Also es geht nicht um mein oder unser Geld, es geht um Ihr Geld. So, lassen Sie uns mal mit einem kleinen Ausblick starten oder mit einem kleinen Rückblick. Ja? Wie hat sich das eigentlich so entwickelt, die letzten industriellen Generationen? Da war die Mechanik, ja, klar, Logo haben wir alle, da ist die Elektrifizierung, ich weise gerne darauf hin, Elektrifizierung bekommt durch das Thema Green Energy und Energieeinsparungen eine ganz andere Bedeutung. Ja, dann war natürlich die Automatisierung, sagen Sie, ist alles in meinen Maschinen passiert, habe ich alles da. Und jetzt kommt etwas, da sagen viele, das ist Industrie 4.0. Ich gehe einen Schritt weiter, wir denken an unsere Handys, wir denken an die Art, wie wir mit Elektronik umgehen. Ich sage, da kommt die Gesellschaft 4.0. Und was wird diese Gesellschaft auszeichnen? Es wird diese Gesellschaft auszeichnen, das Thema, dass unvorstellbare Datenmengen plötzlich zur Verfügung stehen. Wenn ich jetzt ein bisschen gemein bin, könnte ich sagen, ja, die Sache mit den Daten, das ist doch die Sache des Kaufmanns. Und genau da möchte ich Ihr Augenmerk drauf legen, weil es ist wirklich die Sache des Kaufmanns. Natürlich ist es die Sache des Ingenieurs, wie steuere ich meine Maschine, wie bewegt sich meine Maschine und was tut sie. Aber es geht hier plötzlich um riesige Datenmengen, die unsere Maschinen, Ihre Maschinen produzieren. Und aus diesen Daten kann man Geschäftsmodelle machen. Machen wir mal einen kleinen Ausblick in, jetzt muss ich mal gucken, dass ich an der richtigen Stelle bin, mal einen kleinen Ausblick in das Thema, was können wir eigentlich von diversen Partnern lernen. Ich gucke mal auf das Thema Xerox. War ganz interessant, der ein oder andere kennt von Ihnen noch das gute alte Repro-Gerät, ja? Der neue Kopierer kam auf den Markt und war 8-mal so teuer. Das kann uns schnell morgen bei unseren Produkten auch passieren. Wie bringt man ein Produkt, was 8-mal so teuer ist, an den Markt? Ja, man braucht ein gutes Geschäftsmodell. Man frage also seinen Kunden, was sagt der Kunde? Ich zahle $200 Miete für das Gerät monatlich, ich mache 200 Kopien. Also wie sieht das Geschäftsmodell aus? Ganz einfach, man bietet dem Kunden den neuen Kopierer für $200 im Monat und 200 Kopien free an. So ist, wer vielleicht noch dran denkt, der Leasing-Klick-Vertrag entstanden. Nächste Story, Google. Google, ich möchte jetzt nicht mit Ihnen über Googlen reden. Googlen tun wir jeden Tag, sinnig und unsinnig. Ich möchte mit Ihnen über das erweiterte Geschäftsmodell, also ein erweitertes Eco-Modell reden. Denn Google hat das als erstes wirklich per Brillanz, per Perfektion umgesetzt und in den Markt gebracht. Wenn Sie heute googeln, kriegen Sie eine Information. Als nächstes bereitet Google einen Marktplatz für Sie auf. Das heißt, wenn Sie googeln, sehen Sie Werbung. Als nächstes werden Ihre Daten analysiert, Big Data Analytics. Und diese Daten werden anderen verkauft. Und alle drei Modelle, also das Googlen, die Werbung und der Verkauf der Daten, ergibt ein Geschäftsmodell. Und dass man von diesem Geschäftsmodell gut leben kann, ich denke mal, das wissen wir, wenn wir uns die Aktie angucken. Gucken wir uns das Thema Netflix an. Netflix, ein wunderbares Beispiel. Netflix ist die Geburtsstunde des Subscriber-Modells. Ganz einfach, Sie kannten früher die Videothek, Sie kannten Blockbuster, nichts dergleichen gibt es mehr. Heute kaufen Sie einen neuen Fernseher, Sie installieren den Fernseher, Sie geben Ihre Kreditkarte an, Sie schalten Netflix frei und laden sich Ihre Filme zu dem Zeitpunkt, wo Sie ihn gerne sehen möchten. Jetzt möchte ich Sie, und das ist das Schöne, wenn man Medientechnik zur Verfügung hat, jetzt möchte ich Sie einladen, mit mir mal so 3, 4 Monate uns zurückzubeamen. Und zwar im November hat in Mannheim im Rosengarten der VDE, Verband der Deutschen Elektroindustrie, Kongress stattgefunden. Dort hat man sich mit dem Thema Internet der Dinge sehr intensiv beschäftigt. Und das ist halt das Fantastische von solchen kleinen Videoclips. Ich möchte Sie einfach mal mit ein paar Statements von Ihnen sicherlich bekannten Persönlichkeiten konfrontieren.
Wie auch immer unsere digitale Welt in einigen Jahren aussehen wird. Schon heute steht fest, Die Zukunft liegt in der Vernetzung. Und das auf jeder Ebene. Zwischen Städteplanern und Mobilitäts-Apps. Ernährungswissenschaftlern und Kühlschränken. Modedesignern und smarter Kleidung. Aber auch zwischen Medizinern und Start-ups. Deutschen Schülern und dem Silicon Valley. Politikern und smarten Ingenieuren. Experten für IT-Sicherheit und den Visionären der Industrie 4.0. Der VDE bringt die Macher des Internet der Dinge zusammen. Unser Netzwerk bietet Akteuren und Entscheidern eine ideale Plattform, um sich auszutauschen und zu vernetzen. Fachübergreifend und direkt.
Meine sehr geehrten Damen und Herren, die digitale Revolution liegt nicht in der Zukunft, sie ist im vollen Gange. Roboter werden teamfähig, Hand in Hand mit Menschen in der Produktion, in der Service, in der Pflege.
Und das Internet wird Schritt für Schritt zum Betriebssystem unserer Industrie.
In Zukunft ist jedes Unternehmen ein digitales Unternehmen. Und ich glaube, meine Vorredner haben den Case sehr, sehr stark gemacht. Ich glaube, das ist tatsächlich so. Es wird jede Branche digital werden.
Die Digitalisierung unserer Branchen kann nur funktionieren, wenn die bestehenden Mitarbeiter mit ihrem ganz spezifischen Know-how aus dieser physischen Welt mit an Bord sind, um diesen Wandel mitzugestalten.
Wir sitzen damit ja zugleich auf einem riesigen Datenschatz.
Aber die Frage, werden wir es schaffen, in einer Datenökonomie am Ende diese Geschäfte dann auch mit den Daten zu machen? Die Daten auszuwerten und daraus neue Geschäftsmodelle entwickeln.
Entscheidend für den Erfolg des digitalen Wandels wird sein, dass Hersteller, Anwender, Anbieter gleichermaßen bereit sind, ihr Know-how einzubringen. Und das tun sie nur, wenn sie für ihr Know-how auch einen wirtschaftlichen Erfolg erreichen können.
Disruption und Tradition, das kann in den kommenden Jahrzehnten zu dem Erfolgsmodell für unser Land werden.
Denn alles, was digitalisiert werden kann, wird digitalisiert. Und ich gehe mal einen Schritt weiter, alles, was miteinander kommunizieren kann, also Connectivity, wird auch miteinander kommunizieren.
Wir glauben an das digitale Wirtschaftswunder Made in Germany. Wir glauben, dass Deutschland zu einem Impulsgeber werden kann. Aber ich würde sagen, es liegt an uns. Damit vielen Dank.
Ja, meine Damen und Herren, ist es nicht fantastisch, wie man mittels Medientechnik sich Co-Referenten einfach ins Publikum holen kann? Nein, Spaß beiseite. Mich hat dieser Film unheimlich motiviert, deshalb habe ich ihn mitgebracht, und um Sie auch zu motivieren, um aber auch zu zeigen, dass hier ganz andere Fragestellungen morgen da sein werden. Es ist die Fragestellung nicht, wie tausche ich meine Mitarbeiter gegen neue auf, sondern wie bringe ich die jungen Damen und Herren, die Digital Natives sind, in mein Unternehmen? Wie öffne ich mich vielleicht im Unternehmen, um wieder über neue Dinge mir Gedanken zu machen, um mal frisch und fröhlich zu überlegen, wo könnte ich eigentlich in 3, 5 oder 10 Jahren mein Geld mit verdienen? Und auf diesem Weg haben wir uns Gedanken gemacht, und das prägt auch das ganze Bild unseres Standes. Ja? Wir sind ein Unternehmen mit mehr als 160 Jahren Geschichte, und es ist wichtig, dass Ihre Investitionen geschützt sind. Das ist Ihr Kapital und das ist auch unser Kapital. Insofern finden Sie die diskrete Industrie von dieser, die Prozessindustrie von der anderen Seite in der Mitte vereint im Digital Enterprise. Und dass Sie nun, so wie das Dr. Jakob Feuerborn, CTO der Deutschen Telekom, gesagt hat, dass nun alles mit allem vernetzbar ist, dazu brauchen Sie etwas, dass Sie auf sichere und geschützte Art und Weise Ihr klassisches Device, Ihre Werkzeugmaschine, Ihre Rolltreppe, Ihren Trafo, Ihre Schutzgasanlage oder wie auch immer zum IoT machen können. Das ist unsere Mainz 4. Verstehen Sie Mainz 4 bitte als ein Betriebssystem, was nach unten sicher die Connectivity schafft und nach oben, und das ist ganz, ganz neu und sehr wichtig für Sie, eine offene Plattform darstellt, in der Sie nun beliebig in der Softwarewelt Applikationen für ihre entsprechenden Produkte schaffen können. Wie begleiten wir das Ganze? Wir sind nicht nur so, wie es im Volksmund manchmal gesagt hat, die Bank mit angeschlossenem Elektrokonzern. Nein, wir wollen sie auch an den Leistungen, an den Dienstleistungen der Siemens Financial Services, das ist die Gesellschaft in der Siemens AG, die sich um das Thema Finanzierung im Konzern und für Kunden und Partner kümmert. Wir wollen sie dort begleiten, weil wir glauben, und wenn die Christine vorhin vom Elektrobanker gesprochen hat, wir glauben, dass es einfach Sinn macht, dass wir die Expertise aus dem Finanzbereich, abgeleitet aus der betriebswirtschaftlichen Analyse, abgeleitet aus der Bilanz, dass wir die vergleichen mit dem, was an Technologie benötigt wird und was an Technologie eingebracht werden soll und dass wir daraus genau ihre individuelle digitale Agenda schnitzen, damit am Ende sie vorne genau das Richtige tun, damit hinten in ihrer Bilanz das betriebswirtschaftlich Richtige herauskommt. So reden können Sie mit uns über genau das, was Sie dabei bewegen wird. Über die Fragestellung, wie und auf welche Art und Weise innoviere ich eigentlich meine IT und meine Software. Ich habe hier mal als Best Practice Beispiel die Conmatix mitgenommen, ein Partner unserer PLM. Ja, es geht ja nicht nur darum, die Großindustrie, die großen Automobilkonzerne vom digitalen Zwilling zu überzeugen, sondern wenn ich in den Mittelstand gucke, genau um die Frage, wie geht es denn darum, dass auch die Supply Chain, also die Zulieferer, in die digitale Konstruktion mit eingebunden werden. Als nächstes mal in Richtung Durchgängigkeit von Konstruktion bis Service, als Best-Practice-Beispiel den Max Bögel, der es geschafft hat, auf diese Art und Weise erhebliche Potenziale zu ziehen, um die Fehler, die vielleicht gemacht werden können in der Konstruktion, eben durch die virtuelle Welt abzufangen. Das Thema neue Techniken, neue Geschäftsmodelle. Wir haben es heute Morgen in dem Vortrag unseres neuen Vorstandes Cedric Neike ganz gut gehört, zusammen mit dem Beispiel Gestamp, auch ein Beispiel, was finanziert worden ist. Ja, die Fragestellung, wie kann ich eigentlich etwas heute bezahlen, dessen Nutzen ich morgen genießen werde, und wie kann ich die Rückzahlung meines Geschäftes, Pay as you use, Pay as you earn, so aufbauen, dass entsprechend das Ganze kapitalneutral läuft. Immer wichtiger auch die Fragestellung, wie schütze ich Ihr Working Capital, wie schütze ich Ihr Kapital. Das heißt, Sie haben die Aufgabenstellung, ich muss meine Lieferanten, also zum Beispiel Siemens, bezahlen, aber meine eigenen Kunden zahlen erst später. Dort haben wir Finanzprodukte entwickelt mit Standardfinanzprodukten, die ganz individuell auf ihre Bedürfnisse zugeschnitten sind. Oder last but not least, Sie brauchen Unterstützung und Beratung in der Frage, wie kann ich meine Unternehmensfinanzierung gut und solide aufbauen, wie kann ich vielleicht im Ausland internationale Geschäfte entsprechend unterstützen oder wie kann ich vielleicht an entsprechende Kapitalbeteiligungen kommen. All diese Dinge, die wir für unseren eigenen Konzern auch nutzen, möchten wir Ihnen zur Verfügung stellen, zu Ihrem Nutzen. Und last but not least, ich glaube, so erklärt sich ganz gut, was die Christine vorhin mit dem Elektrobanker meinte. Diese Expertise, einerseits die Technik im Blick und andererseits eben das Kapital sauber im Blick zu halten, das ist etwas, womit wir Ihren Weg der digitalen Agenda, Ihren Weg in die digitale Zukunft gerne begleiten möchten. Wir sind hier vorne am Stand 159, da finden Sie unser Team. Die Leute haben alle riesig Spaß und das finde ich ganz toll, sich mit Ihnen und den Themen zu beschäftigen oder gerne auch im Nachhinein. Und ganz frisch zur Hannover Messe haben wir eine wunderbare Studie veröffentlicht, die sich mit dem Thema Produktivitätsbonus aus der Digitalisierung beschäftigt. Lade ich Sie ein, sich das entsprechend abzuholen. Ich sage herzlichen Dank und wünsche Ihnen noch einen wunderbaren Nachmittag. Christine.
Wir sagen herzlichen Dank. Applaus. Du machst das Richtige damit und berätst mich entsprechend.
Genauso, das tun wir.
Wo finden wir dich genau mit deinen
Hier
Kollegen?
den 159, ja.
Also direkt hier.
Der Kollege Jan-Yves Klames, der hebt mal die Hand. Dann sieht man genau dahinter ist die Säule, da findet man uns. Ne? Und Jan-Yves, du übernimmst das dann, oder der Christian, dass wir entsprechend auch mit Ihnen in den Dialog kommen.
Genau, und ansonsten bist du noch mit deinen Kollegen weiter an vielen anderen Stationen hier vertreten, um entsprechend auch beim Thema Energy for Industry oder wenn Sie was in Pharma lösen wollen, in Prozessindustrie oder beim Additive Manufacturing oder für Digital Enterprise im gesamten Beratung benötigen für Finanzlösungen.
Toll,
wir haben
dich habe ich
Kollegen hier
angesteckt,
vor Ort.
das ist super.
Ja, wunderbar. Also vielen Dank, lieber Peter.
Gerne.
Wir machen gleich weiter. Wir müssen nämlich im Programm bleiben. Nochmal einen Applaus an dich, denn wir sind nicht nur hier auf der Messe, wir sind auch im Fernsehen, weil wir streamen hier live. Das heißt, wenn Sie sagen, Mensch, im Programm, was hier überall ausliegt auf den einzelnen Sitzplätzen, da steht noch ein toller Vortrag drin, der ist aber heute Nachmittag, da muss ich schon zum Flieger oder zum Zug. Schauen Sie rein. Sie können sich entweder, wenn Sie zu Hause sind, im Nachgang wie in der Mediathek noch ansehen oder aber Sie sehen, dass ein Vortrag morgen oder am Freitag gelistet ist. Dann gehen Sie einfach live rein in unseren Stream und verfolgen die Präsentation und all das, was hier so bei uns auf dem Stand passiert, von zu Hause ganz gemütlich oder vom Büro aus. Also auch die Möglichkeit ist geboten. So, und jetzt habe ich ganz viel gesprochen und der nächste Vortrag interessiert viele, gehört zu einem unserer Highlights, die wir immer wieder auf der Messe präsentieren, nämlich es geht ums TIA-Portal. Ja, TIA, ich nenne da ein paar Schlagworte wie HMI, iOS, Security, Safety, Steuerung, Kommunikation. Das ist das Projektierungswerkzeug für alle unsere TIA-Komponenten. Und TIA ist das Engineering-System für die Industrie. Wer nutzt es schon? Wer hat das bei sich im Unternehmen? Sehen Sie, wusste ich es doch, dass da einige gibt. Und es ist der Zugang zur Digitalisierung mit offenen Schnittstellen. So, für was steht jetzt diese Abkürzung TIA? Ich würde mal sagen, total in Action. Und da rufe ich meine Kollegen Marcel Roske, den Marcel Roske und den Stefan Kleber auf die Bühne.
Ja, hallo und herzlich willkommen hier auf dem Siemens-Stand. Wir zeigen Ihnen heute, wie Sie die Offenheit des TIA-Portals für die Digitalisierung nutzen können. TIA, Totally Integrated Automation. Mein Name ist Marcel Roske und hier kommt mein Kollege Stefan Kleber. Stefan, was genau hast du da?
Du Marcel, solch einen Messetag stehe ich ohne Schokolade einfach nicht durch. Und außerdem passt Schokolade doch auch super zu unserem heutigen Präsentationsthema.
Du sagst es, Präsentation. Komm, die nächsten 10 Minuten, gib mir doch einfach die Schokolade.
Du hast ja recht. Herzlich willkommen am heutigen Mittwochnachmittag auf der Hannover Messe. Was ist denn Ihre Lieblingsschokolade? Ist es vielleicht Marzipan? Ist es Vollmilch oder doch eher zartbitter? So individuell wie Ihre Vorlieben für Schokolade müssen die Maschinen und Anlagen beschaffen sein, die diese Schokolade produzieren. Und jetzt überlegen Sie mal, was das für das Maschinenengineering bedeutet. Denn das muss schließlich ja auch alles irgendwie programmiert werden.
Ja, und genau darum geht es uns heute. Wir zeigen Ihnen, wie TIA-Portal Ihr Leben versüßt und gleichzeitig enorm viel Zeit beim Engineering einspart. Teilweise funktioniert das sogar völlig automatisch. Denn das TIA-Portal ist Ihr zentraler Zugang zur Digitalisierung.
Die Offenheit des TIA-Portals ermöglicht es uns, einen signifikanten Anteil des jeweiligen Automatisierungscodes automatisch zu erzeugen. Was das an Zeitersparnis und damit natürlich auch an Kosteneinsparungen mit sich bringt, muss ich niemandem erzählen. Für uns als Bühler ist dies ein riesiger Vorteil.
Die Firma Bühler, ein Anlagenbauer aus der Schweiz, der unter anderem Maschinen und Anlagen zur Schokoladenherstellung produziert. Sie haben es von Herrn Müller gehört, ein riesiger Vorteil. Dadurch schafft es die Firma Bühler, 90%, ich wiederhole 90% des Anlagensteuerungsprogramms automatisiert zu erstellen. Und wie? Natürlich mit dem TIA-Portal.
Ganz genau. Und damit vermeiden Sie auch Fehler. Ganz einfach und individuell können Sie Ihre Anlagen modifizieren, konfigurieren oder erweitern. Und wie funktioniert das? Mit der TIA-Portal Openness Schnittstelle.
Richtig, die Openness Schnittstelle ist das digitale Bindeglied zwischen der Elektroplanung auf der einen Seite und der Automatisierung auf der anderen. Bei der Firma Bühler funktioniert das so. Die Ingenieure planen jede einzelne ihrer Anlagen individuell. Also zum Beispiel unsere Maschine zur Herstellung von Schokolade. Wo sind die Hardwareplaner unter Ihnen? Ein Handzeichen habe ich schon gesehen. Sie kennen diese Oberfläche. E-Plan P8. Die Elektroplanung beinhaltet bereits Informationen zu den Geräten, wie Betriebsmittelkennzeichen und natürlich auch Bestellnummern. Des Weiteren beinhaltet die Elektroplanung Informationen zu den Netzwerken und natürlich auch Namen von Ein- und Ausgängen. Das Video läuft nicht.
Ja, und genau diese Planungsdaten, von denen Stefan gerade erzählt hat, genau diese Planungsdaten können dann ganz einfach durch den offenen Standard Automation Markup Language, kurz AML genannt, in das TIA-Portal übertragen werden. Und das Beste ist, das Ganze funktioniert in beide Richtungen. Das heißt, sollten Sie einmal Änderungen im Engineering vorgenommen haben, so können Sie diese ganz einfach an die Elektroplanung zurückspielen.
Die Offenheit zu Planungstools und das automatisierte Engineering verkürzen die Projektdurchlaufzeiten noch weiter. Somit können wir reibungslos mit Disziplinen wie der Anlagenplanung und der Elektroplanung zusammenarbeiten.
Jetzt haben wir auf Knopfdruck die Planungsdaten ins TIA-Portal übernommen. Das funktioniert auch für das Steuerungsprogramm.
Ja, und genau das macht auch die Firma Bühler. Die Firma Bühler lebt die Digitalisierung bereits heute. Die Softwarebausteine, die standardisierten Softwarebausteine, liegen in der TIA-Portal-Bibliothek ab und können je nach Maschinenkonfiguration in das Maschinenprogramm integriert werden und sozusagen auf Knopfdruck verwendet werden.
Und dabei analysiert der Codegenerator die Objekte in den Planungsdaten und erstellt anhand definierter Bibliotheksbausteine das Steuerungsprogramm. Da die Bibliotheksbausteine bereits getestet sind, ist der generierte Code komplett fehlerfrei. Das eliminiert Fehlerquellen und natürlich funktioniert das auch wesentlich schneller als die manuelle Anpassung. Für Sie ist das ein absoluter Mehrwert.
Der große Vorteil der Openness-Schnittstelle im TIA-Portal ist, dass wir unser eigenes Engineering-Tool nahtlos ins TIA-Portal integrieren können. Aus dem projektspezifischen Softwaremodell lässt sich mit unserer stets wachsenden Bibliothek im TIA-Portal ein maßgeblicher Anteil des Projektes automatisch generieren. So können wir in kürzester Zeit Kundenprojekte realisieren.
Lassen Sie sich das mal auf der Zunge zergehen. Die Firma Bühler realisiert Kundenprojekte in kürzester Zeit. Das schaffen Sie auch mit dem TIA-Portal und der TIA-Portal Openness Schnittstelle. Doch das Steuerungsprogramm ist ja nur die halbe Miete. Wie sieht es denn mit der Visualisierung aus? Denn hier hat jede Ihrer Maschinen und Anlagen oder vielleicht doch eher jeder Ihrer Endkunden ganz individuelle Anforderungen an die Automatisierung.
Ja, Stefan, auch dafür haben wir ein intelligentes Tool entwickelt, den Simatic Visualization Architect, kurz auch SIVAC genannt. Damit können Sie auf Basis des Steuerungsprogramms und vorhandenen TIA-Portal-Bibliotheken mit Visualisierungsobjekten innerhalb deren ganz einfach auf Knopfdruck ganze Bediengeräte automatisiert erstellen lassen. Auf Knopfdruck. Gut, statt also nun Variablen per Hand zu verknüpfen oder jetzt mal in Automatisierungsdeutsch gesprochen, die Bilder zu malen, drücke ich im TIA-Portal ganz einfach auf Erzeugen. Und da ich natürlich mit Bibliotheken arbeite, kann ich ganz einfach Standards definieren. Somit sieht meine Visualisierung immer gleich aus, hat das gleiche Design, das gleiche Look and Feel. und auch diese Designs und Stile werden automatisch übernommen.
Und Änderungen im Steuerungsprogramm werden automatisch in der Visualisierung nachgezogen. Dadurch eliminieren Sie Fehlerquellen und natürlich funktioniert die automatische Generierung von Bildern auch wesentlich besser und schneller als die manuelle Bildanpassung.
Ja, die Digitalisierung bringt also für Sie schon heute konkrete Vorteile. Engineering-Abläufe werden automatisiert, Fehlerquellen einfach eliminiert.
Doch trotz Standardisierung, Sie kennen das sicher, keine Anlage ist wie die andere. Es gibt immer auch ganz besondere Anforderungen, die teilweise sehr knifflig sein können. Wie können Sie diesen im TIA-Portal begegnen?
Ja, genau so ist es. Wir haben intelligente Tools entwickelt, die das Prüfen von Funktionen noch einfacher machen. Stichwort Simulation.
Der virtuelle Controller PLC Sim Advanced. Damit können Sie in der Engineering-Phase oder noch besser in der Planungsphase Ihre Automatisierung im Zusammenspiel virtueller Controller testen. Fehler können hierbei oder Ihre Funktionen können hierbei überprüft, optimiert und natürlich auch validiert werden. Und des Weiteren ist es möglich, hiermit auch Ihr Steuerungsprogramm zu validieren. Der echte Vorteil von PLC Sim Advanced ist, dass das Ganze auch ganz ohne Hardware funktioniert.
Mit dem virtuellen Controller steuern Sie also virtuelle Anlagenmodelle. Damit lassen sich bereits vor einer realen Inbetriebnahme Automatisierungsabläufe oder Fehlerszenarien testen und sogar optimieren. Denn je schneller man einen Fehler findet, desto besser ist es für den ganzen Projektverlauf. Sie kennen alle sicherlich die Rule of 10, die besagt, die Kosten eines Fehlers verzehnfachen sich durchschnittlich um jeden weiteren Projektschritt.
Fundierte Tests sind für die Qualitätssicherung unerlässlich. Die Virtualisierungsmöglichkeiten des PLC Sim Advanced Controllers bieten für uns die perfekte Umgebung für die Integrationstests. Dies ermöglicht uns eine enorme Kosteneinsparung bei der Hardware-Infrastruktur und dem Lifecycle der Testumgebung. So werden wir den Anforderungen der Digitalisierung nicht nur gerecht, sondern profitieren auch von ihr.
Übernahme der Planungsdaten, automatische Generierung des Steuerungsprogramms und der Visualisierung, Simulation, alles Möglichkeiten, die wir Ihnen bereits heute anbieten.
Ja, Stefan, doch Digitalisierung ist aber noch viel mehr. Die Vernetzung von Informationen über die gesamte Wertschöpfungskette. Wir setzen bei Siemens dabei auf definierte Standards für eine sichere Kommunikation und setzen dabei auf Profinet und OPC UA, sodass Sie von einem nahtlosen Zusammenspiel profitieren können. Das macht es Ihnen wiederum möglich, ganz einfach und schnellstmöglich von überall auf Ihre Produktions- und Diagnosedaten zugreifen zu können.
Ist Ihnen aufgefallen, wie wir in den vergangenen 11 Minuten Ihren gesamten Engineering-Prozess mit dem TIA-Portal digitalisiert haben?
Intelligente Werkzeuge und Tools automatisieren Engineering-Prozesse und erleichtern Ihnen die Routineaufgaben.
Dank Simulationstools können Sie Funktionen frühzeitig testen. Das spart Ihnen Zeit und Nerven.
Und außerdem können Sie dank offener Schnittstellen diese einfachen Werkzeuge, diese intelligenten Tools in Ihre bestehenden Prozesse oder auch in Ihre innovativen Lösungen integrieren.
Und jetzt sind wir fertig?
Ja.
Kann ich dann bitte meine Schokolade wieder haben?
Natürlich, Stefan.
Besten Dank.
Und auch für Sie kann das TIA-Portal der Zugang zur Digitalisierung werden. Sicherlich möchten Sie jetzt noch genauer wissen, wie genau Ihnen das TIA-Portal Ihr Leben versüßt und Ihre Engineering-Prozesse beschleunigt. Wir und unsere Kollegen von den TIA-Portal-Dialogstationen sind für Sie da und freuen uns auf interessante Gespräche. Vielen Dank.
Einen großen Applaus an euch beide. Vielen Dank.
Station. Einfach geradeaus, die Messe durch und an der dritten Säule links.
Linke Seite.
Wissen Sie wo?
Oder
Suchen
einfach
Sie
mit uns
einfach
mitkommen.
nach den beiden, genau. Vielen Dank.
Dankeschön.
Ja, jetzt geht's weiter hier. Ganz genau im Takt sind wir geblieben. Wir haben hier ein exaktes, präzises Programm, weil wir eben live streamen, also auch zu Hause mitverfolgt werden können von den Kollegen, die interessiert sind und nicht nach Hannover gekommen sind, weil sie da auch noch weiterarbeiten zu Hause in den Büros. Und ich freue mich sehr auch auf den nächsten Vortrag, der zum Thema Kompetenz in industriellen Netzwerken, die wir anbieten, entsprechend aufzeigt, was wir an Lösungen geben können. Mein Kollege Michael Metzler, der Experte in diesem Thema ist, sagt, ein Produkt zu verkaufen ist nur die halbe Miete. Wenn wir richtig gute Betreuung für unseren Kunden geben möchten und auch das Maximum an dem, was wir verkauft haben, beim Kunden rausholen möchten, dass er den maximalen Nutzen davon hat, dann begleiten wir das Ganze und beraten ihn weiter, wie er das nutzen kann, was er denn da eingekauft hat. Und wie er das macht, das bringt Michael Metzler Ihnen jetzt mit seiner Präsentation Ihnen nahe.
Ja, herzlich willkommen. Freut mich, dass es so viele von Ihnen geschafft haben zu dieser Präsentation. Mein Name ist Michael Metzler und arbeite im Bereich der industriellen Kommunikation. Ich darf Ihnen heute präsentieren, warum unsere Kompetenz in industriellen Netzwerken Ihnen und Ihrem Unternehmen helfen kann, erfolgreich zu sein. Da komme ich zur ersten Frage. Was treibt Ihr Unternehmen? Als erstes fällt Ihnen sicherlich ein, Kosten reduzieren. Klar, früher war der Wettbewerber weit entfernt. Heutzutage ist der Wettbewerber in direkter Nachbarschaft und zwingt Sie dazu, wettbewerbsfähig zu produzieren. Und da kommen wir zum nächsten Punkt. Die Produktivität müssen Sie steigern. Klar, jetzt denken Sie daran, wie Sie vor Jahren Ihr Wunschauto konfiguriert haben. Da gab es die eine oder andere Option, vielleicht 30 Stück. Heute gibt es Millionen von Möglichkeiten. Sie können Ihre ganz spezielle Lederausstattung innen wählen. Sie können die 20 Zoll Räder vielleicht oder Sportlenkrad auswählen. Millionen von Optionen, weil Sie es wünschen, weil Sie so Ihr Auto definieren wollen. Für Sie toll, für die Unternehmen natürlich eine starke Herausforderung, weil Sie müssen durch schlanke Produktionsprozesse hier die Kosten reduzieren. Und dabei natürlich nie die Qualität zu vergessen. Ein Stückchen Qualitätsminimierung an Ihren Produkten macht Sie berühmt. Denken Sie an Twitter, an Facebook und die ganzen anderen Social-Media-Kanäle. Berühmt in Sekundenschnelle, aber nicht positiv. Und das müssen wir vermeiden. Und für all diese drei Themen gibt es eine simple Lösung, nämlich Transparenz zu schaffen. Transparenz ermöglicht es Ihnen erst, flexibel und effektiv zu produzieren. Sie müssen zu jedem Zeitpunkt wissen, welche Bestellungen reingehen und welche Lieferungen rausgehen, um Ihre Bestände eben gering zu halten. Dieses Wissen brauchen Sie für Ihre Wertschöpfungsketten. Aber wie kriegen Sie diese Transparenz? Zum einen natürlich können Sie Ihre Anlagen verbinden. Sie können Daten aneinander austauschen. Das ist wichtig, damit Sie aufeinander reagieren können. Und der zweite Punkt ist, diese Daten in die cloudbasierte IoT-Betriebssystem Mainz 4 zu laden. Denn dort können Sie Daten analysieren aus unterschiedlichen Produktionsstätten und erst dadurch smarte Entscheidungen treffen. Und da gebe ich ein Beispiel. Zustände in der Produktion überwachen. Das ist einer der Buzzwords, die in aller Munde sind, wahrscheinlich auch hier auf der Messe öfters gehört. Und da lassen Sie uns mal ein paar Jahre zurückblicken, wie es da war. Die Produktionsanlage hatte einen Fehler, stand still. Sie haben den Servicetechniker angerufen. Ja, dann haben wir erst mal gewartet. 2 Tage lang vielleicht, weil das Visum nicht da war. Welche Gründe auch immer. Es hat 2 Tage gebraucht, um zu Ihnen auf die Anlage zu kommen. Und was ist dann passiert? Genau, es ist nichts passiert. 2 Tage lang stand die Produktion still. 2 Tage lang haben sie Kosten gehabt und nicht 1 Cent verdient. Das gilt es zu vermeiden. Und durch genau dieses Wissen, durch die Analyse der Daten, können Sie nun Wartungsintervalle so timen, damit eben der Servicetechniker an der Anlage ist, noch bevor ein Problem entsteht. Das ist ja überhaupt die Idee ist von Digitalisierung. Und MindSphere kann Ihnen dabei helfen. Aber wie kommen denn überhaupt die Daten in die MindSphere? Physisch. Wie passiert das denn? Dafür brauchen Sie starkes industrielles Netzwerk. Das ist überhaupt die Basis jeder Digitalisierungslösung. Und ich sage Ihnen, die Anforderung an solche industriellen Netzwerke wird sich erhöhen. Immer mehr werden diese Anforderungen kommen und Sie brauchen jetzt ein starkes Netzwerk, ein starkes industrielles Netzwerk, um genau für die Digitalisierung gerüstet zu sein. Und jetzt werden Sie sagen, okay, ein Netzwerk ist doch ein Netzwerk, richtig? Gibt es da einen Unterschied überhaupt? Zum Beispiel bei IT- und Automatisierungsnetzwerken, da gibt es einen Unterschied. IT-Netzwerke beispielsweise, die sind meistens gleich aufgebaut. Die haben den gleichen Blueprint, die haben ähnliche Muster, immer sehr gleich. Auf der anderen Seite die automatisierungsindustriellen Netzwerke. Da sage ich Ihnen, kein Netzwerk schaut genau gleich aus. Jedes Netzwerk ist genau für den Anwendungsfall gebaut worden, für das es bestimmt war. Und das ist das, was wir als Siemens sehr gut können. Dort haben wir die Kompetenz. Wir wissen, was es braucht, industrielle Kommunikationsnetzwerke zu bauen. Ich habe Ihnen Beispiele mitgebracht, um nochmal den Unterschied zwischen diesen IT-Netzwerken als auch den industriellen Netzwerken zu verdeutlichen. Ein Schlüssel davon ist hohe Verfügbarkeit. Denken Sie dran, Sie sitzen im Büro und surfen vielleicht im Internet. Sie wollen diese eine spezielle Seite vielleicht aufrufen. 5 Minuten lang tut sich nichts. Ist ziemlich nervig. Aber ich glaube, Ihr Chef, ihm ist es ziemlich egal. Ich glaube, er freut sich, dass er nicht mal arbeiten können. Jetzt stellen Sie sich mal vor, 5 Minuten lang steht die Produktion still. 5 Minuten lang, weil Sie Produkte eingesetzt haben, die eben nicht industriellen Umgebungen entsprechen. Und da sage ich Ihnen, da wird der Chef ziemlich sauer sein. Nehmen wir das Beispiel Sicherheit. Bei der IT ist Vertraulichkeit der Daten natürlich an erster Stelle. In der industriellen Welt ist die Verfügbarkeit der Produktion an erster Stelle. Sie müssen sicherstellen, dass Ihre Produktion läuft. Sie dürfen nicht zulassen, dass von außen jemand auf Ihr Netzwerk zugreift, Anlagen an und ausstellt, Motoren an und ausstellt und im schlimmsten Fall jemand verletzt wird. Das gilt es zu vermeiden. Und genau dafür haben wir zum Beispiel in unseren Komponenten integrierte Firewalls. Oder schauen wir auf das Thema mobile Anwendungen. Fahrerlose Transportsysteme, auch hier auf der Messe. Stellen Sie sich einen Gabelstapler vor, der fahrerlos bedient werden kann. Hocheffizient, hochflexibel, klar, arbeitet mit WLAN. Auch hier ein Beispiel. Haben Sie schon mal versucht, heute in der Messe ins WLAN-Netz zu kommen? Haben Sie es versucht? Und wie war es? Nicht so toll, ne? Glaube ich auch. Jetzt stellen Sie sich mal vor, Ihrer Produktion vertrauen Sie so einer WLAN-Struktur an. Würden Sie das tun? Ich glaube eher nicht. Wir bei Siemens wissen eben, auf was es ankommt, um genau auch unter widrigen Produktionsumgebungen ein WLAN-Netzwerk zu schaffen, was genau die Determinismus als auch die Echtzeitfähigkeit besetzt, um genau das zu tun. Wir haben Protokolle definiert, wie beispielsweise IPCF, und die in unsere Produkte integriert. Nehmen wir das Beispiel Flexibilität. Ich hatte Ihnen anfangs gesagt, IT-Netzwerke schauen alle gleich aus. Dort brauchen Sie keine Flexibilität. In der industriellen Welt, wie schaut es da aus? Da gibt es natürlich auch Prozessindustrien, die beispielsweise 20 Jahre lang nicht flexibel sein müssen, weil der Wartungsintervall entsprechend ist. Aber jetzt denken Sie nochmal an unser Autobeispiel. Es gibt Industrien, da müssen Sie eben flexibel sein. Da müssen Sie Produktion anpassen, und zwar ziemlich schnell. Und auch dafür hat Siemens flexible Produkte, um eben zusätzliche Ports in Ihren Switch zu integrieren. ohne dass Sie den Switch herunterfahren müssen, ohne dass Sie die Produktion stillsetzen müssen. Denken Sie, was das an Kosten sparen kann, was Sie hierdurch einsparen. Jetzt haben wir über Anforderungen an die Produkte gesprochen, an die ganz speziellen industriellen Anforderungen. Aber Sie brauchen natürlich mehr. Sie brauchen ein gut durchdachtes Netzwerk. Bei Siemens besteht dieses Netzwerk aus 3 Ebenen. Sie haben oben das Thema Unternehmensnetzwerke, dort ist Ihre Büroumgebung, dort ist der Access in die Cloud-Systeme, ins Internet etc. In der Verantwortung der IT. Darunter gibt es weitere 2 Ebenen im Produktionsbereich. Der besteht unten aus der Maschinenzelle und drüber aus dem industriellen Backbone. Dort findet Ihre Automatisierungsaufgabe statt. Dort ist die Verantwortung der Produktion. Das ist genau der Platz, wo Sie eben sicherstellen müssen, dass die Produktion nicht stillsteht. Dafür brauchen Sie Redundanzen. Sie müssen sicherstellen, dass Sie einfach zu warten sind. Aufgrund dessen brauchen Sie industrielle Monitoring-Systeme, die eben auch einen Instandhalter einfach handhaben kann. Und, ganz wichtig, Sie brauchen natürlich Systeme, die getestet sind. Denken Sie an SCADA, was mit einer Automatisierungskomponente, was mit der industriellen Kommunikation zusammenarbeiten muss. Als ein System. Auch das bieten wir als Siemens. Aber die Daten werden natürlich zunehmen. Wir haben anfangs darüber gesprochen, die Zustandsüberwachung, Kamerasysteme wollen Sie integrieren in Ihren Produktionsbereich. Die Komplexität nimmt einfach zu. Und dafür benötigen Sie einen zusätzlichen Aggregationslayer, eine Aggregationsebene, der genau die Schnittstelle bildet zwischen IT und dem Produktionsbereich, was die Regeln der IT als auch der Produktion erfüllt. Und dafür ist der industrielle Backbone, die ja bei uns genannt wird, die perfekte Schnittstelle. Was Sie hier sehen, ist natürlich ein Beispiel aus der Fabrikautomatisierung. Wir haben natürlich auch Kompetenzen und wir wissen, wie ideale Netzwerke aussehen in anderen Industrien, Prozessindustrien wie Öl und Gas, wie Food and Beverage etc. Auch dort haben wir die richtigen und die effizienten Konzepte dafür. Aber es ist nicht alles. Klar, Sie brauchen ein herausragendes Portfolio, was weltweit verfügbar ist und weltweit supported ist. Klar. Aber wir als Siemens denken, dass Sie einfach mehr brauchen. Wir bilden Ihre Mitarbeiter aus zu Experten in industriellen Netzwerken mit unseren Zertifizierungskursen. Wir planen, designen und konfigurieren Ihre Netzwerke mit unserem Professional Service. Und wenn Sie jemanden brauchen, der Ihr Netzwerk Tag für Tag betreibt, auch da haben wir ein Partnernetzwerk mit Experten, die genau das für Sie tun. Jetzt werden Sie sagen, aber warum soll ich denn an Siemens vertrauen, dass er diese Kompetenz hat? Berechtigte Frage. Ganz einfach, weil wir eben selbst Hersteller sind. Wir selbst müssen Kosten senken, produktiver arbeiten. Und wir wissen, wie wichtig dabei industrielle Netzwerke sind. Und das seit 25 Jahren. Und deshalb würde ich Sie gerne einladen, mit uns gemeinsam die Basis für Ihre Digitalisierungslösung zu bauen. Denn wir verstehen die Digitalisierung und binden sie an die Mindsphere an. Wir verstehen Ihre Industrien. Wir haben die Expertise in industrieller Kommunikation und in der Automatisierung. Und wir haben Kundenreferenzen, die für unseren Erfolg sprechen. Und dann würde ich Sie einladen zum Hof der industriellen Kommunikation, direkt unter der Mindsphere, und bedanke mich für Ihre Aufmerksamkeit.
Vielen Dank, lieber Michael. Vortrags war.
Der industrielle Kommunikation.
Genau. Und ich würde mal sagen, für all diejenigen, die sich das nochmal ansehen möchten, die können das über unseren Livestream tun, über die Download-Variante auch. Deine Präsentation ist auch im Internet verfügbar, so wie sehr, sehr viele andere diese Präsentationen. Vielen Dank nochmal an dich.
Gerne, herzlichen Dank.
So, meine Damen und Herren, jetzt geht es weiter mit unserem nächsten Vortrag zum Thema Simatic PCS 7. Wer weiß, was PCS, für was das hier steht? Wir bei Siemens haben ja unheimlich viele Abkürzungen. Da sind wir echt groß drin. Aber das ist, weil wir so viele tolle Sachen haben, die man gar nicht alle ausschreiben kann in der Länge. PCS, Process Control System. Und Sie dürfen gerne da bleiben. Der Vortrag wird nicht so schlimm. Sondern ganz im Gegenteil, er ist sehr, sehr interessant. Evolution von integriertem Engineering, so heißt der Vortrag. Und was ist es? Es heißt, es ist eine Ausweitung, die mit dieser Evolution verbunden ist, nämlich integriertes Engineering ist jetzt inklusive des Slide-Systems. Und das ist schon eine Revolution sozusagen. Und dazu begrüße ich meinen Kollegen Helmut von Au.
Ja, einen wunderschönen guten Tag, meine Damen und Herren. Ich freue mich, dass einige doch noch geblieben sind nach dem Vortrag meines Vorgängers. Anscheinend existiert doch noch ein Interesse. Freut mich. Ich bin Produktmanager von Simatic PC7, dem Prozessleitsystem im Hause Siemens, und möchte Ihnen heute gerne ein neues Produkt vorstellen, welches wir hier am Prozessautomatisierungshof am Stand 52 auch zeigen. Wir beschäftigen uns in der Prozessleittechnik natürlich mit entscheidenden Fragen hinsichtlich, wie sind die Kosten meines Projektes, wie kann ich dafür sorgen, dass meine Anlagen nachhaltig für eine kommende Migration taugen, etc. etc. Das will sagen, dass die Fragen, wie kann ich maximal effizient ingenieren und Kosten im Vorfeld zu sparen, wie kann ich meine Anlage permanent up-to-date halten hinsichtlich der Dokumentation, falls bevorstehende Migrationen kommen und Ähnliches. Das sind die Fragen, die uns heute begegnen, die uns unsere Kunden stellen. Und die Probleme, die sich dabei äußern, sind die, dass an Schnittstellen unterschiedlicher Tools und an Schnittstellen unterschiedlicher Gewerke immer Datenübergaben stattfinden müssen. Ich höre von den Leuten, die die Projekte machen, naja, ich kriege vom E-Planer irgendwo eine Excel-Liste, da stehen Signale drin. Und ich kriege vom Logikplaner irgendwo einen Leitsordner, da steht für jede Messstelle die Verriegelungslogik drin. Und die muss ich jetzt zusammenführen in einen PC7 CFC-Plan, der die Automatisierung für diese Funktion implementiert. Die muss ich hinsichtlich der Jetzt sind wir wieder da. Die muss ich hinsichtlich der Elektrotechnik zusammenbringen. Ich muss die Signalliste importieren in eine Hardware-Konfiguration meiner Automatisierung und. Ich habe Schnittstellen an allen Ecken und Enden für mein Leitsystem. Natürlich kann jedes Gewerk seine Durchlaufzeiten durch Optimierung der Usability verbessern. Ich habe aber immer noch die Übergangsschnittstellen von einem Gewerk zum nächsten Gewerk, dort, wo ich eben irgendwelche Excel- oder Microsoft-Daten übergeben muss. Was wir nun getan haben, ist Folgendes. Wir haben die Produktpalette, die ein integriertes Engineering mit Commerce bietet, die sehen Sie auf der linken Seite der Folie hinter mir. Die Produktpalette, die beginnt bei einem Frontend-Engineering, wo Sie Ihre Datenströme erstmal festlegen, die dann übergeht in ein Piping-Instrumentation, wo Sie Ihre Rohrklassen definieren, wo Sie Ihre Instrumentierung machen etc., die dann übergeht in ein Detail-Engineering, in dem Sie Ihre E-Planung machen, in dem Sie festlegen, welches Signal kommt auf welchen Schrank, in welche Baugruppe, auf welchen Kanal, wo Sie dann die Logikpläne definieren, die aus prozesstechnischer Sicht meinetwegen die Verriegelungen und Ihre Control Strategies festlegen. Diese Produktpalette aus Commerce, die heute schon vollständig integriert in einem Objektmodell da ist, die war bis dato nicht verbindbar mit der Leittechnik direkt. Wir verbinden die nun mit der Leittechnik direkt durch den Simatic PC7 Plant Automation Accelerator, der in der Lage ist, die Daten, die aus den Planungsphasen anfallen und die für die Automatisierung relevant sind, ins Automatisierungssystem zu transferieren. Der Vorteil ergibt sich dadurch implizit. Sie haben nämlich dann für diese Daten keine Engineering-Aufwände in der Automatisierung. Wir haben festgestellt, dass wir durch diese Methodik, wenn Sie eine vollständige, saubere Planung machen in der E-Technik und in der Funktionsplanung, 75% der Automatisierungsdaten tatsächlich für ein Conti-Projekt automatisiert implementieren können. Und ich denke, da ergibt sich die Einsparung automatisch, da brauchen wir nicht weiter drüber reden. Wie Sie aber auf der Folie auch sehen, ist dieser Pfeiler, dieser kleine in der Mitte, in beide Richtungen ausgerichtet. Dieser Pfeil, der in beide Richtungen ausgerichtet ist, soll damit andeuten, wenn Sie denn nun, und das wird immer so sein in jedem Projekt der Prozessautomatisierung, während der Lebenszeit Ihres Projektes Änderungen in der Automatisierung vornehmen. Sie müssen ein Parallelventil anschließen, Sie müssen irgendwelche Hardwarebaugruppen tauschen, Sie müssen Messstellenparameter verändern, Sie müssen Verriegelungen hinzufügen, etc. Wenn Sie diese Änderungen machen, direkt in der Automatisierung, dann war es in der Vergangenheit so, dass immer vergessen wurde, naja, eigentlich muss ich das jetzt in der Dokumentation nachziehen, aber dafür habe ich keine Zeit, Hauptsache meine Anlage läuft. Das hat dazu geführt, dass wenn Sie Ihre Anlage nach 10, 15 oder 20 Jahren migrieren wollen, dass Sie zwar eine laufende Anlage haben, aber Sie wissen nicht mehr warum. Sie wissen nicht mehr, weshalb die Anlage läuft, weil die Dokumentation ist nicht up-to-date und Sie können keinem Migranten, der Firma, die die Migration implementieren soll, die Dokumentation in die Hand geben und sagen, transportier mal bitte in die neue Welt. Das geht nicht, wenn Sie keine Dokumentation der Anlage haben. Was tun Sie? Sie machen ein komplettes Re-Engineering der Anlage. Kostet unheimlich viel Geld. Da engagieren Sie eine Firma, die geht durch ihre Anlage, die muss das Know-how haben von dem Altsystem und muss dann über dieses Know-how von dem Altsystem ihr Altsystem re-engineeren und auf Dokumente bringen, sodass sie Up-to-Date-Dokumentation haben. Das tun wir nicht mehr. Änderungen, die Sie im Leitsystem vornehmen, können wir 1:1 in die Dokumente der Planungstools überführen. Was wir dabei im Detail überführen, zeigt diese Folie. Das sind nämlich zum einen die Bibliotheken, die Sie in Ihren Projekten verwenden. Simatic PC7 erlaubt Ihnen, kundenspezifische Bibliotheken für Ihre Applikationen zu machen. Der Grund ist einfach der, dass unterschiedliche Kunden unterschiedliche Ansichten auf Automatisierungsfunktionen haben und diese unterschiedlichen Ansichten, die können Sie implementieren in der Veränderbarkeit, in der Anpassungsfähigkeit der Bibliotheken im PC7. Diese Bibliotheken wollen die Kunden weiterverwenden, deswegen haben wir die Möglichkeit, die Bibliotheken, die ein PC7-Projekt hat, mit den Dokumenten auszutauschen, die Typicals. Und natürlich zu diesen Typicals, CNT, Control Module Types, können Sie auch austauschen die dazugehörigen Instanzen. Diese Instanzen repräsentieren Ihre Funktionspläne aus der Planung. Das heißt, Ihre Control Strategy, die liegt in den Planungsdokumenten fest und die können Sie austauschen mit dem Leitsystem über dieses Vehikel der Kontrollmodule. Dann, wie ich vorhin schon andeutete, die Interlock Logik, also alles das, was Sie brauchen an einem Equipment zur Verriegelung oder zur Freigabe, das, was Sie üblicherweise auf einem Logikplan im Vorfeld in und oder-Gattern, in Timern, in Verzögerungsgliedern hinzufügen. Das tauschen wir instanzspezifisch aus und das ist auch der Anwendungsfall, der am häufigsten trägt bei der Rückdokumentation. Denn in der Tat ist es halt eben so, dass in der Inbetriebssetzung dort am meisten Änderungen gemacht werden. Und dort ist es dann wesentlich, dass nach der Inbetriebssetzung Ihre Dokumentation, die Sie auch Ihrem Endkunden eventuell übergeben, der die Anlage dann betreiben muss, tatsächlich as is vorhanden ist. Dann haben wir noch die technologische Hierarchie. Das ist die funktionale Abbildung Ihrer Anlage in einer Hierarchie. Die können Sie auch mit dem Planungswerkzeug austauschen, bidirektional, sowie auch die Hardware-Konfiguration. Zur Hardware-Konfiguration möchte ich sagen, dort ist es in der Tat so, dass wir 100% der kompletten Hardware-Konfiguration des Simatic PC7 aus der Planung ableiten können. Durch Knopfdruck können Sie tatsächlich dafür sorgen, wenn eine saubere E-Planung vollständig gemacht worden war, dass Sie im Leitsystem keinerlei Änderungen mehr oder Erweiterungen der Hardware-Konfiguration machen müssen. Das ist technisch möglich. Und die Symboltabelle bedient folgenden Use Case, dass die Softwarekomponenten, die Sie in Ihrer Anlage haben, für die Control-Strategie auch tatsächlich mit den Hardwarekomponenten verbunden werden müssen. Das heißt, Sie müssen dafür sorgen, dass eine analoge Größe, die über ein 4 bis 20 mA Signal in eine Analog-Eingabebaugruppe eingespeist wird, auf einem Logikplan und letztendlich im HMI für den Anlagenfahrer auch sichtbar wird. Das macht die Symboltabelle, die füllen wir da auch. Ein wenig zur Topologie des Produktes, welches wir hier haben. Das Produkt bietet alle Möglichkeiten des Remote-Zugriffes. Wir selbst verwenden das Produkt, wenn wir PC7-Projekte implementieren, um dort maximal effizient zu sein. Und was wir beispielsweise tun, das zeigt die Folie auch recht schön, wir haben einen zentralen Server in Karlsruhe stehen, in der Mitte. Und von diesem zentralen Server aus arbeiten unsere Engineering Companies, die weltweit verteilt sind, Australien, China, in Kroatien, in Südamerika, in Nordamerika. Diese Engineering-Einheiten, die wir weltweit haben, arbeiten alle auf demselben Server, der in Karlsruhe administriert wird. Der Vorteil, den Sie dadurch haben, ist der, dass Sie sicherstellen können, dass alle Projekte, die weltweit gemacht werden, mit demselben Template gebaut werden und vom selben Template abstammen. Das müssen Sie nicht mehr überprüfen, weil die arbeiten alle auf dem gleichen Datenstand, auf dem gleichen Server, der in Karlsruhe steht. Hier noch ein paar Einzelfunktionen. Wir können so eine Anlagenkonfiguration erstellen in den Planungswerkzeugen und wir können über Engineering Wizards mit unserem Werkzeug auch automatisiert Hardware-Komponenten maximal effizient aufbauen. Diese Folie soll nochmal auf die Rückwärtstransfer der Daten aus dem Leitsystem in die Dokumente des Planungswerkzeuges hinweisen. Sie können damit also sicherstellen, dass Sie zu jedem Zeitpunkt eine aktuelle Anlagendokumentation haben. Ich will mich da nicht wiederholen, deswegen gehe ich gleich darüber weg. Was haben Sie also davon? Im Anlagen-Bulk-Engineering haben Sie davon natürlich eine Zeit und damit eine Geldersparnis, ganz klar. Dadurch, dass Sie eine Schnittstelle eliminieren zwischen Leitsystem und Planungswerkzeug, haben Sie auch die Sicherheit, dass dort keine Fehler passieren beim Übertrag von A nach B. Das heißt, Sie haben eine höhere Verfügbarkeit und damit sparen Sie natürlich Geld. It's all about money. At the end of the day, it's all about money. So, was ich Ihnen nicht verschweigen will, damit das Bild des integrierten Engineering sich abrundet, ist, last but not least, dass wir mit dem Werkzeug auch eine Schnittstelle geschaffen haben hin zu einer Prozesssimulation und einer Automatisierungssimulation mit unserem Produkt SIMIT. SIMIT ist das Produkt, welches die Simulationsfeatures liefert, und der PA Accelerator, das Produkt, über das ich rede, hat eine Schnittstelle hin zum SIMIT, die es erlaubt, die Prozessdaten, falls Sie ein Piping and Instrumentation Diagram haben, in SIMIT zu überführen, damit Sie eine Prozesssimulation dort automatisiert machen können, aber auch die Automatisierungsdaten der Templates, die Sie verwenden für Ihre Automatisierung, können automatisch in SIMIT überführt werden. Damit sparen Sie natürlich unheimlich viel Aufwand im Engineering der Simulation, wenn die automatisch aus dem Prozessmodell abgeleitet werden kann. Gut. Jetzt bin ich schon am Ende meines Vortrags. Was wir also damit gemacht haben, ist, dass wir diese Brüche, die über die Gewerke heute existieren und an diesen Brüchen, wo heute die meisten Datenverluste und Inkonsistenzen auftreten, diese Brüche haben wir nicht nur minimiert, wir haben sie eliminiert und damit haben sie durchgängige Datenhaltung vorwärts, rückwärts inklusive der Leittechnik für PC7 geschaffen. Ich bin damit mit meinem Vortrag am Ende und freue mich, dass Sie mir so aufmerksam zugehört haben.
Und ich würde sagen, herzlichen Dank für Ihren Vortrag, lieber Herr von Au. Freut mich
Gerne.
sehr. Wenn Sie noch Fragen haben, hier bitte, wenden Sie sich... Bei der Prozessautomatisierung, wie Sie hören. Also vielen Dank nochmal, Herr
Gerne.
von Au. Dankeschön. So, jetzt geht's weiter. Tempo haben wir hier drin und wir sprechen den ganzen Tag über Digitalisierung. Das Motto unseres Messestands: Digitalisierung. Driving the Digital Enterprise, discover the value of the Digital Enterprise. Ja, da kann man definitiv was rausholen mit den Lösungen, die wir hier anbieten. Und sehr verehrte Damen und Herren, wenn Sie Deutsch sprechen und uns verstehen, kommen Sie näher, setzen Sie sich her. Füße tun weh nach so einem ganzen Vormittag auf dem Messegelände. Vielleicht waren Sie gestern schon unterwegs hier. Nehmen Sie Platz. Hier ist es bequem. Wir haben einen interessanten Vortrag aus dem Thema Prozessindustrie. Der Vortrag wird aufschlüsseln mehr Produktivität und Effizienz in der Prozessindustrie mit der Digitalisierung. Dazu begrüße ich ganz herzlich meine Kollegin, Marketing Manager für Water and Wastewater, Maria Mühlbayer, auf die Bühne, bitte. Wie geht's dir, Maria?
Ja, ganz gut. Vielen Dank. Ich hoffe, allen anderen geht es auch ganz gut. Ich begrüße Sie ganz herzlich.
Jetzt ist dein Vortrag, der hat schon wieder Digitalisierung hier im Titel. Ja. Ich sage, wir sprechen so viel über Digitalisierung. Worum geht es bei dir?
Ja, was glaubst du denn? Es ist klar, Digitalisierung findet in unserem täglichen Leben schon statt. Ist ja klar. Du benutzt ja dein Smartphone, kannst deine E-Mails checken von unterwegs. Wichtig. Oder vielleicht kannst du deine Heizung regulieren über dein Smart-App. Oder vielleicht hast du personifizierte Running Shoes, also Rennschuhe.
Na, momentan bin ich nur mit denen hier unterwegs, da ist nichts personalisiert.
Ja, für die Messe braucht man vielleicht diese. Ne? Okay, also das sind all die normalen Dinge, die dich umranden. Worüber ich sprechen werde, du hast jetzt gerade mal ein Stück Wasser genommen, ja? Hast du dir eigentlich dabei gedacht, was für Prozesse dahinter stehen?
Ja, Prozess ist, Wasserhahn auf, einschenken, Wasserhahn zu, trinken.
Und wie kommt dieses sauberes Wasser, Trinkwasser, in diesen Wasserhahn?
Jetzt lass mich mal raten hier. Es geht um Digitalisierung in der Prozessindustrie und ich würde sagen, das ist das Keyword hierbei. Ha?
Genau, so ist es. Mit Digitalisierung erkläre ich Ihnen, wie Sie diese Prozesse, die dahinter an diesem Beispiel jetzt hier zum Beispiel, ja, effizient gestalten können.
Ich sehe schon,
ja.
Hier geht es wieder um so ein Fachthema. Ich bin jetzt von der Bühne.
Genau. So, das ist das Thema. Wie kann ich die Produktivität, Effizienz in der Prozessindustrie steigern? So, dann fangen wir mal an. Aber zuallererst, lass uns doch mal überlegen, vor welchen Herausforderungen stehen Sie, unsere Kunden von der Prozessindustrie? Was sind die Pain Points, was sind die Herausforderungen? Dann wollen wir diese uns mal erstmal anschauen. Die Herausforderungen können unterschiedlich sein. Ja? Wir reden über lange Zeit von der Idee zu Produkt, zu Produktion. Also es kann unter Umständen auch ziemlich lange dauern, bis ein neues Produkt auf den Markt kommt. Es kann Jahre sogar gehen. So, das ist ein Problem, das antreten kann. Weiteres Problem natürlich die Risiken, die während Inbetriebnahme passieren können. Fehler, unkalkulierbare Fälle, die vortreten und Sie können sich vorstellen, was für Kostenfaktor das bedeuten kann. So, und dann natürlich das Problem Stillstand, Verluste durch Stillstand oder vielleicht fehlt die Transparenz Ihrer Anlage. Das sind die wirklich großen Herausforderungen von Kunden in der Prozessindustrie. Und darauf möchten wir mit unserer Lösung angehen. Und wir haben eine Lösung, die heißt From Integrated Engineering to Integrated Operations. Was heißt das? Das heißt, im Grunde genommen, wir kreieren für Sie einen digitalen Zwilling. Mit Hilfe von bestimmten Tools mit Hilfe von bestimmten Softwareprogrammen, sodass Sie Ihren digitalen Zwilling, Ihre zukünftige Anlage kreieren. Und mit diesem digitalen Zwilling können Sie all diese Probleme lösen. Das heißt, Sie können die kürzere Zeiten zur Markteinführung damit erreichen, Sie erreichen die höhere Effizienz und Sie können Ihren Betrieb optimieren. Dann wollen wir das uns mal genauer anschauen. Wir wollen das Ganze durch den ganzen Lebenszyklus hinweg anschauen. Beginnen wir mit der Engineering-Phase. Fangen wir an. Dafür haben wir Comos. Das ist ein Softwareprogramm, das ist ein Tool an sich, das ist eine gemeinsame Datenplattform, an der viele verschiedene Disziplinen verknüpft sind. Wir arbeiten an verschiedenen Gewerken, beispielsweise Verfahrenstechnik, Automatisierung, Anlagenplanung. Die arbeiten alle auf einer Datenplattform, und zwar gleichzeitig. Was heißt das? In der Vergangenheit war das so. Ich habe mit einem ersten Schritt angefangen und erst der nächste Schritt dann möglich, wenn ich mit dem ersten fertig war. Wir müssen nicht mehr warten. Wir können gleichzeitig parallel an all diesen Disziplinen, an diesen Gewerken arbeiten. Wenn wir das genauer mal anschauen, das sind alle verschiedene Gewerke, die für uns, für unsere Anlage wichtig sind. Und da wir parallel daran arbeiten, profitieren wir natürlich dadurch, dass wir unsere Ingenieurzeit verkürzen, drastisch verkürzen. Und wir erhöhen die Qualität des Engineerings, weil die nicht mal die gleichen Datenwerte nochmal eingeben müssen. Die sind alle einmal vorhanden und die sind immer da. Dann als nächster Schritt, gut, wir haben die Engineering-Phase jetzt mal abgeschlossen. Nächster Schritt, Automatisierung. Wir übertragen nun alle Daten von Comos nahtlos ins Leitsystem Simatic PC7. Einfach per Mausklick. Schnell gemacht. Und damit generieren wir einen digitalen Zwilling. Als nächstes, was Sie noch machen können, Sie können Ihre zukünftige Anlage jetzt schon begehen, solange Ihre reale Anlage noch in Betrieb, noch in Bau ist. Mit Comos Walk Inside, mit Hilfe von einem Tool, von einem Programm, können Sie Ihre Anlage in 3D visualisieren. Wofür brauchen wir das? Wir können zum Beispiel schon mal schauen, wo sind die kritischen Komponenten in unserer Anlage. Wir können unser Personal schulen, damit die sich schon vertraut machen mit der Anlage. Sie können sich ja sicher vorstellen, die Anlage, die Produktionsstätte kann ja recht groß sein. Und damit unser Personal und unser Techniker beispielsweise, die können sich schon trainieren und wissen, wo die bestimmte Komponente finden können. Gehen wir weiter. Das ist noch nicht alles. Nun, was machen wir mit unseren digitalen Zwillingen? Wir können jetzt einige Simulationen durchführen, und zwar von Inbetriebnahme. Sie können sich sicher vorstellen, wenn Sie in der Phase der Inbetriebnahme sind, können Fehler auftreten. Die können sehr teuer sein, sie können sehr teuer werden für Sie. Diese wollen wir vermeiden, indem wir das schon mal vorher testen. Und die Fälle, die wir entdecken, können wir jetzt schon beseitigen, sodass in der realen Welt, in der realen Inbetriebnahme diese gar nicht mehr vorkommen. So, damit natürlich haben wir viele Vorteile. Wir sind schneller dran. Nun fragen Sie mich, okay, tolle Idee, digitale Zwilling, aber ich habe eigentlich schon eine Anlage. Ich bin Brownfield, wie wir das so nennen. Ich habe eine existierende Anlage, die es schon seit vielen Jahren gibt. Ja? Nun möchte ich aber auch von der Digitalisierung profitieren. Und da haben wir auch eine Lösung. Mit unserem Kooperationspartner Bentley Systems können wir Aufnahmen von Ihrer Anlage machen, beispielsweise mit einer Drohne. Sie können dafür auch ein mobiles Gerät nehmen oder Kamera, das ist im Grunde egal. Wir machen Ihre Aufnahme und mit Hilfe von einem speziellen Programm von Bentley Systems können wir diese in 3D übertragen. Und da haben Sie auch einen digitalen Zwilling und können davon profitieren. Nun reden wir über Betrieb, sehr wichtiges Thema. So, was denken Sie, was ist die größte Herausforderung in dieser Phase ist? Sie möchten sicher keinen Stillstand haben, oder? Dann schauen wir mal. Wie können wir damit umgehen? Instandhaltung ist dabei sehr wichtig, damit Sie keinen Stillstand Ihrer Anlage haben. Vorausschauendes, zustandsorientiertes Instandhaltung. Wir nehmen jetzt zum Beispiel hier diese Pumpe. Sagen wir mal, sollte irgendwas nicht in Ordnung sein. So, die Daten von dieser Pumpe, ihr Zustand, Überverbrauch zum Beispiel, werden ständig an PC7-Leitsystem gesendet. PC7 überwacht den aktuellen Zustand Ihrer Anlage, Ihrer Komponenten, in diesem Fall jetzt die Pumpe. Sollte das System merken, dass da irgendwelche Abweichungen gibt, meldet Sie uns das. Wir bekommen eine Meldung, bitte überprüfe die Pumpe Nummer 123. So, und wir arbeiten mit einem Tool, was Commerce MRO heißt. Das ist ein Maintenance, also Instandhaltungstool, das uns dabei hilft, das Ganze gut zu organisieren, zu dokumentieren. Okay, wir haben jetzt die Meldung erhalten über Instandhaltung. Der Techniker ist da. Was passiert jetzt? So, dann schauen wir uns das mal genau an. Der Techniker braucht natürlich alle technischen Daten von der Pumpe. Und er nimmt sagen wir mal, ein Tablet. Ja? Er kann sich alle technischen Daten dort anschauen über Commerce. Er hat einen Zugang zu Commerce. Alle technischen Daten sind da sowieso hinterlegt. Betriebsanleitung oder vielleicht auch Liste mit Ersatzteilen. Er kann das alles in der kürzesten Zeit entnehmen. So, jetzt hat er alle Daten und braucht dann nur zu wissen, wo diese Pumpe genau ist. Mit Commerce Walk Inside kann er schnell diese betroffene Pumpe finden. Innerhalb von wenigen Minuten ist er da, kann seine Arbeit erledigen und diese sofort dokumentieren auf sein mobiles, zum Beispiel, das ist ein Portable, ne, ein mobiles Gerät. Somit bleibt die Dokumentation auch übertragen, die ist sofort übertragen. Sie können sich ja sicher vorstellen, dass wenn Sie irgendwelche Veränderungen an der Pumpe in diesem Fall zum Beispiel machen und diese nicht dokumentieren oder die manuell übertragen müssen, das ist enormer Aufwand. Hier vermeiden Sie diesen Aufwand enorm. Sie sparen Zeit, Ihre Ressourcen und Ihr digitaler Zwilling. Ganze Software, die zusammenarbeitet, bleibt immer aktuell. Das heißt, und das sehen wir auf den nächsten Folien, der digitale Zwilling ist always up to date, wie wir das auf Englisch sagen, immer auf dem aktuellsten Stand. Alle Änderungen werden da sofort sichtbar in Echtzeit. Dann haben wir das Thema angesprochen, Transparenz, fehlende Transparenz. Dafür haben wir auch eine Lösung. Und zwar, wir nennen dieses Tool XHQ. Das ist ein Management-Tool an sich, wo Sie verschiedene Berichte anschauen können, generieren können. Speziell für Sie. Sie haben verschiedene Kriterien, die Sie abrufen können. Beispielsweise für das Management sehr wichtig Business Data. Alle Daten Ihrer Anlagen, wie effektiv Sie arbeiten, wie hoch die Produktivität ist. Sie müssen richtige strategische Entscheidungen treffen. Und dieses Tool hilft Ihnen dabei, diese Entscheidung schnell zu treffen. Und Sie müssen nicht warten, bis Ihr Monatsbericht da ist. Sie können in Echtzeit alle Daten abrufen. Dieses Tool ermöglicht Ihnen wirklich die Transparenz Ihrer Anlage, Ihrer Produktivität und natürlich können Sie auch die Effizienz, Produktivität steigern, weil Sie eben die richtigen Entscheidungen treffen können. So, das war unsere Lösung, was wir für Sie, für die Kunden in der Prozessindustrie anbieten, die wir nennen From Integrated Engineering to Integrated Operations. Der digitale Zwilling, damit Sie Ihre Anlage digital kreieren und schon verschiedene Situationen abspielen können, testen können, simulieren können, im Vorfeld denken und alle möglichen Fälle im Vorfeld vermeiden können. Was macht Digitalisierung möglich? Wir müssen auch über weitere Elemente, wichtigen Elemente sprechen. Wir reden über Industrial Communication, industrielle Kommunikation. Sie brauchen ja Daten von Ihren Anlagen. Sie müssen sicherstellen, dass Sie diese Daten bekommen, dass die Kommunikation stattfindet. Dann haben Sie diese Daten und natürlich sehr wichtig ist, dass Sie diese Daten heutzutage auch sichern. IT-Security, gegen Cyber-Attacks, Hackers und so weiter. Das ist ein sehr wichtiger Punkt. Und der weitere Element, was jetzt wichtig ist, industrielle Dienstleistung, ich würde das so formulieren, from Big Data to Smart Data. Wir möchten die Daten nicht nur sammeln und die einfach da haben, wir möchten natürlich intelligent diese Daten nutzen. Wir sprechen über Smart Data, über Dienstleistungen, die wir Ihnen anbieten können, für Sie zum Beispiel als Manager, damit Sie Ihre Entscheidungen schnell, sicher treffen können. Darum geht es. All diese Komponenten machen Digitalisierung heute möglich. Das ist nicht morgen, das ist heute. Und wenn Sie mehr darüber erfahren möchten, auch diesen digitalen Zwilling von der Prozessindustrie live erleben möchten, kommen Sie zu uns auf den Stand, zu Digital Enterprise of the Process Industries im Herzen des Standes. Dort können meine Kollegen Sie gerne beraten und Ihnen einige sogar Use Cases zeigen. Herzlich willkommen zu unserem Stand und ich bedanke mich für Ihre Aufmerksamkeit und wünsche Ihnen noch viel Spaß. Wiedersehen.
Vielen Dank an dich, liebe Maria. Das ja, meine sehr verehrten Damen und Herren, wir haben hier einige Schlagwörter gehört zum Thema COMOS, digitaler Zwilling, Simatic PCS 7, aber auch XHQ war da genannt. Und dazu kommen wir jetzt in unserem nächsten Vortrag. Operations Intelligence ist das große Thema dabei. Wir haben da einen kleinen Film vorbereitet dazu.
Your plants generate a mountain of data. Imagine sorting through it all to find information you need to make real-time decisions. XHQ Operations Intelligence software delivers complex data in a clear format to your fingertips. XHQ pulls and organizes relevant data from all of your operations and business systems. With a dashboard tailored to your needs, you can quickly access data anywhere at any time on your desktop, laptop, tablet, or smartphone. Its smart design and simple navigation allow users at all levels of your team to make faster, empowered decisions. XHQ is a proven solution for improving collaboration across your teams, no matter where they are. The focused insight you gain by using XHQ can help you discover process improvements that last. With its simple setup, budget-friendly options, and forward-looking design, XHQ is your partner for rapid decision-making for the digital journey ahead.
Swapping over into English language now. You're having an idea what this helmet is about? Why am I wearing it? Guys, come closer. We do have a lot of seats here, and don't worry, it's not dangerous here. This is not why I'm wearing this helmet. So take a seat, give your feet a break. Come on, it's been exhausting all day, I'm pretty sure. And I can see a lot of things through this lens, you have no idea. But if you want to get a glimpse into what I'm seeing and what this helmet can do, and how you can benefit from it, I think you should come here, take a seat, and listen to my colleague, the expert, Robert Waltersdorfer, came all the way from the US with a nice Arnold Schwarzenegger accent, by the way. And he will tell you more about rapid decision making for the digital journey ahead. And my rapid decision making is, I'm off the stage and Robert is on. Please.
Thanks, Christina. Hi, everybody. Rapid decision making for the digital journey ahead. Digitalization is changing our lives in many aspects. Like, for example, how we watch TV at home. Of course, we want to sit in the living room and watch TV on a big screen. But we also want to see a movie or watch TV when we are on the road, for example, driving a car that the kids can watch TV. Or we want to watch TV if we have a break, or when we brush the teeth. We want to see it on a mobile device. We want to see it on a tablet. Basically, anytime, anywhere. Another example is when we listen to music. We want to listen to music at home when we have the big stereo device at home, or we want to listen to music when we go for a run, or when we also drive with the car. We want to listen to music basically also anytime and anywhere. And that's also true for process industries. We also want to have the information available anytime, anywhere to make better decisions. And this you can see, for example, when we are in the office. We want to see, of course, the information when we sit in front of our desktop. We also want to see the information when we, for example, work from home, when we are on the road, when we are traveling, but also when we are just switching between meetings or want to know something when we are in a meeting. Another example is when we are also out in the plant. We also want to see the information that we need anytime, anywhere. When we do inspection rounds, when we do maintenance work, when we do operator rounds, we want to see what tasks need to be done, what information is needed to do the job. We want to see that right in time, and we want to have the information available anytime and anywhere to make better decisions. So let me just show you now a little bit how XHQ works, how the XHQ portfolio looks like. So basically, XHQ is then gathering data from many disparate systems, like, for example, business systems, which are mostly relational data, and on the other hand side, also from plant systems, which also have a lot of real-time information available. And business systems can be like SAP, HR systems, planning systems, document repositories, maintenance systems, or engineering systems. So many different systems where we have connectors, where we can import data. And on the other side, on the plant systems, we import information from process historians. We have a lot of native connectors and also support a lot of open standards there. We also import data from other operations and maintenance systems, as well as like LIMS, laboratory information systems, or other systems. And then we aggregate all that information together in the XHQ intelligence model. And from there, we contextualize then the information for the specific role, for the specific user, that the user has the right information available to then make better decisions and then respond and grow the business. And what you can see also on top, we can visualize on many different devices. Like, for example, if you're in the control room and you have the big board, you want to see everything what's going on in the plant. Or if you're sitting in front of the desktop, you want to have the information available that is specifically needed to make the decisions for the specific role. And of course, on notebook devices, phones, tablets, and also on wearable devices. And now let me show something more about how an XHQ screen looks like. You can see here a desktop environment. This is a very rich visualization because the experts want to see all the information, what's going on in the plant. This is built with our engineering environment called the XHQ Workbench, where you can design all the different widgets, all the different tiles, like charts, trends, table controls, like a GIS map. That's what can be seen also on this desktop device. Then, of course, also on notebook devices. Here you can see one example for the batch industry, and where you can compare in a batch analyzer 2 batches. Basically, you can get the golden batch and then compare another batch. What is the difference and where you can improve your business. You can also see there are some trender elements. Okay, and now with our new version, XHQ 5.0, you can also design screens for tablets and for mobile devices right in our workbench. And that's very good, because you can have now also the information available on your mobile devices to make better decisions anytime and anywhere. You can see already here some examples. One example is about reliability. You can see some charts right there. You can see some controls, some table controls. On the other side, you can also see some charts and some table controls. And now let me also show you more in the software. I can show you right on this mobile device how XHQ look like and give you a better idea what else you can do. You can see here the typical landing page of XHQ. This is the first page if you open our XHQ demo. And then from there, if I click, I can open additionally the navigation. In the navigation, you can select which view you want to look at. Alternatively, you can click also directly at the icon right here if you want to open a specific view. I open now a view for refining operations intelligence. Here you can see the KPIs on the left-hand side. For example, the lagging indicators or refinery utilization or in energy efficiency. On the other side, you can see like commercial information, like the price per gallon and also how that evolved over the last week, and also with the whole trend of this KPI. In another example, you can see that also XHQ can import the process flow diagrams and then show here how the plant is performing with the actual against the plan. And you can see all what's going on in your plant in real time. Here is another example on safety performance. You can see, for example, the HSE incidents year to date, where you can see it in a, now it's right there, in a chart, and also how the environmental parameters were moving over time in the trend below. Another one is, for example, where you can see some KPIs on utilization, also some nice charts here, and also a trender. And one shows the key performance indicators. You can see here traffic lights and also year-to-date percentage of target. As well, on the right-hand side, you have like the ability to create annotations. So if you want to record something regarding this KPI, or send an email or give somebody a call if something is not right. Okay, these were the examples directly on the mobile phone to give you an idea of what is possible. In addition to that, and what you saw also before when Christine was walking on stage, we have also the ability to show data on augmented reality devices, like this helmet from our partner Decri. It's a smart helmet enabling augmented reality. And if you see through the lens, you can see what you can see right there in black. Black means where you can see through, and the white information is then projected right where you look at. So for example, if you look at a pump, you can then see your performance indicators, you can see the trend, you can see this information right in time to make better decisions when you are working in the plant. And the big advantage is you have your hands free, you can work right away, get your information from XHQ over the integrated data gateway, and have the information right away available to make better decisions anytime and anywhere. Okay, then I can also show something more, what we have on our Station 50. We also have there XHQ running on a MindSphere machine. We have installed this together with Comos. And you can see XHQ screens running on MindSphere and then navigating if you need more information on a certain asset to Comos, to the Comos software, where you get more information on engineering or on operations. For example, you can open there and P&ID drawing in Comos, do some annotations, do some redlining, and then go back to XHQ to also see further information. You can see that and visit us at Station 50. There we can show also the helmet, the augmented reality device, also how we display on MindSphere. You can also see XHQ in the vending machine from MindSphere. So XHQ is there visible in the MindSphere apps. So if you go there, please take a look at it. Also look for XHQ. One slide to sum up. XHQ can provide many benefits. The main three ones are to access all information. And with that information contextualized for your specific role, you then have the ability to make faster, more empowered decisions. And this pays back. This is what our customers give us as feedback. These are the business results at a glance. For example, 8% reduction in the operating costs, or 9% increase in facility utilization, 2.5% increase in operational availability, and 11% increase in production. We are driving and innovating operations in next level of operations intelligence with XHQ. Rapid decision-making for the digital journey ahead, this is our claim. You can also find us on Station 50, like mentioned. Please visit us there. We can show you there how XHQ looks like. We can show you our demo. We can show you how XHQ is running on mobile devices, as well as how XHQ is running on the helmet with the augmented reality device, and also how XHQ works on MindSphere. Thanks a lot.
The machines. No, it's just the... All right, Robert. Thank you. Great hand of applause.
Thanks a lot.
Thank you very much, dear Robert.
Thanks, everybody.
Yeah, and we're talking about other things. I've been wearing a helmet, not because I had a headache and took a pill this morning, no. But pharma is the topic which we are talking about now, digitalization initiatives in the pharma industry. And for this, I welcome my colleague Andrew Whitetalk to come up on stage and tell you more about what's happening. But guys, you gotta come closer here. Give your feet a break. Take a seat, cozy seats. Interesting topic, an expert from the pharma field. It's really, really, really interesting. It's something you might need for sure in matters of knowledge, in matters of talking to other experts, maybe somewhere chatting at the airport or in another meeting. Do use your chance to listen to the expert coming up on stage now, Andrew Whitetalk.
Brilliant, thank you. Hi, good afternoon, everybody. Come on in, come and sit down. It's been a long day, right? Come and sit down and hear about the great pharmaceutical industry. Thank you, I needed some water, not for some pills, but my voice is going from speaking to so many people today. Great to see you. I'm here to talk to you about digitalization initiatives in the pharmaceutical industry. So what we're really doing and what I'm wanting to show you is some of the examples of how we work with global pharmaceutical customers on innovative topics in our industry. My name's Andrew Whitetalk. I work out of our competence center for the pharmaceutical industry in Karlsruhe in the south of Germany. You hear from the accent, maybe I'm British, but I'm working on specializing in digital and software solutions for our pharmaceutical customers. So when we talk about the pharmaceutical plant of the future, come and hear about the pharmaceutical plant of the future. There's lots of space here. Huh? What's so special? So we have 3 key steps in the pharmaceutical world, which we will focus on today and which we show on our Pharma Cube a little bit further down in the booth. Development is finding drugs, finding new molecules, doing the clinical trials, doing the testing, first step. Then, after we find a drug, we need to make a big, usually in bulk, the drug substance in primary processing, so making large bulk recipes. Finally, we then need to put it into some packaging, so into tablets or syringes or into small bottles. Across these three steps, there are always challenges around efficiency, around the time to market, the flexibility, and of course, what's most important for many of our pharma customers is quality and the regulations. One of the key things about flexibility in the pharmaceutical industry is being able to really bring down the size of batches. So we see a little bit in our stand as well about the idea of even being able to produce a batch size of 1, meaning that I have an individualized therapy for myself as a patient, and this is happening today with cancer, where customers or patients who have had cancer have had it removed through chemotherapy, and then we have an individualized therapy against the cancer, which is based on the genetic makeup of that person. But how does Siemens solve these problems? By providing automation and manufacturing software to really make that process really much more efficient and much more cost effective. Come on in. Come on. It's great over here. Come and sit down. Okay. I'm not going to say it all the time, don't worry. So how is technology driving the change in the pharmaceutical industry? And briefly, and again, we can show this in more detail and with great pleasure on our stand around the continuous manufacturing and paperless manufacturing. I'll explain that in a bit more detail in a few moments. Around additive manufacturing, 3D printing. You see an example of 3D implants just on the left here. But the first pills are being produced by 3D. There are 3D printers of 3D prints of pills because they will dissolve in the mouth a lot more easily. So this is the reason to do that. We're thinking, or the industry is thinking about a time where we go back to the old days where the pharmacist has his own printer in the pharmacy. You go in and he prints out your pills for you. This is something that the companies are thinking about today. Okay, Siemens is not providing those pills today, but this is the type of use case and where we want to be able to provide the tools to make these processes more efficient. I think it's, quite interesting. Big data and analytics, simulation and robotics, I think these are challenges for many industries. I don't need to go into detail here. Perhaps the most interesting one for me or for us here is robotics, because we always have a lot of manual and very small batches, a lot of manual type processes, and trying to interact our manual operations with robotics is often quite a key challenge, and using that as a trend. And this comes back to my fourth point here, so I don't have to repeat it, the labor modernization, the way that people are going to be working in the future in these pharmaceutical plants of the future. Companies are obviously trying to make themselves trying to use technology to give themselves a distinctiveness. They're transforming their plants. In-plant transformation is really key, yeah? They really want to see how they can transform their plants into this digital enterprise, into this type of futuristic plant. And again, things that we're seeing today. And finally, network sophistication. This is really around the collaborative aspects of the very complex network, not necessarily specific to pharma, but where we see contract manufacturers, suppliers, many different entities and companies that are coming together, and we really need to track and trace the information through the whole process. So, I don't think I did say, but I know that Christine said we want to talk about some real concepts and some real examples. And this is what I want to talk about today and show you some examples of that. Our innovative concepts in the pharmaceutical industry. The first one, paperless manufacturing. I don't know how many of you are familiar with the manufacturing process in a pharmaceutical plant, but the key thing is that everything has to be recorded. This documentation, we can see 400 or 500 pages of information that is needed to produce a batch of medicine. Lots and lots of paper. So we need to take that, or our customers are wanting to take the paper out of that process and have the advantages of recording the information electronically to be able to guide the way that things are working, to make sure that things are recorded correctly, and also to make sure, of course, that I have the information, and if there's a problem, I can review that quickly. Imagine if you have to review 500 pages of a batch record, that's a lot of time. And we have companies, or I've seen companies, where they have 10 or 15 people whose job is to go through this batch documentation, quality assurance it's called. If they are only told to go to page 10, page 20, and page 50, because that's where the potential problems were, then they're only reviewing the exceptions. So review by exception, it's a key challenge, or a key benefit, I should say, for in the pharmaceutical industry. Once we also think about paperless, we want to think about how we integrate with our automation, yeah? And so it's bringing together these manual steps as well as with automation. And there we see the examples of integrating our recipe, integrating our workflow, which we show on the booth. We show all of this on the booth. And then the integration of the HMI, the human-machine interface, that the operator has a single screen which he's looking at. So rather than having one information thing here, one information thing here, some paper here that I'm filling in, you're giving them the tools to be able to make that whole operator process much more efficient and make sure you record the information itself. There's plenty of seats, guys, if you want to come in, no problem. Okay, so paperless manufacturing, the benefits, of course, saving time, improving guidance and control, and reducing that review and approval time. What about continuous manufacturing? Continuous manufacturing is a trend in the industry which has been going on for a few years now. And Siemens is part of this transformation of the industry through the analytical part. Let me explain. This is an example of an FDA-approved process in Puerto Rico, the first company that has actually converted from a batch process to a continuous process. Their challenge is moving these raw materials, feeding in constantly different raw materials with different, with different consistencies, and making sure that they come out in a very, very clear, consistent blend. You can't have, so it's very important. Imagine, and this is the way it helps me to think about it, if you're mixing salt with sugar with flour. These are 3 white powders, maybe. Well, it should be. But they're of a very different consistency. And to make sure that you get a very consistent blend is very important. So you add in wet and to make sure that it all comes together. But the point being, we need to analyze the properties. And these NIR, or near-infrared analyzers, are pulling out the information of what's going on, pulling out the information, and then we're doing the analysis through this process analytical technology. It's a really interesting part and a real thing that's transforming our industry today. We can show you more on the booth, of course. Huh? Siemens is also working with providers of single-use equipment. This is another interesting example because we're thinking of flexibility in a plant. What does single-use mean? Well, a great example to illustrate that for people who aren't so familiar is in the kitchen, in your bin, in the kitchen. You don't change every time you fill the bin, you don't change the bin. You don't clean the bin every time. You have a plastic bag and you take the rubbish out and you throw it away. One of the challenges of biopharmaceutical production is the contamination. If something gets contaminated, then I lose the batch. A batch could be millions and millions and millions of euros, pounds, dollars, whatever. I think we know what I mean. The point being that contamination is very, fighting against the contamination is very important, and so having single use enables me to be able to really reduce those cleaning times and the changeover. There are other benefits as well, but what Siemens is doing is providing the software to be able to manage that process, make sure that the bag is changed. I know that when I ask my son to change the bin bag in our kitchen, he never does it right. And you need to, well, I don't have a manufacturing process in place to make sure he does it properly, but it's this type of an idea. Okay? 2 other final examples, and this is a really interesting and exciting one for us, is a real proof of digitalization in the pharmaceutical industry. Intelligent Immersive Manufacturing, IIM. This is a project that we've worked on with a company in the UK, GlaxoSmithKline, or GSK, may be familiar with, and we've got a great article in one of our customer magazines called Customer Magazines about the art of the possible. Remember that. Is everyone familiar with the term art of the possible? Not really, huh? It's just these English guys come up with these terms and nobody understands them, right? So what they're really doing there is thinking about what might be possible in the plant of the future. How might an operator be working? Here is an example where we use the XHQ software. Those of you who were here a minute ago will have seen the dashboarding. An operator being able to come on a huge, huge tap board and being able to see and drill down in the batch exactly what's happening. Yeah? So this is really, really cool, right? So we're really able to slow down that. But there are other things that are happening in this art of the possible. They wear they wear wristbands. So when they move up to their computer, what's the hardest thing about most annoying thing? The login and the password. Here, if I walk up, it knows that I am who I am because it's got my cardio heartbeat thing you know what I mean? It knows who I am, and it just opens up the screen at the right place, at the right time of who I am, so of what I need to do. Then I think the other key key and other interesting thing is they do voice activation. So they're standing there, and rather than having to do everything and start everything, they stand there and they're doing something. Start the batch, stop the batch, voice activation, gesture control. It's a bit like Minority Report. It's coming to the pharmaceutical industry, but it's to help us, not to do any harm. Don't worry. Okay, and this is about continuous tableting, about really guiding operators and optimizing those operations and thinking about how an operator will work in this new digital world, not taking the people out completely, but helping them to do their job more efficiently, because I need them when I'm making medicines. My final example is the one I mentioned earlier, the personal immunotherapy. For those of you that are just arriving, very briefly, we make our customer is making a personalized vaccine against cancer. The big challenge there is really been to bring the data together and really guide the process. And I'm not guiding necessary operators, I'm guiding very experienced people who have a lot of data to handle. They've got a very complex process which they're trying to understand and make sure it goes right. Scheduling, so we use our automated scheduling tools, we use our manufacturing systems. Bringing together these different technologies, that's really key as well. Bringing them together to provide a solution. And again, from a solutions perspective, that's our job in the Pharmaceutical Solutions Competence Center, is use these different pieces of software to provide digital type solutions for our customers. It doesn't just have to be digital. Here are some more examples, and some of the ones I repeat as well. Integrated engineering, paperless and continuous, as I mentioned earlier. I think I'll go through them all, a PLM, through the manufacturing of the future we just mentioned, the secondary part, and there's a great example of how we're making tablets just down there. So you can make now these tablets, here we are in my box, so I don't need to get it out, you know what tablets look like, but I can't even open the box, it doesn't, because I'm going from the wrong end, not very intuitive, huh? So, you know, making these in a Siemens, you know, showing how we can fill a vaccine plant or how we can actually make these types of medicine and actually support the secondary processes of the packaging lines and bringing them together. So on that note, my presentation is finished. I'm now going to go and eat my bottle of pills and try and get my voice back. And I hope that that's been informative and interesting for you. Thank you very much for your time, and thank you very much for your generous smiles and nodding and so on and so forth. So on that note, thank you.
Thank you very much, Andrew. Very good. Thanks a lot.
Okay,
well,
cheers,
ladies
guys.
and gentlemen, yeah, we're talking about pills and the filling process of pills, but we also do have dairy industry and the food and beverage topic here at our booth. Who has been at the dairy station to collect one of those bottles? Anyone been there yet? Hey, it's a great showcase. You can choose your favorite flavor, chocolate, raspberry, or even mango. So I go there more often a day in order to choose whatever, but you also will not just get the bottle of whatever you have chosen, you will get information there as well, how complicated it usually was to fill up bottles in the individual flavor of whoever wanted whatever, and to label a bottle as well. Well, what am I talking? I mean, we have experts here. I have Jomi, Rajaji, and now I'm stuck. See, this is what's happening when you're talking too much. Holy moly. You can tell your name by yourself, huh? Let's do it like this. Okay, please welcome up on stage my two colleagues. Wednesday.
Hello and welcome to the Siemens world of food and beverage. I think everybody is nowadays talking about digitalization, and I think you see this everywhere in our booth as well. But we thought that what we have to offer to you in terms of digitalization. So let's talk about digitalization in our food and beverage world, right?
Yes, definitely we should. So let's take the dairy industry as an example. That's why I've brought a drink. It's a nice chocolate milk show. So I hope you like that.
I really thank Andreas to give this milk to me, but I don't like chocolate. I would like something much more healthier and fruity stuff. That's my type.
Come on, I thought you're the sweet guy. Now you want to have something fruity, sporty, with protein?
Yeah.
But no problem. I'm prepared. So I have another drink with me. That's a nice orange mango protein drink. So this is really healthy stuff. So I think that's better.
Looks like he really takes care of me, so he's really prepared to give me another one, another flavor. And this is what I was really asking for. But today we are in the Hannover, so we need to do something much more challenging, I would say. Let's do something more challenging in terms of the label of this. I don't like this label, so let's do it in terms of our corporate color. I want a blue label.
A blue label?
Yeah.
Are you sure?
Yeah, let's do a blue label.
Okay, then let's do a blue label. So we can change the label according to your personal taste. My name is Andreas Zintel.
And my name is Rajesh Shom.
And we are from Siemens Food and Beverage. Today we are going to show you how digitalization applies to the dairy industry.
Yeah, exactly, thanks. But whenever we talk about digitalization, what comes to our mind is like we are talking about big cars or like big airplanes or like very high-tech products, right?
I would like to have that blue car, honestly.
My dear friend Andreas, we need to focus today. We are talking about digitalization and digitalization in dairy. But I will make your life really easier and explain you what I mean by that, yeah?
Okay.
I had this experience, and probably you as well, all of you had this experience. Whenever you go to a supermarket, yeah, you see so many different flavors. You see so many different attractive packagings, new ingredients, stuff into that. Somebody likes to drink a high-fat milk, a low-fat milk, an organic milk. So there's so much of wide range of products the people as consumers wants you. But like as a manufacturer, how do you meet this requirement from the customers, from your end users? And I think here, digitalization plays a really vital and a very important role.
Yeah, absolutely. Digitalization plays a vital role in the dairy industry. And we can make it happen with Siemens technology. So we have the right portfolio to cover the entire life cycle of such a milk-based drink, starting with the product design, the planning of the production, the engineering, execution, and of course, finally, the services.
Absolutely. So thank you for setting the tone of it. So as Andreas mentioned, let's go through these 5 facets of the value chain of the complete plant. Let's start with the product design. Like even in this product design, this is where digitalization and the virtual twin comes into play. For such a simple drink which he offered me, for this simple drink itself, you need the process formulation behind. And you also need the right ingredients that needs to be in the right composition. I mean, like the right content of the sugar, right content of the milk, right content of the protein to have the right product before you really go to the market, right?
Right. And Siemens supports you in this formulation process, taking into account different regulations in different markets. For example, in the US, in Europe, Asian countries, or any other country, it doesn't matter. And the graded nutrition table is also the link to the next challenge in our concept, which is the creation of cost-efficient but also attractive packaging. And this includes a stress test simulation of the packaging and, of course, the design of the label. And so this is exactly the point where we can change the label to your personal taste, so we can make it blue.
Wow, that would be exciting to see how you do that for me. Okay, then let's go to the next phase, which is the production planning. Because you need to really know how much you need to produce on a wider scale before you really go to the real world. And in the production planning also, you use the virtual world, that's the digital twin, to create your entire production line before you really start committing and producing to your customers. And here also, digitalization plays a really vital, important role.
Yeah. This means we can really validate the entire plant in the virtual world before ever building it. So we can identify bottlenecks and we can avoid overcapacities. And most important, we can run the entire plant under extreme conditions without any risk to the employees or the equipment.
But then I have a question right now, because what we both explained is that we have designed the product, we have started planning for the production. That means in the virtual world, we have already like up and running the plant, right?
Right.
Yeah, but then can we still use the digital twin even after the plant has been commissioned and up and running?
Yes, for sure. Every time you introduce a new product, we can speed up your time to market by allowing you to do feasibility checks with the digital twin. And the digital twin is also the basis for the next step in our concept, which is the production engineering.
Production engineering, this is the most scary part which I have gone through in my life, because in production engineering, what we try to do is that it's the most time-taking, I would say, phase in the project, because here is where you really make your plant, I mean, you design your plant in terms of your mechanical design, your electrical design, and your automation design, yeah? But with the Siemens technology, you can really reduce this time of doing these three facets, which I mentioned as electrical, mechanical, and automation design, because we have a really integrated portfolio which helps you to integrate these three facets and make it much more easier and faster for you.
Yeah, so we offer all the tools that are needed for an efficient production engineering. And as my colleague mentioned, they are all integrated, so they are capable to exchange data. And this allows a very nice working model for cross-functional departments, because they can exchange their data and reuse them. And that makes production engineering very efficient. This is how digitalization gets a human touch, because it brings people closer and let them work more efficient.
But now I'm really getting excited, because we have been talking about design, production, engineering, but he promised me to give a milk which was my customized one, and I don't still see that.
Yeah, very good question. Now I will bring you from the virtual world of planning to the real world of production. And to be honest, you're quite demanding in producing your milk-based drink, so he wants to have a special label, a special taste. And to achieve this, we have to synchronize our manufacturing operations with our business processes. And one step is to have a proper scheduling, taking into account the availability of the material, of the equipment, of the employees, and of course, the energy consumption. And you know what? We have a solution for that.
Of course, I'm 200% sure we have a solution for that. But when we talk about scheduling, I think it's also important to know at what efficiency individual lines are operating, because until you know what efficiency, you would not know how to improve that. And with the Siemens technology, you can create a lot of transparency between your production assets. We have those, I would say, technology to measure that. And for sure, what you can do is that you can generate your KPIs, your OEE structure, and we can calculate that, and also relate that with a line balancing algorithm to check your plant before you really go real. So you really know where your bottlenecks are and your overcapacities are, and then you can simulate the whole world before you really go to the real world.
Wow, that's very interesting. That works for one line. A global dairy company, they have many plants distributed all over the world. So how can we do service in terms of data analytics for this?
I was pretty sure you're going to ask me this question, because it's quite a very, not quite, it's really very valid question which is asking. But don't worry. In Siemens, we have this solution very nice and widely made, and all of our viewers might have seen it. It's MindSphere. MindSphere is the platform. It's an industrial IoT platform where you can develop this and you can do a lot of analytics out there. And what questions you're asking me, you can exactly do this in MindSphere.
Yeah, you're absolutely right. MindSphere is a great environment to do data analytics. In fact, we have just developed 2 applications in cooperation with our partner from Atos. The first one is about quality benchmarking. So basically, it's about comparing different sites distributed all over the world in regards of their quality performance. And with the app, you can easily identify which plant is producing in a good quality that satisfies your customer and which one is not. The other application is about performance benchmarking. So especially for filling and packaging lines, it is crucial that they work with a good performance. And with this app, you can get a full transparency how your lines are working. You can compare them, and this helps you to stay competitive in a market like the dairy industry.
Fantastic. this really sounds exciting. But I think it also gives a lot of flexibility to the plant manager because of these apps, because the plant manager can do data analytics. Sorry. The plant manager can do data analytics sitting anywhere in the world because he's using these apps to do data analytics, whether sitting in his office or sitting in his home, because it's a cloud-based solution. So it gives a lot of flexibility for the plant managers to do this. So really, we have seen a really comprehensive portfolio from Siemens, like starting from the product design itself to the services. But to make it a little bit easier for all of us, let's summarize what we have been talking about in the last 10, 12 minutes. Yeah?
Yeah. So digitalization allows a horizontal and a vertical data integration. It fosters the collaboration within your enterprise, and it brings people closer.
Okay. And the second most important thing is it creates your value for the data that you have. I mean, you can collect all the data. You have a lot of data coming up from the plant. But what do you do with the data? You have to analyze the data and create it into real value, right? And it also fosters the relationship between the cross-functional BUs within you. Like, I mean, from the R&D to the production to the warehouse management to the logistics. So they all bring together and you can analyze the data.
Yeah, and finally, the digital twin allows you to simulate everything in the virtual world before you ever commit resources in the real world. And now we are in the real world. I have something real for you. That's a nice orange mango protein drink with a blue label. Very healthy, very fruity. So I think that's the one you've asked for.
Exactly. This is what I was looking for. And I really thank you to make this surprise gift for me. Thank you very much. And what I heard at the beginning of this presentation, that you guys have not tasted your own customized milk. I'm telling you, you're missing something in life. Please visit our booth, which is located in the center, the F&B booth in the Siemens World. It's absolutely in the center. You just can't miss it. And yeah, we are still here. Yeah, if you have any questions, we will be glad to answer them. But for the time being, I really thank you for your kind attention. Thank you very much, guys.
Thank you very much.
And we say thank you, Andreas Zintel. Flavor and bottle, and it's really interesting to see how all this is working together, and
absolutely,
it really is yummy. So thank you.
Thank you.
Yeah.
Thank you.
Straight 4:30. We are live streaming. We are on TV. So we just keep in the schedule, and I mean, without digitalization, nothing, really nothing would be possible nowadays anymore. And sometimes it takes a while until the digitized processes go into life. We need the video. Here we are, ladies and gentlemen. Welcome to our presentation, Digital Enterprise in the Manufacturing Industry. I know what you will be thinking now. Oh no, digitalization again. Well, it's our motto, but
Christine,
still.
I don't like it. I don't like it when you talk negatively about digitalization because, after all, we're living in some really, really exciting times. And you don't look like a woman who wants to live in the past. You look like a woman for now and for the future, right?
Well, of course, I adapt to changes and what's going on, but still, I mean, not everything was bad then. You're right, Magnus. Remember the vinyl when we were listening to the records and the little crackles and the really good sound, and you were sitting there watching the covers, looking at the sleeves. Smell? Well,
yeah,
I
the
don't
smell,
know.
like when you put out a sleeve,
Yeah.
very good. Yeah, I mean, vinyl is going through a revival for good reasons, for sure. Analog music is very nice, but I think you are forgetting all those nights you sat there with rec, pause, and play, trying to rip those albums, putting together a mixtape and the tape for your morning run, listening to it in your Walkman, your Sony Walkman, because taking one of those puppies on your back home for a run wouldn't make a lot of sense, right?
That's true. I mean, and this is when music got digitized,
Right.
and now that's the CDs which came into position.
Exactly, and digitized is a very good word because that's what happened. You take something that's analog and you turn it into digital. That's digitizing. But we're talking about digitalization, somewhat difficult to pronounce, but I'm getting there slowly but surely. So we are in the age of digitalization.
And that's cool to have.
Yeah, but just think about the way you and I and probably the audience are consuming music nowadays with those streaming services that are available everywhere. It's much easier to put together a playlist now because when the CD was there, you still could only listen to one album at the time unless you had a CD changer with those 5 slots. I did not have one, so I'm very happy now.
Me neither.
Yeah, and a bit nerdy though, but if you think of those adaptive algorithms that are analyzing your lifestyle, your way of running, and when you go out on your daily morning run, which I think you do,
Now and then,
now
to
and
the
then.
office.
So those services actually propose music for you, to get that extra bit of energy to get that better time.
But to be honest, I wish my running shoes would have that to push me forward.
You want your shoes to do the running for you.
That'd be cool.
It's lazy, it's cool, but I can look into it. But what we can do though, already today, is actually customize your own running shoes based on your stature, your weight, your running pattern, in the color of your choice, of course.
Oh, which is lovely,
And
yeah.
you get them delivered in the same time frame as you would for a mass-produced part, and of course with a comparable price tag. That's possible.
Well, I'm aware that digitalization brings advantages and it's changing the way we use and buy things. But to be honest, what does that have to do with the manufacturing industry?
It's a huge challenge, but you need to face it. So obviously you need to take products to market as fast as you can. It's been like that for a very long time. You need to offer this ability to be flexible, customized mass production, still producing with quality and take advantage of the resources you got available today and get even more efficient and protect your security.
Stop. Hey, now, this is office talk, Magnus, and I think I leave you here with your topic because I'm just
Okay,
a girl
but
with
you come
shoes.
back later though.
Yeah.
Okay, good. So, I take it from here. I'll go through this a few steps now about digitalization. And let's start with how products are coming to life nowadays. It's probably one of the reasons why you guys are here today and visiting us at the Siemens Monter. If we take the technology that we call generative design, which is combined with topology optimization. Probably doesn't say that much, but it's basically adapting nature's way of constructing organic things like trees and plants and that. So you get very advanced products, very advanced constructions. And if you have those advanced products, you need advanced technology to manufacture those. For example, additive manufacturing, which is kind of printing in steel or in some other material in layers, and you're able to generate those amazing products. You can take a look at that behind you in the additive manufacturing cubicle afterwards. Products and how they evolve has also changed over the last years. Cloud technology, most of you are probably in the cloud, storing data, but it's so much more than just data storage. It's also about analyzing data and feed the insights back in the value chain, so to speak, in the process of development of your product. So if you want to take advantage of this, you need to look into the ideation, the realization, and the utilization phase of your product development process. So to get the most out of this, you need to look at the entire value chain, which goes from product design and all the way to services, and kind of weave a digital thread of information through the entire chain. And then it's transforming, and you may ask yourself, why is this transformation necessary? Well, it's probably the only way to react to those constantly changing products. The complexity goes up the whole time. And apart from that, it also gives you the tools and the means to actually produce faster, shorten cycle times, and of course enable a lot more innovation. And we call this a holistic approach. This is what it looks like. It's enabled by Teamcenter, which sits as a fundament beneath. It's a collaboration platform for data communication. And we need that in order to make data flow from design and all the way to services. And behind it, we got MindSphere, our cloud-based open IoT operating system. And analyzing data, we have the ability to feed that back into the process and constantly optimize it. Another nice thing that happens when you have gotten this far and your steps are all aligned is that this digital twin that you may have heard of is actually available. So what do you need a digital twin for? Well, it's basically a digital environment of the real world in which you can design, test, simulate, optimize, validate, and do pretty much everything you would like to do in the real world without consuming any resources, without building any prototypes, etc. Probably I'm still a bit too theoretical, so I'm going to take the advantage to show this on one of our own products, the Thematic Field PG. PG stands for Programmiergerät, and it's German for laptop. No, it's not. But it's a computer that's very often used in the factory environments to develop PLC code. It's a very sturdy laptop. It can take some good beating, if you like. And this is something you see also at the booth, this PC. So let's say you want to design or develop this type of laptop. Then you could go into our NX system and construct it, basically taking this laptop from the first idea, the first innovation, through the design phase, industrial design, constructing, and do everything you need. All the way from simulation and also to manufacturing planning. Let's look at simulation. A computer like this has got a processor. A processor is working, processor is generating heat. And we want to make sure that not too much heat is being generated within the housing of this laptop. So we're simulating the physical behavior of this processor and this cooling bracket that you have there. If we now realize that it's way too much heat being generated, we need to do something about it. What could you do? Smaller processor? Sure, less performance. Or you simply change the size of the cooling bracket. And since you're working in an associative environment, you basically go back to the engineering phase and you stretch this bracket out and perhaps even add a cooling hole on the side of the panel by simply copying and pasting. And this is made possible thanks to synchronous technology within NX. Simulation of parts is something we've done for a long time, and some of you may have heard that we got a new family member here at Siemens. That's the Mentor Graphics, joined us just recently. And with that, we do also offer solutions for designing and simulating electronic components in product development. And with that, we have created the digital twin of the product. And I'm going to move on into the next stage, the production planning. So we have the data sitting in Teamcenter. So, of course, we'll do the process planning or production planning in the same environment. Basically, merging the product with the resource, with the plant, and the process. And when we have this bill of process, as we call it, we can go ahead and simulate the worker's environment, for example, ergonomic analysis, making sure that our colleagues on the shop floor who are assembling the laptop aren't getting any work-related injuries or fatigue or similar. Or perhaps we get a robot. Then we can use the same environment, but instead of a human, we use a robot, like this dual-arm robot, to do more or less the same type of operation. Simulation can also be done in a bigger scope, a larger scope, let's say an entire facility, in order to discover bottlenecks, scaling the buffer zones, perhaps even discover and analyze how much energy is being consumed inside our factory with energy simulation, and use this information to further optimize our real production. And at this point in time, we probably do also have a few machines and production lines in this environment. And thanks to automated engineering, we can basically take the information from this simulation and push it into our engineering framework, the TIA portal. And with that, we can take it to the next step and do what we call virtual commissioning. So working with a digital twin of our S7 1500 controller, PL System Advanced, a TIA portal, and Process Simulate from Technomatics, we can validate and debug this code digitally, which means that when we want to go for a real production, we basically take this controller with us to the shop floor, the code, and we get a very short commissioning time. And the rest of the engineering is, of course, carried out in our TIA portal, our engineering framework. And thanks to world-leading automation products from Siemens, the production is obviously running smooth and efficient. And with that, we have the digital twin of the production. At this point, we're going to start producing the laptop for real. And at this time, you may also have to optimize this environment. You have orders coming into your factory, and you want to make the best out of those orders and make sure that you're as effective as possible. And this is Simatic IT Preactor that you use for advanced planning and scheduling. To get efficient, to reduce time, to build quality, you may also need work instructions. And this is also something you would get via Simatic IT MES solutions from us. So the picture you see here on the screen with the robot, it's kind of a spin-off product from the production planning phase, because you can add movies, you can add PDFs, pictures in this environment to support the colleagues on the shop floor when they're building this laptop. Quality, also very important. So throughout the entire manufacturing process, you're able to track the quality. So if one of those bullets would go out of bounds, you could be reacting to that, or be proactive even, making sure that the product that leaves the belt is actually already ready to go, and no quality surprises will come your way. When producing products, we produce a lot of data that is of great value, and data we want to use. And with MindSphere, our cloud-based open IoT operating system, you collect and analyze the data and transform it into valuable knowledge and feed it back in the system. So with that, we have our 3 digital twins from the product, the production, and the digital twin of the performance. At this point in time, we start optimizing the whole thing, pushing this know-how back into product development and production planning. And the cool thing is, we're doing this on one integrated data model, Team Center, and that's where all those 3 twins are sitting. So, which allows for all stakeholders involved in the development process always got access to the latest, the release data, and can take that decision that's required to get even more efficient and deliver an even better product. So you may ask yourself, what do we need in order to enable all this? Well, we call it the Digital Enterprise Suite. And this is what I've been talking about the last 10, 12 minutes. Team Center as a collaboration platform. On top of that, you get the product lifecycle management environment for design, simulating, MOM, manufacturing, operation management for communicating this information down to the shop floor, where we got the totally integrated automation portfolio, and behind it all, MindSphere. So with this, you would be able to shorten the time to market, allow for flexible mass production, customized mass production, prove that you are producing quality, take advantage of the resources available for you today and get even more efficient, and at the same time, protect your company from cyber attacks or losing intellectual property. So to become the game changer, you need to be realizing your digital transformation. This is the way forward. The Digital Enterprise Suite will also make the future yours. Christina.
Future ours.
Oh, you know, yeah?
Dear Magnus, yes. Okay, thank you very much. Big hand of applause to you. Very impressive. Room for new perspectives in process automation with the new version of the distributed control system, Simatic PCS7 version 9. This is the title of our next presentation. We can bring digitalization down to the field with Profinet and hardware innovations. What that all is about, and in detail, this will be presented to you by my colleague, the Portfolio Marketing Manager for Automation and Engineering, Manuel Keldenich. Please welcome him up on stage.
Welcome also from my side. I guess you all have heard a lot of digitalization here all over the booth at the Siemens courtyard. And I'm going to talk about digitalization in the process industry and how we can bring digitalization down to the field level, because we're coming from the mind sphere. We have an enterprise asset management system, and we have a DCS, a distributed control system, which is needed to run a process plant, basically. So when I'm talking about this, I think we have to start with the challenges in the process industry. And one challenge is highest availability of the plant, because you can imagine an oil rig, for example, which is producing and producing, and you can generate value or economical benefits only the time that this plant is up and running. If you have a stop of production, this can easily cost you more than 10 million euros each and every day. So availability is key in process industries. Another topic is investment protection, because when you engineer a process plant, you have in mind that the thing that you are engineering right now, this plant, will be up and running for more than 30 years or even longer. So you have to already consider what's coming in the future. And then talking about the plant runtime of more than 30 years, it is clear that this plant cannot run for 30 years and then sometimes it's over. So it has to be modernized, extended from time to time, so at least the data basis is changing each and every day because you have new equipment, etc., etc. But how to overcome these challenges? Guess what? Digitalization is the answer. And I'm talking about digitalization down to the field level. Means where you have all this little equipment like pumps, flow meters, etc. And Profinet, an industrial Ethernet communication standard, is the basis for us that we use to bring digitalization down to the field level. Because Profinet is enabling to communicate nearly in real time. And what's really important for us is, in regard to modernization projects, that it is really flexible. It has scalable architectures and it gives us a lot of opportunity when modernizing a plant, for example. So we have developed new hardware for our new version 9 of the distributed control system, Simatic PCS7. We have a new remote I/O for highest availability. We have a new compact field unit that makes the closing from the control cabinet to the field level. And for sure, we also have some software innovations because we're talking about a completely new version. Starting with our new remote I/O, the Simatic ET200 SPHA. First of all, we reduced its width. Means 50% smaller, and in the end, we can connect much more modules from 12 to 65 right now. That means that within one standard cabinet, we can realize much more I/Os. I/Os are the input-output signals that you need for the communication from the control system down to the field. Another real big benefit to reduce space is that with the integrated terminal blocks, we do not need the MTAs within the field, which are basically needed to transfer and to connect all the cablings, all the wirings down to the field level, but which take a lot of space. So we have a modular structure, we save space, and a lot of cables. We already had our first project that with this approach, with the new remote I/O, we could save up to 60 or 70% of the copper cables that run into the field and come back, which means in the end, this is really a lot of value for our customers. Another use case that I would like to describe is change in run. Due to the redundant Profinet interface, which you can see here with the 2 green lines, we are able to exchange modules in runtime when there's an error occurring without having a downtime. Means shutting down the system and it is not producing anymore for the time the repair needs. So we do not need different equipment or mechanics. We have a push-in technology, so we just take out the module, exchange it to a new one. The error is fixed without downtime. And our customers benefit in this case from the downtime avoided, no risk for errors, etc. A third use case is that we can standardize the control cabinet assembly. Means we have uniform terminal blocks and we have a fixed wiring, so we can standardize the cabinets, save a lot of space, and thus lower the costs for planning, installation, commissioning, and also the time and the effort for the so-called factory acceptance test, which you have to do to make sure that it is working right now, that the things that you have engineered are really working in the field. And in the end, you have a much faster commissioning, troubleshooting, and save enormous time. To sum it up, one topic is that we can also use it in harsh environments in a temperature range of -40 to +70 degrees, which is really beneficial when you think about an oil rig, for example, which is in the Nordic Sea, and where high temperature differences are. It's up to X zone 2. We have a lot more connections that we can provide within the existing space that is limited, and cost savings is obvious. I also mentioned the second hardware innovation based on Profinet, which is our compact field unit. It enables us to realize a completely decentralized approach. What you can see here is that in the field you have a flow meter, which is connected via Profibus PR to our compact field unit, and the compact field unit is connected via Profinet, means industrial Ethernet, to the control cabinet. We can mount it directly in the field, and with this approach, we need less cables, a lot less cables, and plant extensions are much easier because we are not limited to the control room and the space we have for the control room and the control cabinet, etc. We can mount it directly in the field, and it's a box which has just this size, like a card box for shoes, for example. So we have less effort for the installation, for the planning, and for the documentation too. Now showing a short use case on device integration. When, for example, there's an error occurring at the flow meter in the field, we have to exchange it. We take it out, insert a new one, make the wiring from the field device to the compact field unit, and the compact field unit is using the automatic addressing functionalities of Profinet, makes an initialization, and gives a short hint to the software, the control system above. So in the end, we call it plug and produce, which means it's as simple as connecting a printer to your computer. So now we have time savings in regard to this process from more than 1 hour or half an hour minimum nowadays to less than 1 minute in the future. And the benefits are that you have much more flexibility in regard to plant modernization and extension projects. You have enormous time savings and cost savings for sure. Well, I already mentioned it in the beginning. We do not have innovative hardware. We also have improved our software solutions, which are a major part of the distributed control system. One of that is our process device manager, which is needed for the initializing and the integration of process devices into the distributed control system, so that it recognizes that they speak the same language, basically. And with the new version based on Profinet, we can lever the full potential of the CFU because they are talking together, talking with each other. Another solution regarding recipe engineering is mostly important for pharmaceutical or for food and beverage industries, because we can now import recipe data and separate the engineering workflows for equipment modeling and the recipe creation. In the past, it was a joint approach, and now we can separate this and roll it out on different plants from one vendor, so it's much easier. With our Simatic PCS7 maintenance station, we have some opportunities now to really have a vertical data integration from the control room via the control cabinets down to the field level where the field operator is exchanging devices, for example. So the data and the documentation are always consistent and up to date. Last but not least, with our Simatic management console, we provide opportunities to our customers to manage and to have a look at the existing status of their hardware and software installation within the field, manage it, and in combination with our customer support database, we can also give them suggestions how to improve their installed base, use, for example, more energy efficient devices, etc. So our customers benefit basically from better informed decisions. They have less workload. The error potential is much lower than it was before. And they save a lot of time. And what's really important, the documentation is always up to date. Because you can imagine, for example, in the pharmaceutical industry, the legal authorities like the TÜV might ask you for the documentation and you do not have to search for it. You have it there just by press of a button. So you can always ensure regulatory compliance. And all that taking into combination, the Profinet approach, the decentralized approach with our compact field unit and the new remote I/O is why we call it room for new perspectives due to space gatherings and more flexibility. At a glance, we have the more flexibility. We have the usage of Profinet, which is the future also for the process industries. We have enormous cost savings and improve the profitability of our customers with this approach. If you want to learn more about that, please feel free to join us at the courtyard beside or behind, from this point of view, the Digital Enterprise Courtyard, and we are glad to answer your questions on that. Thank you very much, and have a nice evening or a nice day at the Hannover Fair. Thank you.
Thank you very much, Manuel. Ladies and gentlemen, we come to an end here now with the official program because we're having a special event this evening at the booth. So I'm saying thank you for visiting us, for listening to our presentations. We will be back tomorrow at 9:45 with a presentation about our research and development department by Dr. Michael May. And if you have enjoyed the presentations and what we have shown to you, I just can only say, hey, have another look at it. Look in the live stream, which we are running through all day until the end of the week. And you can repeat until Monday what we have shown to you. So on Friday, you can see the program from Tuesday and so on, which is very informative. You can see the visit of the Chancellor, who has been here on Monday and talked to our CEO. Also a very nice little movie clip, which is available on the internet. And you can find it on siemens.com/HM for Hannover Messe 17- live stream. And you will find little videos with all the presentations and what's happening on here. If you want to know more about what's happening tomorrow, we have a brochure. It's right here. I can show you. It's available here. And you just go in here, have a look. Lots of presentations for tomorrow. Again, all day long, 9:45 until 5:45. We will show you what's happening in the Siemens world. Until then, enjoy your stay at the largest booth at the fair. 3,500 square meters of solutions, innovations, and exhibits. Thank you very much for coming here. Enjoy the time and the rest of your day at the fair booth. Thank you. Hey, we're back. Back on stage, back in the Thought Leaders Forum. Welcome, ladies and gentlemen. Don't be shy. Come and visit me in the auditorium. If you belong to the group who has been invited from process industries, you're having a special invitation for tonight's events. This is little Angela Merkel. She was handed out to herself on Monday when she was visiting our fair booth and talked to Joe Kaiser and Klaus Helmrich. And Angela was quite happy with the little 3D version of herself. So that's a nice souvenir from Hanover. I really hope that you also do take along souvenirs from Hanover, because here in the Thought Leaders Forum, we show a lot of presentations with wonderful, precious content, and that should be something you take along with you. The first one who will be presenting here now, this late afternoon, is my colleague from the US, Aaron Frankel, and he will tell you about which benefits digitalization can bring in the additive manufacturing industry. So welcome up on stage, Aaron Frankel.
Thank you. Thank you, everybody, for joining us today. We've got a full house. It's exciting to be here. So today, we're going to talk about additive manufacturing. And here at Siemens, we believe in creating new ways to design and produce products. And we do this by combining the power of additive manufacturing and digitalization to give us that ability to take an idea in our heads and transform it into a digital model that we can then inexpensively manipulate, optimize until it's perfect, and then turn it into atoms. And we do this with 3D printing. I think I might need my clicker. But in order to unleash the power of additive manufacturing, it's absolutely important for us to change the way we think about designs. And this gives us the power to reimagine products and start to unleash new capabilities. It gives us the ability to transform our designs around the functional capabilities of the products. What you're looking at here is a high temperature burner. And you can see a very complicated shape. The purpose of this burner is to essentially burn messy fuels at an extremely hot temperature to extract the hydrogen. But you have to burn it so hot that you can actually melt the metal of this burning tip. So our engineers optimized this design using advanced computer-aided engineering capabilities to be able to create a shape that will stay cool while executing this process of fuel refinement. Another way where we can take advantage of additive manufacturing is to optimize our designs for performance. And in this particular example, we're looking at a lever from an aerospace example. This lever is actually at the tail of the aircraft. It's used to connect the actuation of the pilot's joystick to the elevators on the back to control its pitch. And what we've done here is we've leveraged generative design capabilities where we, as a designer, tell the system what kind of performance we're looking to get out of this design, and then let this computer generate an optimized shape to achieve those goals. And the computer came up with a very interesting shape that's not only just as strong as the conventionally manufactured part, which is cut out of a block of metal, but is 15% lighter. Now, you couldn't make this geometry using conventional methods. Additive manufacturing unlocks this power. Another example of the way we have to change the way we think about additive manufacturing is to think about designing individualized components, components that are mass customized. And the reason why additive manufacturing is important in this area because it gives us an economical way of being able to produce these types of parts. We don't have to invest in expensive tooling in order to create very complicated shapes. We can turn our designs directly into atoms. But not only do we need to change the way we think about designing these parts, we need to begin to incorporate the additive manufacturing technologies into our production environment. We need to retool our manufacturing. And there's some interesting technologies that Siemens believes the industry can use to deliver completely new types of product designs. And those technologies are listed here. And I'd like to kind of run through a couple of examples for you. This first part was created using the powder bed fusion capability. Essentially what it does is you take a very fine laser beam and control it to melt a very fine powder and grow the part in one direction. And what's interesting about this technology is that it lets you create very intricate details that you would not be able to make using conventional approaches. Notice all the very fine detail on the interior of this part. This is that gas burner that I talked about earlier. And in fact, this design was optimized around, was actually created with inspiration from a vegetable, from fennel, from a fennel bulb, was used to do this. So you couldn't make this using conventional approaches. Another technology that we find very interesting that we're focusing on is called jetting. And jetting essentially is a technology that HP is pioneering to be able to take a chemical agent and drop it on material powder and then use heat and light to solidify that material into a shape. And what's interesting about this technology is it was used to create this gear and essentially allows us to scale up volume production of printed parts to the point where it is becoming economical to produce high volumes of pieces. HP's calculated that with their first version of this printer, they're able to print 55,000 of these gears as economically as you would using an injection molding process, which I think is quite impressive. Another technology is directed energy deposition. This is where you take a nozzle that's equipped with the ability to blow metal powder and then sinter the metal powder using a laser beam equipped to that nozzle. And what's interesting about this capability is it allows us to unlock the ability to use a combination of manufacturing technologies on a same machine. We call it hybrid manufacturing, but essentially the ability to do additive manufacturing as well as CNC machining on the same machine tool. DMG Mori is pioneering this approach, and we've partnered with DMG Mori to be able to unlock its capability. So this is stainless steel that has been 3D printed, and you can see this very mirror-like area where a CNC cutting tool was used to machine it to a high surface finish and tolerance all on the same machine. And then last, I'd like to show you an example of material extrusion. This is essentially a composite part that was printed using a material extrusion head connected to a robot controlled by a Siemens controller. And what we've done here is we've automated the ability to produce composite parts. And because we've done it on a robot, we're able to take 3D printing out of the small box or print volume we normally make parts and begin to scale it in size, where we can begin to print very large parts. And this is significant because these composite parts can replace metal parts, and they're much lighter. So after we're able to kind of change our mindset and begin to design parts for additive manufacturing, and we're able to take advantage of these types of technologies in the production environment, we can begin to rethink our business. And this gives us the opportunity to, say, print on demand, create parts on demand. We no longer have to rely on mass production, but we can print exactly what we need, exactly where we need it. And this enables us to unlock the power of, say, digital inventory. We no longer have to store a large inventory of physical parts. Not only can we individualize and customize, but when we start to take advantage of additive manufacturing, we can accelerate our innovation cycles because we no longer depend on long lead tooling items, castings, for example, or injection molds. We can produce exactly what we need when we need it. But in order to take advantage of these capabilities in an industrial environment, we need to have the right tools. And the problem is that many of today's tools and systems that would be used to create these parts are disconnected. There's a disconnected software chain and a disconnected hardware chain. And when you have disconnects, you start to lose control of the workflow. You have to convert data and information between the different applications. And this is what can prevent us from taking this technology into the production environment. And so our big idea is to add tools to the digital enterprise suite to help us industrialize additive manufacturing. What we're doing is in the PLM environment, we've added new design tools to enable designers to create very organic, topology-optimized shapes that are lighter in weight and just as strong. We've added the ability to be able to simulate these designs so we know exactly how they're going to perform after we make them. We also are adding tools to be able to simulate how the production or the printing process is going to work. So now when we create our plan to be able to print them, we know that we'll achieve the desired geometry we're looking to get. And we've added the tools to be able to design the print preparation process, to be able to deliver the work instructions or the instructions and the data to the machines in order to create these parts. But we also need integrated tools and equipment on the production side, which is why we're investing in our totally integrated automation portfolio to be able to connect hardware for 3D printing directly into our mainstream production environment. We have the automation, the drive capability to be able to drive the individual machines by providing these pieces of equipment into the control cabinet. And we're able to connect these machines into our production environment, so we're able to deliver information to the machine, pull information off of the machine, and use that to optimize our design and our engineering processes. And then lastly, you need to be able to control production. You need to be able to manage your orders, manage your schedule. And our manufacturing operations management suite delivers these capabilities. So I'd just like to end on, we recognize that we're embarking into a new frontier with additive manufacturing. There is a lot to learn. And in order to be successful and to industrialize this capability, companies need to be able to work together in an ecosystem and share information, share knowledge and expertise. And so what we've built, or we're building, is a platform for part manufacturing where we can connect together people who have designs that they would like to optimize for 3D printing with experts that have know-how to be able to help design those parts, with machine tool OEMs and printer OEM companies who can provide guidance on how to best unlock the capabilities of their systems, with institutes, communities of engineers, and co-innovate together. So with that, if you have any questions or would like to see some more examples and see some of the software in action, I would welcome you to come take a look over here at our additive manufacturing cube, and we'd be happy to talk with you more about it. Thank you for joining us today. Please don't step on each other on your way out. I know it's going to be kind of crowded. Just be careful when you go down the steps. But anyways, thank you all for attending. I appreciate it.
Coming up now, digitalization. That's the key word for our presentations here at the Thought Leaders Forum and at the booth. I mean, discover the value of the digital enterprise. That's the motto of this year's presentation at the fair in Hannover. And we have lots of digitalization topics, and one of them is to boost productivity and efficiency in process industries with digitalization. And for this, I call up my colleague Petra Geis.
Hello, Christine.
Hi, Petra. How are you?
Better when the day's over.
It's an exhausting day, but it's already Wednesday.
Yes.
So it's the third day in a row where you have been presenting up here.
It was exciting. It was really exciting to be
And I
here.
mean, the booth is super crowded all day long, so I guess you have been talking to a lot of customers.
We do have, really. And that's good news.
Good news. That's great to hear. That's great to hear. So, digitalization, one more time, one of the buzzwords.
Yeah.
What does it have to do with process automation?
Yeah, you see, you have a glass of water here, yeah? How do you think does the water comes into your tap to get it?
Open the tap, put the glass underneath, close the tap, drink your water.
Would be good if it would be so easy. There are a lot of processes behind to clean the water, to purify it, and so on. And of course, our customers want to do it efficient way. Yeah.
And digitalization is the keyword in this?
Absolutely. So we show possibilities to them how they can it more efficient and boost their productivity.
So I'm really excited now what the digitalization topic is in general, and I'm curious to hear about that.
Thank you, Christine. So digitalization not only affects our daily life, but digitalization also affects process industries especially. So let's first talk about the major issues, the major challenges in the process industry here. Yeah? So major topics are very long periods from the first product idea until the product launch comes into the market. Yeah? Another challenge is also the commissioning. Commissioning is a very critical phase because if there something happens unexpected, your plan and your costs can completely run out of time and everything. Yeah. So also during the operations phase, it's pretty important to avoid downtimes. Yeah? High costs by downtimes, especially by unplanned downtimes, of course. And last but not least, it's necessary to have a good transparency about the product and the plant and the process itself. So our solution for this is from integrated engineering to integrated operations, as we told it. What's that? It's a complete tool set that helps you exactly for these topics. It helps you to shorten your time to market, to make your operations more efficient, and boost your productivity and increase efficiency. All this. Let me just show it during the life cycle of a plant. Let's start with the engineering phase. Engineering phase, we have our tool called Comos. With Comos, all different disciplines, they engineer on the same data hub. So process engineering, piping, automation, electrical engineering, everything. And no matter where the engineers are located or different companies working, they're all working on the same platform. And of course, if one of those companies changes any value, all other disciplines have this value immediately at hand. So this helps you to do processes in engineering phase, not sequential after another, but to do them more in parallel. That means, of course, you save time during engineering, and of course, you also have a better data quality because there is no manual data transfer or no transfer at all from one discipline to another. So consistent data. The next step then is the engineering of the automation. As we have already some automation data in our data hub, we can just put this data in our automation system and automatically the DCS hardware software will be built up in the PCS7. So this also helps to make it much faster, so the automation engineer will be much faster ready with his engineering work. So all this together, we have all the data of the plant and the processes now together in a data hub, and this is what we call our digital twin. So the digital twin is now existing, engineering is completed, but our real plant is still under construction. So usually this is a kind of a lost time, isn't it? No? So this may take several months until the plant is ready for commissioning. So we want to use this time in a clever way with our digital twin. So first thing, we prepare a 3D visualization of our plant. So we can virtually walk through our plant. Also, it's not existing yet. Yeah? So this helps us, first thing, to check if all the critical assets that need some maintenance from time to time can be accessed easily. And second, I can train my service staff for this. Yes? So they can already get familiar with the plant. And as soon as the plant is ready, my staff is trained and can start directly with the work. Another thing that we can do during this phase is to check if we have errors in our engineering. You know, typically there are errors, and sometimes, unfortunately, many errors. So let's do a simulation of all the automation function during this time and check all the functionalities. Oops. So with simulation framework, we can do this. And this helps us to find these errors in advance. And we have enough time to eliminate these errors. And of course, this helps us when it comes to the real commissioning. For the real commissioning, it will be much faster, much safer. So a lot of time saving also in this phase. So you see, we have shortened time to market by saving engineering time and saving time for the commissioning. Now you might say, yeah, it's nice such a digital twin to have, but it's only for greenfield plants. On your right, this kind is for greenfield plants. But I have good news for you if you have a running plant. We also can create a digital twin for running plants, existing plants. You just take photos of your plant. For instance, with a drone, you fly around your plant and take pictures, and can also do it with a smartphone. Put these pictures with our partner Bentley Context Capture into a 3D version of the plant, and then you also can use this simulation. You have also a virtual 3D of your plant that you can walk through. Yes? So this is also a possibility to make it better. And of course, it helps you for planning your modernization in future, and it also helps you for training, for your continuous training of the staff. Now, let's come to the next phase. It's the operation phase, or in general, the operation phase, where you also can profit with a digital twin. Let's say we are watching a pump, and first thing, of course, is we want to check all the data of this pump to see the health of the pump. Yeah? So I can have predictive maintenance already to maintain it before something happens to this pump. But if something happens, or if now maintenance is really needed, I also have the possibility to make this much faster than until now. So if something happens in our PCS7 control automation system, we get the information, pump XYZ, something is wrong. The operator gives this information directly from the PCS7 system to the service system called Comos MRO. So the service guy gets this information, okay, please check pump ABC. With one click, he goes into the digital twin in Comos and gets all the information about this pump. He said, okay, this is the type of the pump, technical data, manuals, instructions, spare part lists, whatever. Everything's possible here. Yeah? So he gets all the information immediately. And let's imagine it's a huge plant. Maybe there are 500 pumps in this plant. So how to find my pump ABC? So it's just another click away with Comos Walk Inside into the virtual plant, and you will be directly navigated to this pump that needs maintenance. So it's just about 5 seconds. The service guy has all the information he needs to do his job. And he, not only from his desk, all this information is also available on mobiles. Yeah? So he can access all the digital twin data also with a mobile and do it on the fly during his daily work. So of course, this helps to get all the maintenance work done much faster in this way. And repair, of course. So now, as we have done, let's say we have changed the pump. We have changed the pump ABC into the pump XYZ. And maybe we have also did some other changes. We have changed the sensor here or added a part of the plant here. So what happens? My original plans of the pump have nothing to do with my documentation. After a few years, plant and documentation often is very different. Or honestly, is your plant documentation always up to date? So it's pretty cost intensive to do so. But of course, several industries like pharmaceutical industry, food and beverage and so on, they must update their document according to the regulations. So also here helps our digital twin because the service guy can do these changes directly on his mobile, said, okay, I changed the pump ABC to XYZ, and this is automatically updated, the digital twin, and then also the complete documents are up to date. In any plants where the pump, you see the pump in the electrical or in the piping or wherever, the new pump is in there. So everything is as is. Not as built originally 5 years ago, but as it is now. So also quite a help for those who need up-to-date documentation. So last but not least, the point data transparency or process transparency. We have a nice tool called XHQ that's especially also designed for management decisions. Yeah? It gives you the complete transparency about plant data, process data, but also business data. So you can also access purchasing data, for instance, or stock market data, everything, all the data you need to make your decision. You can create your individual chart and see this. Now you might say, that's nothing new, okay? I get my monthly report and I have this data. But here you don't have to wait on your monthly report because all these data are in real time available. So at any time you look on your chart, you have the real-time data of stock market, of your process, of your plant, and can make your fast decisions based on facts and figures. So what I've told you now is our tool set from integrated engineering to integrated operation. But to make a complete digital enterprise, you need more, or there are some basics. First thing is you need industrial communication. So you need to do data, yes? You need to have them. So you need communication to bring the data from the field to your automation, to your management system, wherever it's needed. Second thing is, of course, industrial security. You have to protect your data. You have to avoid cyber attacks, for instance, but also access control, for instance. These are things. And last but not least, industrial services. They help you to improve your business. They analyze your data. They can help you to improve your maintenance issues or your service issues everywhere or everything else. We have a lot of apps, for instance, that can help you here in this way. So all this together helps you to create your digital enterprise. And we are happy to show it also in live at our booth later on. So be welcomed and don't hesitate to ask me and my colleagues for more information and for the live demo. Thank you.
Only gentlemen around me here. Welcome to the Siemens booth. Officially, we close the program now, and I'm looking into the camera because it's over now. We call it a day, Wednesday, day 3 at the Hannover Fair in the Thought Leaders Forum. Thank you very much for watching. See you tomorrow at 9:45. We're back with a great presentation on our research and development department within Siemens Corporate Technologies. Bye-bye. Well, and now I'm here back with you guys. Welcome to Siemens for our process industries.
Thank you.